Good morning, everyone. I hope you're all good. Let me just share this quickly and make sure that we're actually live. Yep, looks good. All good, all good. Right, so we're going to do a very long stream today. I'm just going to dive into it immediately. Basically, I'm going to live stream all the prep that I would usually do. So when I usually live stream at like 2. Oh, I haven't got the chat up yet. I'm usually doing a bunch of like reading and stuff like that, but today I thought, you know what? I want to do more than I usually do. Which means, guys, there's going to be a bit of a downtime when it comes to this. We're not going to be doing the most exciting stuff all the time. We might be reading, we might be studying. Hello, Alex Codes. So there's a lot of things I might do. There's also because the stream's going to go on for so long today, there's going to be a lot more stuff that's going to be happening, in the sense that it's going to be like, if I'm going to read a PDF, for example, to do some studying, which I usually do at the beginning of the day, which is what we're going to break into initially. We're going to do the studying. We're just going to try and grind out as much as I can. The goal of this live stream, at least at the very least, is to hold myself accountable all day. I want to do more than one, so this hopefully isn't just a one-off. So yeah, it's going to be a bit of a different stream. So the first few hours are going to be studying. I will read out loud, so it's not just me just reading nothing, or just in silence. But yeah, so I'm just going to dive into it. So all the prep that I usually do is going to be live streamed as well. The goal of this live stream, and these live streams coming up at least, let me get my toggle track up, is to work harder than I have. I want to have the most hard working week that I've ever had. Because I'm going to say I've been dropping the ball a bit. You know, I've been working like 3 hours, and then yesterday I only worked for 42 minutes, which isn't acceptable. So what we're going to do is just going to grind out some stuff. So the first thing I usually do in a day is I have Obsidian, which is a note-taking piece of software, and I usually just kind of do revision based on some notes I've already taken. So if you're unfamiliar with this, it just allows me to connect similar notes to other notes. So for example, this is Vulkan stuff. Then I like, okay, what is a fence? And a fence connects to other things that I can read and get better and do a bit of revision. Each of these nodes are to do with a different topic. So yeah, let's just dive into it. That's what we're going to be doing for like an hour-ish. Yeah, is that running? And also I'm just going to randomize this playlist. We're going to have to battle the playlist throughout the whole day. Well, that's chill. Anyway, yeah, so like here we go. What are wait idle operations? These are the heaviest of all synchronization methods. Yeah, it's pretty intense. It's just because everything connects to everything else effectively. It's pretty useful though. We can just like navigate basically via like Wikipedia, for example. This is like a Wikipedia link to something else. Anyway, let's get into it, dudes. Yeah, so here's the other thing. I do expect that at some point there's going to be like 0 viewers or whatever. I'm going to talk about this just a little bit more. I don't expect because we're going to be live streaming for a long time and pretty consistently. There's going to be like air quotes boring parts of the live stream, but I want to like do it regardless, because I want to be outcome independent. I want my efforts to be, you know, even if, for example, I have live stream number 3, I'm 4 hours in, I don't want to keep going. No one's watching. No one will care if I stop streaming. I want to keep going anyway, you know what I mean? I want to work as hard as something like this is a bit toxic, you know, as hard as Pirate Software says he does, you know what I'm saying? Like, that's what I want to do, right? You know? Yeah. Yeah, so anyway, so if I just couch all that, so some of the stuff will be a bit underwhelming, but yeah, this hopefully will be like a nice radio show you can stick on in the background while you go about your day and stuff like that. Yeah, you need a ferret for that. There we go. Yeah, it's a little toxic, that I have to admit, but here we are. Let's dive into it, boys. Okay, so what are wait idle operations? These are the heaviest of all synchronization methods, wait idle operations. This starts like anything else with a queue wait submit command. Then these device starts working through the batch of commands, okay, and uses an appropriate queue to handle these commands. Once the commands have finished, the queues go, yeah, okay, so it goes to a queue. So we can do a queue wait idle, yeah. We can wait on these going idle. Okay, cool. You can also wait for the entire device with a similar command, but you're waiting for all the work to finish on the device. Yes, cool. These are used to wait on the host side for the device to finish. Fantastic. Okay. What else? What should we do actually? Let's do it via index instead of via this network node, because it is nice just to randomly click on stuff, but sometimes you do need a bit more order. So this is like the index of everything. Page of content. Right. Let's just look at buffer device address stuff. Because this is what we're going to be battling with today anyway. So make sure we get this done. If you have a standard buffer device address, buffer, okay, so I need to change this a little bit because the way I talk about this is incorrect. So buffer device addresses themselves aren't necessarily, but a buffer device address is a way you access a VK buffer. There is no difference between a buffer. So I need to kind of tell myself that so I stop saying the wrong thing, because I've been saying the wrong thing on stream over and over again. Where should I put this though? That's the question. Okay, so let's put it here. Buffer device address itself isn't a new type of buffer. It's just the way you access the buffer. You can access the buffer, a buffer, in more than one way. So calling it a buffer device address buffer makes no sense. Alright, cool. Yeah, because it's important that you, as an engineer, you're accurate with the way you speak. So when you're communicating your ideas to other engineers, that they understand what you're saying. Even if you're conceptually doing things correctly, if you call it something wrong, you end up in a bad position. Okay, so you have your standard device address buffer. So a VK buffer that is accessed via a buffer device address, and you're updating the data on the CPU. This needs to be host visible and coherent. When you update the data within a buffer device address, it's CPU visible and coherent. You simply update it with something like this. Okay, so we have a struct. Okay, so we have 2 frames in flight. Okay, so this is just telling me that I need to update things. So for a CPU buffer like this that we update every single frame, in theory, this isn't just for buffer device addresses themselves. Sorry, buffer device address accessed, but VK buffers that are accessed with a buffer device address. This is true for any type of buffer. So I think I need to kind of like have a important. So yeah, this is like the first thing I do every single day. Well, I go to the gym first, so I've already done that. But after that, then I do this kind of revision. Then I'll do some studying. Then I'll do some programming. That's like the general idea. I also wasn't sure exactly what we're going to be doing today. I know I want to do gameplay code, but we might end up doing something completely different. Because I haven't even planned. Like, planning is part of the process, right? So we're going to actually plan live on stream as well. So, right, so important. So we have, this is true for any type of, of VK buffer if it's CPU coherent and visible. So CPU coherent visible buffers. Okay, so CPU, these need to be updated frames in flight. Okay. Okie dokie. Bit of revision there. Done. Okay, so when you update... Okay, so yeah, that's just an example of how you do it. Yeah, because it doesn't really matter. So we just have like some arbitrary data that we end up getting filled. There are two things to be aware of here. The VK copy memory to allocation needs to be the destination pointer. Oh yeah, okay. In these second arguments. And that, yeah, okay, so that can't be null. Early today? Yes, we're going early and we're going all the way to the end, so we should be streaming all day. The most important thing here, though, so we're doing a revision initially. So I was streaming all the prep that I would usually do. So yeah, feel free to stick me on in the background while you go about your business. I'm aware this won't be as interesting, but I want to work hard today, so and keep myself accountable. This is why we're here, getting after it. The most important thing here, though, is to reuse the same pointer. That points to the, oh, okay, yeah. So it creates the bindless buffer. Yeah, you can't. I think this may be true for both. You cannot make, yeah, a new piece of memory and update the CPU that corrupts the memory in strange ways. So that what that's telling us there is, if you have a VK buffer and you're trying to update it on the CPU, sorry, on the GPU, you can't make a new struct or a new piece of or a data that contains that whatever, you know, whatever, you know, this is the container, right? You can't make a new array in this case. This is just an array to then upload that to the GPU. The reason that you can't do that, I don't exactly know the spec, but there's obviously something I do not know about the spec that tells you. I had weird data corruption when I did this, and I think it's because, here's my thought, right? Everything is kind of tied to this like allocator, and when I start uploading like a new container, I believe we might look into this, but like the allocator itself is not tied to the memory that we're uploading. If we make a new if we make a new array on the fly, so it's something like that. So yeah, be careful of that, guys. If you ever actually do this kind of VMA copy to allocation, you have to reuse that pointer that was initially used to create the buffer that you end up using. Yeah, so some of the stuff obviously is, yeah, that's also for myself, by the way. Also note that this is a CPU updated buffer. You need to update things like this. Yes, current frames of flight to avoid race conditions, which is why you have two. Because the CPU and the GPU have, you don't want them accessing, reading and writing from the same buffer at the same time, because we have no idea when the CPU will be reading from it and the CPU will be writing to it. So yeah, be very aware of that. You need to. Alright, so let's go through all of our synchronization notes again, because this is always one of the hardest parts. Vulkan command categories. When we are talking about synchronization, we are concerned with action commands and what order they execute in. What order they execute on the GPU. Yes, that's fine. We use synchronization commands to do that. The state commands are not affected by synchronization as they change the state of the command buffer itself while recording. Binding and setting up dynamic parts of the pipeline are examples of of state commands. Right, okay, so here is a short list of the different commands. So we have, I'm just going to kind of draw, indexed, indirect, draw mesh, clear. Yo, E indeed. Synchronization, yes. For some reason that's the British way of spelling synchronization. We put Z instead of S and basically all the words that have jeune at the end. Don't know. So yeah, synchronization. Dispatch, indirect. So we have track, trace ray, indirect. We have copy buffer image. Okay, yeah, so the two different ways. So these are the action commands. So yeah, that's important to note that there's a lot more that I don't know. I don't know how to do things very, very well with this kind of stuff. Anyway, each subcategory in this list is used to get work done. Yeah, so that's the synchronization. I won't go through these, but yeah, it's pretty straightforward. So we have pipeline, set, event, wait event, begin, render pass, end render pass. I assume dynamic. If it's begin and end render pass, I think dynamic rendering are also the same. They must be synchronization commands. Let's look that up actually. Where did I put that actually? So synchronization commands. So hang on. VK dynamic. Oh, it's in the wrong. It'll be here. VK dynamic. Where's the dynamic rendering? Yeah, it'll be here somewhere. So it's not as big, so I can just scroll through the class. That'll be a nice reminder because I barely use this. Okay, so here we are. Yeah, VK begin rendering, that's the actual command. Let's go and see. I think it's synchronization command. Does it tell us in the documentation? Yeah, it changes the state at the very least. It's not an action command. Yeah. And which to record to. So it's telling us what we're going to record to. So yeah, at the very least it's a state command. It's not a draw command. Yeah, okay, so it just sets up the state. I'm not entirely sure if it is a synchronization command. Is it synchronization? Right, let's just Google it. Is this a... Yeah. Look, I'm typing it the American way. Right, I'm going to ignore the AI because the AI is completely useless. Is it synchro? I just want to have it so I can add it to the list. But I think it is. If or is it just a state change? Do you have a good grasp of pipeline barriers? Still kind of struggling to understand the parameters of VK pipeline barriers and how to use them in many parameters. Yeah. Sounds good. Hello, Mado. Yes, how about if you stick around for this live stream, in the beginning part at least. What we'll do, I'll go through my notes and we can hopefully discuss between us the pipeline barriers stuff, and maybe because I'm about to go through that. This is part of my notes, so I'm going to go from top to bottom on this, and maybe that can help you out. So implicit synchronization guarantees. So this is like the first thing you should know if you don't already know. So implicit synchronization guarantees. When talking about synchronization between commands, it's important to note that Vulkan has implicit synchronization guarantees. This means that commands recorded to the command buffer and submitted to the VK QSubmit ordering matters. So order matters, I should say. Order matters. So that tells us that it is important that the order. Vulkan expects the order of your commands to be correct. So, sorry, to make sense. So let's synchronize the queue. Basic synchronization queue. Yes, I am doing dynamic rendering. I didn't do for a long time. So the Vulkan queue. The synchronization of queues in Vulkan is basically the same as one queue. A queue is just an abstraction of Vulkan blasting through the commands. Yep, okay, so command buffers, misconceptions. All commands are global to the queue, are global to a queue, so synchronization to anything within the queue is global to all commands. So that's a good thing to remember. That's like a prerequisite to understanding VK pipeline barriers. Everything's global to a particular queue that you do for synchronization. Anyway, so next, VK command overlap. When you're recording commands to a command buffer, the order is important and preserved because of implicit synchronization. Command guarantees. The execution of commands in a queue is just a stream of commands from start to finish. Commands will fire off one after another, but in sequence, but end out of order. This means that the actual execution of commands is out of order, because starting a command isn't the same as executing a command. The graphics driver may overlap commands like VK draw and VK dispatch action commands. This is where you might need a barrier if VK dispatch is dependent on VK draw. But remember, all action commands will finish executing at a specific unspecified time, meaning that you'll likely need memory barriers anyway. So yes, I think I'm trying to, in a roundabout way, saying in that paragraph that the graphics driver will overlap commands, and you basically need barriers. But it's also true that you'll get undefined behavior, maybe. That means that the graphics driver's accidentally got everything correct. Frame buffer operations inside the render pass happen in order within an execution. So yeah, that's if you're using render passes, that's good to know. Okay, so let's go with each. I think we did this earlier, so we don't need to do that again. What are fences? So we're going through all synchronization primitives. So we've got to do fences. And we did wait idle operations. Okay, so what are fences? Fences are similar to wait idle operations, but allow finer control over. Yeah, so for the people who are tuning in, because I'm going to be streaming for a long time today, all the prep that I would usually do in a given day, I'm just going to stream all of it, which includes the revision. So I usually do revision, then I'll do some studying. So then we'll look up some stuff together and like make some new notes, and then I'll start coding at an unspecified time. I go off vibes, but I haven't done a revision in a minute, so so that's why we're talking about like synchronization. It's not like I need to know synchronization, it's just I need to constantly revise this stuff, otherwise I'll start forgetting it. Anyway, so fences are similar to wait idle operations, but allow finer control over how we are waiting. This starts like anything else with a VK QSubmit command. Then the device starts working through the batch of commands and uses an appropriate queue to handle these commands. Fences are signaled after a batch of work has finished, okay? Meaning that it's important to consider the batches you're signaling, so you're sending to the VK queue submit. So if you have a queue with more than one batch, the fence signal state is dependent mostly, capital letters, on these commands in that batch. Yeah, because there's a specific rule here that kind of makes this complicated. The typical case is if you have command 1, 2, and 3 in a batch, and command X, which isn't in the batch, that runs after, which is important, the batch of commands. Even if command X isn't finished, the fence will be signaled if command 1, 2 are finished. So it doesn't, yeah, if this is like in the middle of something, we'll then signal if it's waiting on this command, then it'll have to wait for it on a particular point. Actually, that's a lie. I don't know if it's on a particular point. Anyway, it's important to note that there is an execution to, there is an exception to this fence batch rule. If you have a command that isn't in the queue but runs before, which is this is the caveat, the batch, and that command takes longer than all the other commands in that batch, then the fence will be signaled when the slow command has finished, not when the commands in that group have finished. So that's the important thing. So if there's like a slow command not in that batch of work that you've decided to fence up, that's taking 2 times as long, you'll have to wait for that above. So this is this is what the spec says about this. The fence signal operations are defined by QSubmit. Additionally, include the first synchronization scope, all commands that occur earlier in the submission order. Okay, so when we talk about first synchronization scope, oh, did I say submission order? First synchronization scope, sorry. All commands that occur earlier in the submission order. When we talk about first synchronization scope, we are talking about all commands before the commands in the fence. Sorry, we talk about all the commands before the fence in the queue. The only thing in the second synchronization scope is the fence operation itself and builds up an execution dependency. So yeah, if you remember that all synchronization operations are global to the queue, you know, it doesn't matter if you've decided to fence off a particular set of commands, it's global to everything in that queue. So that's effectively the special rule with the synchronization scope idea. Which is why we can put a fence right at the beginning of the frame, and regardless of what that is when we wait for that guy, all the work should be done at that point, which is done in my code, which I think anyone's done this who's written a Vulkan application, so it's not exactly like confusing. But this is, say, new frame. This is why we can just stick this right here. Like, it doesn't matter what's happened. Because all the commands that happened before this, let's just say we're on frame like 2, will have to be finished because because they'll be part of the first synchronization scope rather than the second, which is this fence itself. Anyway, so the 2 scopes build up an execution dependency between command batches, which typically states that the first scope must finish before the second, which is pretty straightforward. The scopes aren't exclusive to fences. First and second synchronization scope execution dependencies are how Vulkan works with everything. There you go. Avoid fences if you can, because the CPU will just wait until it gets a signal from the fence, which isn't useful. You always need to reset the fence manually. Okay, so let's read Mado. So what I recommend is to delete your graphics pipeline and rebuild it again. The second time I rebuild my graphics pipeline, I understood more. Making a new pipeline will teach you how to make this. Yeah, that makes sense. If you're gonna do that for practice, for sure. Okay, so we did fences. Semaphores next. Semaphores. Semaphores are used to order commands within a queue and synchronize different queues together, which is really what they're used for in my case. Well, when I talk about queues, there's only one queue, but they're kind of ordered together. Anyway, there is also functions outside of the command synchronization that need semaphores. Okay, there are two types of semaphore binaries in timeline. Two types of semaphore binary and timeline. Timeline are called in 1.2 and needs extensions to get working in earlier versions. Binary semaphores are the simplest and require less setup, but can do less, which makes sense. Semaphores are different to barriers because they are interested in setting up barriers between groups of action commands rather than individual commands on the GPU. A binary semaphore can either be unsignaled or signaled. It begins unsignaled. The semaphore works as an I just realized about like synchronization. No, whatever. As an synchronization command in the queue that signals the semaphores when the command is complete. Another command will wait on the semaphore until it is signaled and then go on and do its work. Once the command has started, the semaphore goes back to unsignaled state. Yeah, pretty much straightforward. If you have a batch of draw commands, for example, the batch can wait on a semaphore before executing after submitting to a VK submit. Yes, I can turn down the music. Thank you for asking me. Yeah, I will put it there. Let's do this. Oh, how's that? Yeah, let me know if that's good. Thank you for Mado. Thank you for I can't, like I said, I can't hear the stream, so yes, very much appreciated. Okay, so as we are waiting for a batch command after a VK submit, we are waiting on a device, not the host. A fence does the same thing but waits on the host side, not on the device. So the fence, so with a fence, we are waiting for a signal to arrive after the batch of work has been completed on a device. A perfect time to use a semaphore is when you have a batch of commands in a queue that needs to be executed after. I'm glad I got it right. Thank you. Yeah, thanks again. To execute it after each other. Okay, so in this example, we have one queue signal. It signals a semaphore, and a second queue waits on it. You can think about that in the example above. That one queue is a graphics queue where all the work is done on the GPU. All the work on the GPU is done, and the second is the presentation queue, where everything needs to be presented to the screen. So yeah, graphics, signal, wait, presentation. Very good, very good. Okay, so now we're going to get to the nitty-gritty of synchronization when it comes to barriers, but we have to talk about implicit memory guarantees when waiting for a semaphore. So this is the final thing. Signaling a semaphore makes all memory available. Okay, so this is going to talk about, memory guarantees, which is important. Waiting for a semaphore makes memory visible. So signaling a semaphore makes it available. Waiting for a semaphore makes it visible. This basically means if you're ordering your synchronization commands with semaphores, you won't need memory barriers, as it does the transition for you. If you need a pair of signal/wait semaphores, signal/wait if you need, if you have, well, I'm reading that wrong. If you have a pair of signal/wait, yeah, I think we still need semaphores in here. Semaphores, they operate as full memory barriers. For example, if you have one queue that is one write, that one writes to an SSBO in a compute shader, and that data gets consumed in a UBO in a fragment shader in Q2, you can set up semaphores between these queues. In these queues, if they are queue family concurrent. So Q1 may look like this, which is just a VK dispatch. So we signal the semaphore here. Note here we are not doing. Note here we don't need a pipeline barrier. Signaling the semaphore waits for all commands and writes this dispatch memory to be made available before the semaphore is actually signaled. There we go. Q2 may look like this. VK begin render pass. We'll just say render pass. Draw and render pass, and then we go. Okay, so we're about to submit this. My semaphore will wait for that guy, and the destination wait. What we're waiting on is the fragment shader. When we wait for a semaphore, we specify which stages should be waited on. On something like that. So we should wait on the semaphore. In our case, the fragment shader stage. The semaphore takes care of moving the memory layout safely to what we need, which would be a uniform. So yeah, so effectively, if we need a uniform read bit, then it'll transition out for us based on our. So confusing. Vulkan gives me migraines, but it's always good to revise and revisit definitions. Yeah, it is. Yeah, so this effectively just does the memory. All this, I can sum this up very, very simply if just to give it some broad strokes for people. You don't have to worry about transitioning the memory from the L2 to the L1 cache or the L1 cache to the L2 cache. If you use semaphores, that will transition the memory. The graphics driver will know what type of memory transition it needs to happen. So if we need to be uniform read bits, for example, that will do the transition for you. For the fragment shader stage, for example, in this example. Yeah, so you don't need to do this, and you can do this. And when you wait between queues, when you have a semaphore between queues, this is all good. You're all chilling. Okay, so let's get into the pipeline barriers. What are pipeline barriers? Which is the lowest level synchronization. The whole point of these is to stop overlapping resources / memories from action commands. You generally need to have two types of pipeline barriers: memory and execution. So you have two types of pipeline barriers: memory and execution. The difference between the two is that execution only cares about the order of execution of commands in a queue. Memory cares about both memory and execution order. So this does the L2 to L1 cache transition as well. Whereas execution barriers use the same struct, by the way, but they only care about execution order. You pretty much always do memory barriers, as far as I can tell. I don't think I've ever done a. I'm going to turn this up for me and then turn it down for you. How's that sound, guys? So I'm going to do this because it is so quiet on my end. Let me know if that's good. I've just turned the music down on my end. Sorry, I've turned it on, turned it down there, because I literally can't hear it. Anyway, action commands which are pipeline stages. So does that mean I don't need image memory barriers, just a semaphore, because I have a bunch of image memory barriers to change the image layout? It depends on your how you order your command buffer and how many queues you have and how you've ordered them. So you can basically have no pipeline barriers and just have semaphores, but that's heavier weight. That means that every single command gets touched by a semaphore, which is maybe not what you want to do. Memory barriers are going to be faster because they allow commands that don't touch anything to be so let's just say you have a vertex shader stage, right? And that can happen at any point. No one cares. But we have a early fragment shader test, which is like to do with depth testing. And you're like, okay, so we need to make sure that something happens in the compute shader happens, then we can do this early fragment shader stage. Now, what a semaphore will do is it'll block everything. Let's just say you have like a queue and like one has a vertex shader in. A vertex shader command gets ran in that queue, and then we go, okay, so we're going to wait and then do. And it also has the compute shader in, for example. Let's just say it has both. The vertex shader and the compute shader will have to wait. You'll have to wait on both. And it's possible that the compute shader is like really fast. Let's just say it happens in like 0.001 millisecond, but the vertex shader for some reason is like super slow and it takes like 0.5 milliseconds. Now you're losing a lot of performance on this fragment shader that needs to run because it runs these three. This is what the fragment shader. It runs these four really pipeline stages here. So it depends on what your setup is, and we'll break into this and I'll explain these pipeline stages a bit better so you can understand them, because this is half the battle, is understanding the pipeline stages. Because then you'll know what command needs to be waited on and what commands can continue. Because like in this example, the vertex shader should be able to blast through. This is kind of a bad example in theory, right? Because typically you want the vertex shader to like run and then the fragment shader, but you know, we're just in this hypothetical fragment shader in a game anyway. It's doing something with an image that we don't care about, you know what I mean? Like because a vertex shader can do other things than just translate vertices around. But anyway, so action, the pipeline stages. So yeah, it really depends on what your thing. But we'll talk through this, and we'll get into the nitty gritty of what barriers need to be waited on and all that kind of stuff. So action commands, which are everything other than command buffers, state changes, synchronization, and indirect draw commands, consist of multiple operations which go pipeline stages. What did I say? Okay, so I read something there. Indirect commands consist of multiple operations which go through. Okay, there we go. We go through pipeline stages. That's what I meant to say there. The pipeline stages that get executed depend on action commands and the state of the command buffer. In the pipeline stages, they themselves aren't strictly followed by the actual work. This is because some stages can be merged, and in the VK pipeline stage, some stages are left out. The graphics driver will do this, and it's not something you have to worry about in theory. So, that all I'm saying there is like the import vertex shader and like, for example, these two might just be merged together and they might run at the same time. It really depends on what the graphics driver wants to do. And in theory that we never have to worry about that happening if we have a memory barrier or a pipeline barrier and the graphics driver has merged some thing together for some reason. We shouldn't have to worry about that. So There are also 3 special commands that have special access or combined stages. So you have VK host stage, VK pipeline all stage commands, and VK all graphics commands. A command you submit goes from VK stage top of pipe or VK stage none in synchronization 2, or VK stage bottom of a pipe or slash, I should say slash because I'm, yeah, okay, or VK stage all commands in synchronization 2. So if you're using synchronization 2, top of pipe and bottom of pipe have been replaced with none and all commands. So yeah, nothing that complicated there. So we are adding synchronization to the pipeline stage for all commands to order the commands you care about. The mystery, I don't know, of top of pipe and bottom of pipe stages. The VK stage top of pipe is actually where the commands get passed, and the bottom of the pipe is where the commands return. So in synchronization 2, it's none and bottom pipe. Okay, so that's just, so you can think of this top of pipe as the GPU passing the commands, kind of like how the CPU needs to pass assembly instructions before it does anything. So yeah. Where did you find that image for the pipeline stages? What is sync? Oh, sync H. Yes. Oops. So let's go back to this. This was from a video. I shall provide. It's a really good video. This is where I stole the image from, but I'll post that in the live stream for you, so you can look at it later. There you go. Yeah, synchronization. When I say synchronization, sync H2 synchronization is just it's the newer version of synchronization. It kind of streamlines a bunch of stuff together. It's actually really cool. It's quite simple. If you know synchronization 1, the transition between the two is very simple. Anyway, in Q, execution of pipeline barriers. An execution pipeline barrier is a pipeline barrier. An execution barrier is a pipeline barrier. An execution barrier is a subset of a memory barrier. So here we have the actual guy. This is synchronization 1. If you were to do synchronization 2, you basically have a struct instead that you pass in instead of all these arguments. That's basically the difference, right? It's basically some of the things got renamed and you use a struct instead of tons of arguments. So we can talk about synchronization 1 and 2 when we talk about this, because it doesn't really matter. If we ignore all the memory barrier flags, okay, so these guys, sorry, all these guys, in the function, you can just have source and destination stage masks, which are only interested in execution order. The source mask and the destination mask are at the heart of synchronization in these commands. In the command stream, we have before source mask and destination stage mask for after. So I'll explain that in a little bit more detail in the next one. Where it is the okay, so the difference between source and destination mask. So VK stage flag, source mask, and destination mask can be thought of as one being the consumer stage, the source destination mask, and the producer stage, the destination mask. By specifying the source the source and the target stage, you will tell the driver what operations need to finish before the transition can execute. The source destination mask. Did I write that right? So that's the yeah, okay, so by specifying this the target stage, then things that need to finish are the destination masks, And what things can't have started yet is the destination mask. That makes sense? So that's what needs to be waited. What we need to wait for, and that's what that can't happen. Okay, so for example, if you have this memory barrier set up like this, which is the execution barrier. Set up like this, you have the command buffer. We have bottom of pipe, the source stage, and the destination stage, top of pipe. When you add this memory barrier, did it again. When you add this execution barrier, you are saying that every action command needs to finish, and no work must start before the transition happens. Effectively, the barrier will wait for everything to finish and block all work from starting in the next command. So it's very important that this is per command. So there's an arrow here, right, that goes from bottom to top. This also keeps going like this, bottom to top, bottom to top, bottom to top. This goes on and on and on. So it's not just like this. This also should be red. This also should be red. Like the amount, because we've done it. Remember that this is global to all the commands in the command buffer, unless we specify otherwise. So it's like bottom and top constantly. So we have to wait for everything to finish, and then we can only start the next command once everything in the previous command has been finished. Like absolutely everything. This isn't very good because it because you have a pipeline bubble. Yes, because you imagine that a command that has nothing to do with another command, like they shouldn't be pausing for each other. But anyway, so anyway, let's go. Okay, so let us use a better example. Let's say we want a vertex shader that stores an image via a VK image store, and you want that to be consumed by a compute shader. In this example, you wouldn't wait. Sorry, in this example, you wouldn't want to wait for the fragment shader to finish. So, so we let that piece of work pass through. If there is a compute shader command, we must wait for the vertex shader to finish. Okay, so like I said, we don't want to wait for slow stuff that we don't need to wait for. We only need to wait for things that are dependent on each other. The way to express this is to have the source mask to be the VK the VK pipeline vertex shader bit, and the consumer to be the VK compute shader bit. So we need to wait for everything to be done here, and then we need to wait, and then we can continue with the next command with this. The VK memory pipeline barrier. So we have the what is this? The source stage mask, and then the destination stage mask. The idea here is that we have two action commands which execute at different pipeline stages. They execute the green parts or just skip them. So, for example, here's important, right? This is something that tripped me up, and it's important to note. I think I might say it here, actually, so I'll just actually keep going. But yeah, you can see we wait, and we let all this green stuff pass through, and we only wait for these two. So in the first command, we are skipping over the compute shader part of the pipeline barrier because of the command. It's not. There we go. So let's read that again. So in the first command, we are skipping over the compute shader part of the command because the command does a no-op on that pipeline stage, so nothing needs to be waited on. So in this, for example, we don't do anything here. This is a no-op. Even though we're saying wait on the compute shader stage, this is a no-op here, so we just, when it's a no-op, the graphics driver is smart enough to just blast through. So we don't end up waiting on ourselves in the command. Important. This is extremely important that you don't get recording command buffers or submitting queues mixed up with the work being done, which refers, I think I meant to say, to an action command running through its pipeline stages. So that, yeah, this is not when you're recording things on a command buffer, this is not the same as work running on the GPU. So yes, we have implicit pipeline guarantees, but it's not the same as the actual work being run, and that's what you're actually doing. Anyway, so that was a bit of a long way. Here's an example, right? Execution pipeline barrier example. Here's an example of adding a memory barrier. Note that we are not looping through the VK dispatch commands. So yeah, because that adds an extra layer of synchronization. So dispatch, pipeline barrier, source stage, destination stage are both compute. With this barrier, the before set of commands is 1, 2, 3, and after is 5, 6, 7. Our possible execution order could be 3, 2, 1, 7, 6, 5. But we can never, because of this pipeline barrier, this will never, 1, 2, and 3 will never be, they will always finish before 5, 6, 7. But the order of which they finish is completely out of no one knows. If you want to dig into examples to make sure to look, if you want to dig into the examples, make sure to look at this link to make sure that you are doing what you want. So, because someone asked earlier, I will post this in the chat. This is a massive list of what type of synchronization you might want to do. Oops. Didn't need to do that. My apologies. So, compute to graphics, and then it's like, okay, so graphics to compute, right? So that's a resource that you can use for your specific example. There you go. If you are interested, there you go. Note we are waiting on the source stage and not allowing any work to continue past the destination stage in this case because we are working with a VK dispatch. Yeah, so effectively it's, yeah, that's just telling us that we're doing the same thing. But you have to remember that we're waiting here and then we're not letting anything past this, but they're the same. We can have the same thing because we're doing both dispatches. And this is like, if we go back to here again, this is one command, this is the next command in the queue that you submitted, that you recorded. Right. And this just goes on and on and on. Anyways. Building up an execution dependency chain. With these barriers, you can build up an a dependency chain, which is done by connecting the destination stage to the source stage. For example, we can make a dependency between a VK dispatch that needs to transfer data from one buffer to another. So yeah, this is basically just the same example again. It's nothing complicated, but we just have now two pipeline barriers that do this execution thing. That's all an execution dependency chain is. It's not that complicated. We just have, instead of one, we have two. In this example, 4 must wait on 1, 2, and 6, 7 waits for 4 to finish, which is a transfer command in this example. We are achieving the result of ordering the commands by this memory barrier. Next, where were we? Synchronization events, aka split barriers. With events, you can have a barrier that overlaps work. You can use VK events to split up memory barriers. I've never used this, but it's good to know about it. The idea here is that the commands in between, the commands that's the command in between. Let me read out this. The idea is that the command that commands in between. Yeah, there we go. The idea here is that commands in between can overlap with other commands before and after the set of commands. For example, if I have a VK command 1 and command 2, and which have dependencies on each other. However, VK2, yes, and VK2 waits for VK. I don't say why. Ah, okay, yeah, sorry. However, while command 2 waits for VK command 1 to finish, we could have VK command A and B running while the wait is happening. So same old deal. So I'm doing X here because, you know, I don't know what we're waiting for. But you can just see that these are going to run. Now, A and B will run whenever they like. So, literally whenever. Obviously, they'll start in order, but they'll execute finishing at whenever. Not all, yeah, this is important. Not all GPUs take advantage of this feature, but it's very important for advanced compute work. The reason being is if there is a gap that the barrier can, if there is a gap that the command can go through and fill up work, we get a performance win. So yeah, you can think of it like that, right? If you can run these commands without pausing them, because you did events with split yeah, I should change this to Z. Anyway, where are we? Okay, so here we go. Memory. So to understand memory barriers, you kind of understand how memory works on the GPU. How memory works, how GPU memory works. The L2 memory on the GPU is considered available, but to be used by warps. So a warp in this case is just a group of a group of threads. Typically that's 32 threads on an NVIDIA GPU, or 64 on an AMD, although that's got less strict nowadays. I believe you can have 32 now on an AMD, depending on what you want to do. And I'm using the NVIDIA word here, warps. I think on AMD graphics card they're called wavefronts. So if you're familiar with AMD, that's what that means. Hello, Ratchet. Now we're just doing some revision, talking about how GPU memory works. So there you go. L2 memory on a GPU is considered available, but to be used by warps, it needs to be moved to L1 memory, and can be considered visible. The L2 cache is connected to the GPU DDR memory, which is connected to the GPU memory controller in some way through the PCIe or UMA. UMA is when the GPU, I think, sits on top of RAM or something like that. No, where the CPU has a GPU in it and it sits on top of RAM. Kind of like a Raspberry Pi, I believe. I'm a bit shaky on hardware, so, but this is the important stuff anyway. This Vulkan memory model. This is a Vulkan memory model of visible. This Vulkan memory model of visible and available is just a mental model that surrounds the incoherent caches, which is different from the CPU and RAM, which is always considered coherent on x86 CPUs. Let's say that in a warp, work has to finish and let's say that in a warp, work has finished and is written, has written some color values out after being processed. This would be visible memory, but not available memory, meaning that it can't be used by any other warp unless the memory is pushed to L2. If memory is available, it needs to be pulled to L1 cache, becoming visible. Okay, so you have, okay, let's add some notes here. So Ratchet's giving us some nice stuff here. UMA means unified memory architecture, where both the CPU and GPU use the same memory. Right, that makes a lot more sense. Thank you for that. Like in consoles. There we go. There we go. That's where we fantastic. Thank you. That explains a bit. Okay, so if the memory is available, it needs to be pulled. Okay, so that's the whole process. This is why we have a source and destination access masks to make sure that the memory is transferred. To make sure the memory transfer is completed before we move on with further execution of commands. When we are making memory available, we are flushing the caches, and when we are making memory visible, we are invalidating caches. This is just a more general terminology. So visible and available is like, I think it's a Vulkan speak, whereas like the rest of the, you know, if you're talking about caches in general, that's kind of like what that's the same idea translated. Okay, so let's talk about access thingy-majigs. What are access masks? Okay, these are used for memory barriers. Okay, so above here, which is what we've just read, we have actually only been talking about execution barriers, which are just concerned with execution order of commands. Memory barriers are also concerned with moving memory. We need from the graphics card Memory barriers are also concerned with moving memory. We need from the graphics cards L2 memory to L1 memory. For example, if we have an execution barrier that states that we need to wait for VK stage shader bit, we might need to make sure that the memory data is available. We might need to make sure that whatever the data is available needs to become visible. Okay, so we set the access mask to shader read bit. Okay, so I'll explain this a little bit more because there's a bit more going on here. Because this is actually the meat of it. How to make a GPU memory available, visible, and available. Below is an example of how to make L1 cache, how to take the L1 cache and make it available to the L2 cache for a color attachment. So we're going to use synchronization 2 here, but synchronization 2, you can just, it's the same, you just use, for synchronization 1, you just have to set the arguments instead of making a struct. So this is just the struct version of what we were talking about earlier. Okay, in this example, in the example where the L1 cache needs to update the L2 cache, we need to finish the VK pipeline color output stage, which is, if you notice, this is a stage mask, so that's what needs to be finished. And the access color attachment right moves the L1 cache, which is what we finished. Once we finish that command has been done, into L2 cache to be available as color attachment right. For different situations, you would need to change the memory type to something else. So yeah, I'm basically saying if you want to push something else, push something to L2 cache, whatever, this is just color attachment, which is the most common thing, which is like Vulkan 101 type deal. But if you had other things that need to be pushed to the L2 cache, then okay. So using the destination flags, we are moving the L2 cache to L1, making it visible. So again, what is this? We can't let anything happen beyond this point. So the VK stage color fragment bit, and then okay, so let's just read this. For example, let's say that we have command 1 that writes out color memory to its L1 cache. Command 2 wants to do something after that command with that memory. Command 1 has finished and uses its memory output in okay, and it wants the memory output in the shader in it, and it wants the memory output in its shader. In its shader needs to be transferred. Okay, so okay, so yeah, I'm just gonna kind of get rid of this. I don't exactly know what I'm saying there. I kind of think I've said the same thing twice. Command 2 wants to do everything after the memory. Yeah, okay. And okay, so we need to pull the memory from L2 cache to the L1 cache. There we go. That's what I was actually trying to say. Okay. The source masks. The source access masks. The source access moves the memory from command 1 command 1's. Let's just kind of do this. L1 cache to L2 with the destination mask telling VK command 2 to transfer the memory from L2 cache to its own L1 cache, making it visible so it can complete its operation in the fragment shader stage. There we go. Right, next. And finally we have the... Right, when using synchronization 2, you can use... Crying emoji. Yeah, if there's something you're confused about in my revision, feel free to ask a question. When using synchronization 2, you can use the VK dependency info, which restricts what type of memory barrier / execution barrier operations perform under. So there we go. Here you can see 3 different types of barriers that can be set up. The image and buffers are just used to restrict between buffers based on buffer-based action commands and image-based action commands. The VK memory barrier 2 is used for global barriers. This will increase performance as you're setting up hard synchronization barriers for this will increase performance as you're I think I meant to say not setting up hard synchronization barriers for every type of memory that doesn't require it. Yep, okay, so that makes more sense. It's important to note that render passes are just a very roundabout way to handle image memory barriers, which is really useful to know if you're very good at memory barriers, render passes even. As when you eventually finish working with render passes, they output a VK image view inside a frame buffer that goes to the swap chain. So effectively, it's this. A render pass is just that, in a very roundabout way. I just joined. Why are you talking about UMA? We're just doing some revision. And I just didn't know what UMA was, so Ratchet filled me in, which is nice. Okay, so we did that. So for those who are just joining in, I'm just going to be streaming for a long time today. And typically what I would do is I would do like a bunch of prep before the live stream. And then like do some coding, and it'll be kind of a bit more exciting to watch because we'd actually be making progress. But because I've been slacking and I just kind of want to work harder today, I just want to do all the prep that I would do anyway. Live stream that as well. So that's what we're at. That's what we're about today. So this is the revision part of the stream where we just revise what I already know, and then we're going to do some studying, and then we're going to do some coding. We'll get more and more exact on what we're actually doing in the actual coding. But I believe this is good so you don't end up forgetting things. Okay, so no top-up pipe and bottom-up pipe access masks. This is important. And also this goes for none and all stages as well, you know, for synchronization too. Doing this is completely meaningless. The top of the pipe / bottom of a pipe are only for execution barriers, which are strictly different from memory barriers. Not strictly different, more like different usage. The reason that they are useless for memory barriers is that the stages perform no memory accesses when they are complete. For example, the top of the pipe pipeline stage is when, I'm going to say instead, is when the GPU passes the commands before execution. That doesn't touch memory. That doesn't touch memory we are interested in. It's possible that touches some kind of like instruction cache or something like that. But we don't care about it. We can't access it. We can't do anything. Yeah. Split barriers. Oh, I thought you were making a game without using VRAM staging, like Apple Silicon. Yeah. Nope, we're not doing that. But it's good to know, you know, that concept. Okay, so split memory barriers. This concept is very similar to building execution dependencies, as we can also do memory barriers transfers over different memory barriers. By making a memory available in one memory barrier and making memory visible in another memory barrier. Okay, so yeah, this is the idea. This is what ends up happening if you set the destination mask and the source mask to 0, and we don't do the memory barrier transfer completely in one go. If you're using dynamic rendering or render passes without a subpass dependency, when ordering your work in a queue for a frame, this is what you'll need to do for your color attachments, with work in the middle running the shaders. Here is an example of what a split memory barrier looks like for a situation where a computer I always write this computer shader. I always catch myself writing computer shader for a situation where a compute shader is writing to an SSBO and we later read from it in another compute shader. So we have a dispatch to writes. This is the writing to thing, and our memory is in VK shader write mode. So again, remember that we have to. This is when we begin the pause. This is for the next command. This is where we start the pause. This is what can't continue. We have the source destination mask, and we then, what is this one? We are making this L. Can I remember? We are pulling this. No, we are pushing this to L2. I think. Let me look through this a bit, and then we don't continue past here. We wait for this to finish. No. We push. This is pushing this to L2, I think. Hang on. I've completely forgotten. Let me just look at my notes again. It's kind of complicated synchronization. That's why I revise it quite a lot. So when I eventually do indirect draw calls and I build up buffers with those indirect draw calls, I can just write all the pipeline barriers without stressing. So it is important I remember the. So the source mask and access mask is when we go from how to make L1 cache to L2 cache. Okay, so that's the push. So we are doing a push and then we're doing a pull. So then that can run. Right. Okay, so then it's like, in theory, I'll just write a comment here. Other stuff happens. I don't know. Say other commands run. Alright. You know, in theory, right, that's like have nothing to do with each other. Note that the stage masks cannot be 0, and the access masks can be 0. When the access masks are 0, we are saying we don't care about what the memory state is in for that in either L1 or L2 caches. I assume you are reading things I sent a few weeks back. Yes, effectively. So when just so you know, Ratchet, including this is for also people who are watching. These are the notes I've taken based on stuff you've sent me in resources. So I do actually go into the resource hash resource area and do make up notes. So yes, I'm just making sure I do not forget it. So we're almost done with our synchronization studying. How memory layout transition works. According to this blog, VK image buffer barriers aren't interesting and no GPU really cares about them. Okay, so you don't need to worry about that. When you're working with VK and memory VK image memory barrier, you have to change the image layout at some point. So this is these guys here, which is the final thing you haven't done. What's interesting is that the VK... Sorry, what is interesting is the new layout and old layout happen in between making the memory available and visible. So what we've just talked about, pushing and pulling to L2 cache and all that kind of stuff, this happens in between. The rules state that because we are doing a read/write operation, the image must be available before the transition takes place. After the transition, the memory layout is transitioned to be made available again, but not visible. The transition happens on the L2 cache, so the actual transitioning process is only for the L2 cache, baby. What this means is that, let me fix the music. Did anyone ever play this game? I feel like I was the only ever guy to play Realm of the Mad God like crazy. I've got 500 hours into that. Played it. I was so addicted to it back in the day. Anyway, what this means is that if you have memory that's only in L1 cache, and you try to transfer it from one type to another, it won't work. If you later want to use this transitioned memory with an action command, you need to move the memory to be visible in L1 cache for work. Oh, you played it, cool. Yeah. Oh, yes. Okay. Hi guys. I'm glad someone else played it. Fun fact: the DLSS SDK has a synchronization error internally that the validation layers will catch. So I can't use DLSS with sync validation. Oh, that is a miserable. No way, dude. That sucks. So you can easily get read-write errors because you're having to turn that off. Oh no, how annoying. I guess the only situation how I would deal with that, you're probably already doing this, but just make sure there's no breakpoint, I guess, and just ignore that particular error. Okay, so the final piece of the puzzle, when we put this all together, the theory of synchronizing a frame, which is the final thing that every Vulkan programmer should know when it comes to synchronization. Synchronization is hard, okay? Anyone who's struggling with it, there you go. I said it. If you didn't believe it, now you know. If you want to debug synchronization in Vulkan, you can turn it on in your Vulkan configuration tool. It's off by default. This will allow the validation layers to catch mistakes you're making, which is literally what I just read about. Ratchet has to turn this off, or you'll get. I don't know how the SDK, DLSS SDK's error and how bad it is or whatever. But if you turn this on, you'll see the error, apparently. When you actually want to render a frame, you need to do these things. Wait for the previous frame to finish. Acquire the image from the swap chain. Record a command buffer which draws the scene onto that image. Submit the recorded command buffer. Present the image to the swap chain. Recording. So the GPU can do its work. Okay. This is the overview you need to keep in mind while other things are mentioned. With synchronization, everything is explicit, meaning that the order of operations is up to us. We need to tell the driver what to do with all the synchronization primitives, which is the semaphores, wait, idle commands, all those things. It's important to note that the GPU and the CPU are asynchronous, meaning that a lot of Vulkan commands will return before they work. I think we've said this multiple times. There are three major things you need to synchronize. Acquiring an image from the swap chain, execution commands that draw onto acquired image, presenting an image to the screen for presentation, then returning to the swap chain. This is great, but the order of this functions finish on the GPU is undefined, so you'll need to wait for them. Okay, so I think I wrote this note because I went through my... So I have a bunch of a render pass version, and I realized that everything here is just completely useless. If you're not using render passes, it's it's very render pass specific stuff. I mean, not this specifically, but if I go to it felt very render pass heavy. Because a lot of these notes were based on the Vulkan tutorial, Vulkan-tutorial from 2016. Anyway, so we did synchronization for victory. How long have we been going? So 1 hour and... what else should we do then? Alright, let's just catch up with chat. Someone filed an issue about it like a year ago. No response. Oof, that's miserable. I have a test tomorrow of physics, and here I am watching your stream, lol. Maybe you should do that. Pure gameplay. But yeah, thank you for turning up anyway. It works properly. It works properly because the VK command clear image internally uses a compute shader, which is synced properly. But Vulkan expects the transfer related sync. Ah, okay. Right, okay. So yeah, it's expecting some extra synchronization command setup. Interesting. So yeah, this is going to be part of the stream, guys, where we kind of have to figure out what we're going to be doing. And what we should be reading and what we should be studying. And this may include watching YouTube videos and stuff like that about programming. And so I'm not entirely sure. So we have done... I didn't want to try and plan this too aggressively because revision and stuff. So I'm trying to think what are my weakest areas? What are my... This is how I think, by the way. I just opened Notepad. Come on. Areas. There we go. It works on the video hardware, but it's basically a validation error. Yeah, it's a tough one actually. It's kind of nitty gritty kind of. I don't know how slow it would be to set up some kind of pipeline barrier that does a transfer or something. It'll always be yes, my weak areas will always be Vulkan, but it might be because okay. So here's the thing about why I've been. I kind of need to talk about this a little bit. I think. Why have I been struggling with this entity thing, right? Entity code. Okay, so let's talk about this. One, I could just use a stable ID from the many different types of tutorials that I've found that the way I've currently got things set up Nothing really seems to work. Okay, so because of that, what I might need to do is break everything up, break everything, and start with a newer data structure. Okay, so I might do that today. We might do that. Okay, so studying, that's okay, so that's for coding. I'm writing that down because I want to say, like, oh, is there something I need to study here? We'll do that later then. But studying wise, what I want to do today. I'm just gonna look for my codes. It's like a single missing barrier. Yeah, it feels like it. It feels like it's a. It feels like you just throw it in. Why don't you use ent or flex instead of rolling your own? Just curious. It's not that my ent. I think what's ended up happening in general, Omega Killer. It's not that those libraries wouldn't be useful. It's that I've set up my code in a particular way that's like it's causing me issues with any type of implementation that it comes. So even if I pulled in ent or something, the way things are currently set up, I need to really rethink how I've done them, because it's I've seen like really nice simple implementations of things which I'm kind of interested in using, or at least modifying enough that it's like fits my engine. But it's like I've got this like half written one, like entity code, and it's all kind of busted up. So I need to, yeah. But before that, we need to do a, what do I want to study today? Okay, so we have graphics theory, which we could do. So like OpenGL, like .com or whatever it's called. Could do DSA, I guess, for entity-specific stuff. So that might be looking at ent. Does the translator work here properly? There is a translation tool. I don't know, Dimitri, how it functions. Oh no, it's a close. Oh yeah, I guess you can't fix it then. Never mind. I bet people are dying to like crack it open and fix it. That's very annoying. It's got a synchronization error in your thing. Maybe. What do we want to do? Obviously, I think the direction we could take is completely up to me, and we can change at any point. We could actually do. I don't really like studying a Vulkan without like randomly studying Vulkan. What do I want to do? I do want to study something. So let's look at my books. I've got downloaded PDFs, which is how I'm going to do things. I might study threading / operating systems, maybe. Yeah, let's do something a bit random. Let's do some operating systems. Because I have the book. What do I need to do? Let's look at my notes. So I don't have anything on. Because we could study IBL. I haven't actually finished IBL. Yeah, let's look at my let's look at my synchronization actually. My unfinished notes. So we have this, which we haven't finished. We've definitely done that one. Oh, we've done that one. We've done that one. I can't remember why I didn't do anything here. That needs to likely be deleted. Yeah, runtime type information. This might be useful for streaming in objects at runtime. We have memory alignment, which I never kind of finished, which I don't really think we need to do. Texture mapping's fine. I think I can safely delete this. Vertex buffers. We have synchronization, which is where all my notes came from. We have Vulkan dev stuff, which I never really got through. And that was, again, more synchronization. We have threading. Yeah, let's do... Let me run my code, right? Sorry, I'm being a bit syntax error. In my fragment shader. Let's throw this back together. And we need a debug scene. So I'm going to try and think, what am I struggling with and what do I need to study? Because I could just study operating systems and that, but which is just kind of fun. But I need to like target what specifically my weaknesses are. But if it's something like shadow mapping, for example, which I don't know how to do at all, like I would want to have to, I would want to have an environment where I can actually debug that stuff in. And I don't want to just start driving into the coding immediately, just to break up the day a little bit. Why are you complaining? Alright, so let's just... Right, I'm just going to get rid of this for a minute, because this is my attempt to try and copy something. And, yes. I think later on today, at least, we're going to be able to, we're just going to rip this apart, so I'm completely fine getting rid of it for now. Yeah, so we're going to take advantage of some of the resources I found online. And I'm just going to get rid of this for now. Don't need this. Okay, and scroll up. You know what I'm going to do, actually? I'm going to develop... I'm going to do a bit of programming, I think. And then what I'm going to do after that is then work backwards. What I mean by that is once I've... Yeah, let's better to be 40 for now. Why is this edited? Oh yeah, okay, so let's bring this back in. And yeah, so what I'm going to do is kind of do a little bit of coding now, and then no, I'm just trying to think. All right, I think this is a situation where we just pick a direction and go in it, right? So let's study. Yeah, okay. Who cares? What is it? OpenGL tutorial. Sometimes, like when you agonize over the, what is it called? you agonize over like, oh, should I do this? Should I do that? It's more important that you just pick a direction than agonize over the, oh no, maybe this, maybe that. Okay, so otherwise we're going to be here forever figuring out what the perfect thing is that I should study. We should just pick something and just go with it. And if it's crap, then we'll just switch. Rather than sitting here thinking, oh, it's not the perfect thing. I do need to know theory, so let's just do graphics theory for a bit. Where is my graphics theory? Which one is it? Here it is. Because I haven't finished this. Alright. Fun fact, DLSS does Vulkan coder interop. Oh. Never heard of that term. Oh, interrupt. Yes, Dimitri said. CUDA was also a C++ project directly through NVIDIA's thrusts. Now they've merged everything into a mono repo. And the agents make 1,000 commits a month. It's what? Flippin' heck. I guess that's what happens when you start huffing the AI fumes too much. Holy, that's crazy. Staring at your code works as well. Yeah, that's true. We could just stare at it. But yeah, I think I want to be staring at my code later on. Just to give myself a break. Okay, so image-based lighting. Let's just. I haven't done this in a minute, so let's go through this. I think I actually studied this on stream last, but yeah. So let's read this. Okay, so diffuse irradiance. Irradiance. How do I actually say this? Let's get this onto my. Irradiance. Where is a dictionary? It's a dictionary for difference. Dictionary definition. Okay. Bro. Let's go to a dictionary. Who's to judge? Jeez, that was a. That's why I love Zig. No, I need to listen to that article. Oh my goodness, I'll forget it. You know what? If I say it wrong, who cares? Okay, so image-based lighting is a collection of techniques that deal with lighting outside of point lights and ray tracing. It treats the environment like a big light source. We are basically taking our cube map texture and using each texel as a light emitter, so this note is going to be way rougher than the ones we just read, so which makes things look brighter, like they are belonging to an environment. Very cool. So image-based lighting is typically more accurate than some global illumination stuff, especially with ambience. We can start to introduce physically based rendering with image-based lighting if we look at the physically based rendering equation. So the goal here is to do the integral over all lighting directions omega I over the hemisphere. How do you say these differently? Literally, let's just shout this word. Omega! Omega. Because we need to consider every light direction. I'll just say W. I know it's omega, but because we need to consider all every light direction, solving the integral is non-trivial. Unlike when we know all directions of the lights. Unlike when you know all direction the light is coming in, I guess. Alright. We need to do these tasks. Need to do these tasks to simplify our calculation. First, we need to grab all the scene radiance given any direction WI. It needs to be fast. Yes. If you already know, I'm just gonna grab a drink. Yeah, for this marathon, gotta make sure I stay hydrated. Alright, so let me just zoom in. Yeah, let's make it look no bad. Let's go. BRB. And then it's just to anyone who tunes in. Am I obligatory? Yeah. Yes, you gotta say hi. Bottle of water. Yeah, gotta get a bottle of water. Tea. Oakley dokley. Back. Yeah, I had some stale tea which I wasn't going to drink. Don't tell spiffing Brit I had to throw away some Yorkshire tea. Alright, we can get rid of that now. Anyway. Okay, so if you already have a processed cube map, this gets easier to work out. We can simply visualize every texel of a cube map as one simple light emitting source based on the physically based rendering equation. We can sample over a cube map and get our scene radiance based on that direction. We want things to be fast, but we have a problem. We'll need to WI, I guess, over the entire hemisphere, which is far too expensive to do per fragment shader infication. So yeah, this, if you think about this, this is done over every pixel, which is slow as fuck. So we gotta figure out better ways to do this. To help with speed, you want to pre-compute or pre-compute. Why did I write that twice? Most of the computation. You can split up the diffuse KD and specular KS in terms of the BRDF. In terms of which can be made independent from each other. That might be good. I don't actually know what's the correct thing at the moment. What you air quotes should be doing or not should be doing. But that's why we're here. If you split up the diffuse and specular parts of the integral, you can focus on the diffuse part of the BRDF. If we look at the Lambert term, which is a constant term, the color C refracts quotient KD and pi. These are not dependent on any on the integral variables, so we can pull it out of the term. It's just a bit of algebra, that, or a bit of calculus, I guess. Okay, this means that the integral is only dependent on Wi, assuming that P is at the center of the environment map. With that knowledge, we can calculate our pre-compute. We can calculate, or that's what I meant to say. Oh, whatever. Calculates our pre-compute a new cube map that stores in each sample direction or texel. With WO, the diffuse integrals result by convolution. Sorry. Convolution in maths means that we are taking two functions that produces a third as an integral product of two functions, f times g, if both f and g are functions. Once you read this, check out the paper I sent on Discord. Yes, I will do. Thank you. I don't know how long we'll be on this. We might be on this for a few hours. We'll see. It depends on how long my note-taking takes. But yes, thank you for the resource, by the way. I will grab it. As I get rickrolled. Thank you. It's really nice. But yeah, if anyone does have like cool resources related to what we're studying, I will I will read that too, because we're in the study phase of the stream. Okay. Here, what we are doing is considering all the data in a solution. So I think this is a pre-computed, and this is a non-pre-computed, but we'll see. I'm scroll down to here because this is where we need to start doing our studying. In the same set. Okay, so here, what we are doing is considering damn, all the data in a solution set and applying some kind of computation that is applying some kind of computation that is every piece of data in the same set. What am I saying? Here, what we are doing is considering all the data in a solution set and applying some kind of computation I think I meant to say to every piece of data in that same set. Okay, yeah, that makes sense. In our case, the set is the scene's radiance or environment map, meaning when we are considering a single sample from the cube map, you have to consider all other samples that get sampled over the hemisphere. Okay, makes sense. We'll want to do the convolution by solving the integral for each output. I think I could start. No, okay. There's the hemisphere omega output sample direction. We do this by grabbing a bunch of WI and work them out and sample the average over the hemisphere omega. The hemisphere we need to build up is samples sampled is a bunch of samples in the direction of omega I, and orientated let's Google that briefly. Let's go to this. I was going to do something a bit with that, but
oriented.
Okay, yeah. I was making sure I wasn't saying something. Oriented towards the output sample WO0 directions we are convoluting. So as far as I can tell, I got as far as this. Yes. Okay. So now we need to continue. Or did I? Hang on. No. Okay. Okay. So this pre-computed cube map. That for each sample direction WO stores the integral result can be thought of as a pre-computed sum of all indirect diffuse light of the scene hitting the surface aligned along the direction WO. Okay, so now I've got to sum that up in my own words. So this is what we're going to be doing. I'm going to be reading like a sentence and then trying to write it the way I want it to be read, because that's how the learning process goes. You learn in the struggle. Unfortunately, downside is it's slower. So for each sampled direction, $, how do I do this again? Backslash omega O stores the integral results can be thought of as a stores the result of the integral of the diffuse integral. Yeah. See you in a minute. Okay. This is a pre-computed sum of all the indirect diffuse light hitting a surface aligned along the direction. Yeah, okay, that was pretty much a copy and paste, but it is kind, I don't know how to say that any other way. So omega this is a pre-computed sum of all the indirect diffuse light hitting a surface aligned. Okay. Such cube map is known as an irradiance map. Because radiance and then IR radiance. I wish you knew how to say that. When you work this out, you have a irradiance map. Seeing in... No, let's read it. Seeing as the convolution cube map effectively makes us to... Seeing as the convoluted cube map effectively allows us to directly sample the scenes pre-computed This is because we have a pre-computed a convoluted cube map which effectively gives of us a sample of the scene's irradiance. It must be irradiance, right? From any direction. WO, let's go. Alright. Omega. Ooh, zero. Righto. The irradiance equation also depends on the position P, which we've assumed to be at the center of the irradiance map. This does not mean all diffuse direction lights must come from a single environment map, which may break the illusion of reality, especially indoors. This does mean that all okay. Rendering engines solve this by placing reflection probes all over the scene, where the reflection probes calculate its own irradiance map of its surroundings. This way the irradiance and radiance at position P is interpolated irradiance between its closest reflection probes. Makes sense? For now, we assume we are sampling the environment map from its center. Okay, so as far as I can tell, that's quite... If you're indoors, it's going to be common that if you have one irradiance map at this is going to be $P at point P, your diffuse light calculation is going to break down how engines deal with this is to have reflection probes at different points, and they calculate their own irradiance map, and then you do linear interpretation between each probe. Nice. Cool. Okay. Alrighty, let's restart the music. Cool. Alright. Below is an example of a cube map. Environment. Below is an environment. Below is an example of an environment. Below is an example of a cube map environment and its resulting irradiance map, courtesy of the wave engine. Averaging the scene's irradiance for every direction W. Okay, this is what an irradiance map looks like. Based on the using this environment map, cube map. I don't need to say environment cube map, blah blah blah. Now let's grab that. Can I just drag this in? This might be easier actually. Yep, that'll do. Swag. By storing the convoluted results in each cube map texel, the irradiance map displays somewhat like an average color of the lighting of the environment map. Sampling any direction from this environment map will give us the scene's irradiance in a particular direction. Fantastic. So if we store the convoluted, it's a funny word this, isn't it? Convoluted. It results in each of our cube map texels. Yes, in the direction of... I just want to get this completely right. And do a slash. Omega. Oh, there we go. It's kind of like an average of the light and color. This gives us our scene's irradiance. Hell yeah. I wonder if you could just like, instead of having like doing the convolution calculation on the fly, could you just like load in this texture and this texture and kind of like have them both working together? Because that would be kind of interesting, wouldn't it? That'd be like right, so let's break this up a bit anyway. So what I want to do is So what? This is how I make notes as well. So I also don't just do what is image-based lighting. So the next step, when I have like a breaking off point like this, I like try to make the notes smaller because I'm not going to read this all in one go in the future. So image-based lighting is technically, yep. So we have physically. So what we're going to do now is I'm going to make this bigger actually. Rendering physically based rendering equation. So now I'm just trying to figure out how what would be a good separation. I think this all needs to go together, as far as I can tell. Yeah, so assuming that we need so I want to keep the convolution of these functions separate. I want to like simplest. Let's do the goal with using image-based lighting and physically based rendering. PBR. Okay. And then I can go and then I want to be like simplifying. Simplifying. The equation to for diffuse. Okay, and after that okay, So here we have a consider all the data. Yeah, I'm gonna have to have two concepts in one, I think. And then okay, so when we do the compilation, so the work of convolution, okay. Yeah, so I'm going to keep these together. Actually, making... Yeah. Making the irridance map. Yeah. Alright, so that's what I'm going to do. I'm going to split up what is physically based lighting. Sorry. So let's make a new note. Oops. Oops. What is image-based lighting? This takes a little bit of time, but it wouldn't be that bad. Yep. So graphics theory. I don't really know how many. Let's do physically based rendering. Yeah. Because the physically based rendering is a topic in itself. So what I'm doing here is kind of like grouping notes by category. So these are the tags, and this is just like how mature the thing is. And now I can build up the I can start building up like connections between these things, because I want to be able to just be like, all right, what is image-based lighting? And then for the next step, I want to be able to go, okay. So then I go like this and do the next thing, and then I take, because the whole point of this is to break up my notes into little pieces, so I can, like I said, just read them. So graphics theory and physically based rendering. So we also have image based lighting, I guess. I guess I could make that a tag. I'll leave that for a minute. I'm not entirely sure. No, I've changed my mind. I'm going to do it. I'm going to call it image-based lighting. Because it's like a subgenre of image-based light thingy, isn't it? So we want to make a new note for that. Move to okay, so yeah, we want image-based lighting. You don't want too many tags, but I like to think of it as like hierarchy. So like graphics theory, physics-based lighting, image-based rendering. So I could go into graphics theory and click on these notes down here, and yeah. Diffuse. Irradiance. Now we connect these guys together. Like this. And like this. Cool. And now we go like this. We make a new one. Okay, so this is going to be a bit of a bigger. Simplifying. Simplifying. F-I-N-G. That's how you spell it. Okay, so... Right, okay, there we go. That's how you spell it. For diffuse image-based lighting. Cool. Let's go. And let's grab these tags. Let's throw that in there, make it easy for myself. We're going to have this and this connected. And so simplifying is going to be immediately the one that follows. And we're going to take all our notes here and throw this in this section. Do I mention convolution in here? Find convolution. Yes. Okay, so... Oh, okay, so I already have the definition. Cool. Next is making the actual map. And I'm going to throw all this in. Did I... No, I didn't. Okay, so these notes need to be connected to the original note. So if I want to read the full thing, I can. Making the guy. I don't feel although I don't know why I feel like did I call something bad by accident? I used to feel the reason I never streamed this stuff on stream was because I didn't want to bore everyone, but I don't know if this is like super boring. It's fine if it is, honestly. It's more important that I develop as a programmer. But if it is, I apologize. But also, at the same time, later on, we're going to be doing a lot more programming. We're going to be diving into outside of studying. So if I want to make the irradiance map, I've got to have multiple things. You've got to know what image-based lighting is. And then basically I want all my notes because it's going to build up on. But it's kind of cool because I'm not that worried. Like I used to be like, oh, I can't do this on a stream. This is really boring. But considering we're going to be doing, this is going to go on. It's going to be a long guy. It's going to be a long one. I'm actually fine with the lulls of the stream. I think it would be a bit insane if everything was like super hyperactive the whole time. Hopefully this feels more like I'm yapping in a library almost. Like we're in a study session together at this point. Me and you, whoever's watching. It's cool to see how other people's thought process and how they learn and new stuff. For me, it's kind of better than coding / game dev. Cool. I appreciate that. I make a killer. Yeah. I like it too. Honestly, it's like I really benefit from. Even if I just put it on the second monitor, even if I mute it, sometimes I do this. Sometimes I put a stream on, I mute it, and then I just have that there while I work as well. I've done that so many times because I feel like it's nice to have like someone to study with. So if I'm doing something similar to that for anyone, that's kind of cool, and it's cool that people can see my thought process and all that. So okay, cool. Now I'll actually read these in the future. Hey, I think also as well, it's gonna eventually become an index. I'm gonna take graphics theory, and I'm gonna move this. It's gonna be its own thing. So I'll explain what I'm doing in a minute, because this will come up in. Can I copy these? This would be really nice if I could. No. Okay. So I'm just going to take all these guys. And what I'm doing here is making IBL. Making like an index to go through. This is really helpful in the future. Because eventually this graphics theory is going to get pretty big, so I can now refer to it. And we have I don't know what's called, as depth. So we have something that's not related in here that's connected. So what is reverse Z? Cool. Alright, so now for those who are like, okay, what just happened? I'll explain. It's kind of cool. So now what I've done is I've made a purple node, and this purple node, instead of it being a orange, this will eventually turn into this kind of idea where we have a general topic that has everything together. So operating systems, threading, C++, assembly, and graphics theory. So yeah, I had a feeling that was going to happen at some point. Anyway, it's just useful to have that. Okay, so now we're on part 2. Okay, let's go and make this. Okay, so we have. Alright, so high dynamic range. But I'm wondering though that instead of having a high dynamic range texture, can't we just like convolute and just have like a low dynamic range texture and a convoluted texture? Sorry, I should call this an irradiance map instead of having a high dynamic range, because I have read this briefly. But it will be good to learn how to deal with equirectangular maps anyway. So anyway, so this is called PBR and HDR. Right. Okay, so we briefly touched upon this in the previous chapter, which was what? I actually don't know. Oh, okay, so there's like a general lighting thing I haven't read. This might be useful to learn how to do the... Yeah, so this is just physically based rendering. But I've actually never done the gamma correction, I don't think, which is kind of interesting. Anyway, so we'll just say, okay, cool. I briefly touched upon this in the previous chapter. Taking the high dynamic range of your scene's lighting into account in a physically based rendering pipeline is incredibly important. Taking the high dynamic range of your scene's lighting into account. Okay, so what is it talking about? If I go with find HDR, let's just have a quick look. Okay, so far we've been assuming all our calculations are in linear space, and to account for this we need to do gamma correction at the end of our shader. Calculating the light in linear space is incredibly important, as a physically based rendering requires all the inputs to be linear. Okay, note. Okay, so what I'm going to do then is let's actually throw this in here. Let's call this linear lighting versus high dynamic range. Rendering. Okay, cool. Even if we don't get back to what we need to do, this is important to know, because I might be able to just kind of add. It'll be nice to know if I can add this kind of gamma correction. Yeah, so I'll just read this. I won't read everything. So far we've assumed all our calculations to be in linear space, and account for this we need to account for this we need to do gamma correction at the end of the shader. Okay, so if you are using physically based rendering, you everything, all its inputs, what am I saying? Inputs need to be linear. When you are lighting the scene in linear space. So this means you need to do gamma correction. To get your lighting, to get your light correct. I don't know. Yeah, so what I might do is just kind of experiment with my shaders and throw this lighting correction in. We don't have any high reflection stuff, but yeah, we'll see. Okay, so note taking this into account, we will not taking this into account would, yeah, okay. Additionally, we want light input to be close to their physical equivalents, such as their radiance or color values can vary widely over a high spectrum of values. Sure. What? Additionally, we want light inputs to be close to their physical equivalents, that the radiance or color values can vary widely over a high spectrum of values. Okay. As a result, the LO, which is this, I guess, can rapidly grow high, which can get clamped to 0 or 1 due to the default low dynamic range output. Okay. Right, so when you're doing high, physically based rendering, you want your inputs to be as accurate to the real world as possible, meaning that when you work out the color, for your diffuse light, it looks like. Is that diffuse or specular? Sorry, it's actually the final part. What's LO? Okay, so that's diffuse, albedo, specular, radiance. Okay, so that for me in my code is what have I called it? It will be material color, so I call it AO. Let's look at the maths again, side by side. So albedo, material color, I believe is that is the, which one is it? What are we working out here? Right, I need to see more of the code, I think. Be right back. Yeah, no problem. I'll be here. I will always be here. I don't know why I said that. Okay, so we have these two. Denominator, yes. So that's our specular BLDF, and where's your Fernal? Oh, it's Fennel, sorry, Fennel. Okay, so you worked out you called it F. So that's okay. So that's your denominator. Specular. So this is this. Yeah, because you have the L.N here. Okay, so this is the. Okay, yeah. Okay, so this is the line. Okay, so I'm gonna use my own code. You see. And if I take this, yeah, let's take all this, and I throw this into my notes, and like this. Okay, cool. Let's get rid of the comments. Let's get rid of. I don't need 2 of these. Okay, so material color. So that's what that is. Can grow rapidly in LDR. Low dynamic range. Range. Which means that it can get clamped to 0. Nice. Okay. Or 1, I guess, as well. 1.0. Okay. We fix this by we'll fix this by taking the LO and tone or exposing we fix this by taking the LO and tone or exposure map the high dynamic range value correctly to low dynamic range before the gamma correction. We fix this by taking the LO and LO and tone, or expose the map to the high dynamic range of values to low dynamic range before gamma correction. Here we tone map the high dynamic range colors using rain map operator. Ah, okay, right. Preserving the high dynamic range of a possible highly varying irradiance, after which the gamma correct color. Ah, okay, right. Okay, so there are 2 ways to fix this. One, let's do it like this. One, expose tone or expose exposure to tone map or exposure. Hang on. We fix this by taking the low and tone or high dynamic range HDR value correctly to low dynamic range. Expose taking HDR data and correctly converting it back to LDR, or tone map it to LDR. These things need to be done before gamma correction. Alright. Nice, nice, nice. Okay. Good, good, good. Okay. So this is Reinhard's, or Reinhard even, operator. Here we tone map the HDR color using Reinhard's operator, preserving the high dynamic range of the possible high varying irradiance, after which the gamma correct the color. We don't have a separate frame buffer or post-processing step, so we directly apply the tone mapping and gamma correction step at the end of the forward fragment shader. Taking both linear space and high dynamic range into account is incredibly important in a physically based rendering pipeline. Without these, it's impossible to properly capture the high dynamic range and low detail of varying lights of intensity, and your calculations end up being incorrect, thus visibly unpleasing. I'm not going to lie, without gamma correction / HDR, this looks better to me. It's possible that you had white lights here, but I prefer like kind of like more intense lights. But anyway, you can simply apply a Reinhard operator at the end of your fragment shader to correct the colors in your physically based rendering solution. Okay, so in our case, this would be after we've done all the mixing of our colors, then we want to go into our this guy, and instead of encoding the color, okay, hang on. I have a feeling that I already do this. I think this is, yeah. Okay, so, okay, let's experiment for a minute. This is encoding things back to linear space. That's literally what this is doing. But it's good to have this in anyway. So I'm gonna have both. So this would be encoding to linear space based on a high dynamic range. And as far as I can tell, that gives us the correct color. I wondered, okay, so that I always wondered why when I did tone mapping in the past that it looked bad. It never looked good. Like any tone mapping that I ever did, people were saying like this happened like more than a year and a half ago. But in comment sections, people were saying, nope, you need to convert to sRGB after tone mapping. Right, okay, that I'm still going to say what I'm going to say, but I'm also just going to correct the future me. Okay, thank you. That's helped me out, Ratchet. So I changed everything to linear space, and then I did tone mapping. And it made everything grey. It made everything look grey for some reason. So you need to convert to, yeah, after tone mapping. So what I'm doing here, I'm doing no tone mapping at all, and then I convert to linear space. But I always did, like I said, I always converted to linear space, then did tone mapping on that linear space instead of using the high dynamic range. And everything looks terrible, honestly. So let's experiment a little bit. I know we're completely going off. We're not doing what the description of the live stream has said in the title, but this is kind of fun. So, oh, I should fix the music after this. I do like the song though. The conversion to sRGB can be manual in your shader or automatic writing. Yes, I'm doing it manually in the shader, which I think this is what it's doing. I don't actually know the maths very well, but okay. So what I'm gonna do briefly is add tone mapping before we do the convert to linear space. And I'm just going to see like what Reinhardt's tone mapping looks like. I know it's the simplest and kind of the most basic, but we're going to see kind of like if it looks grey as hell like it used to, or not. Let's so what I need to do is activate the player camera because that actually has the light source. Oh, hang on. Let me where's the light getting written out to? So the light location needs to be updated with the camera, and currently it isn't. Because it's taking the player position. And for now, what I want to do is take this. And instead of light position by a player, I want the camera, or game camera, internal 3D camera .x, right? Is there something else in here? Position, probably. Yeah, .x. That's a Z. Okay. So what I'm doing here is just adding the lighting so it can be updated because it's quite dark my scene, so I need to be able to see how this affects things. This is quite exciting. Okay. So I'm going to write what you said into my notes ratchet, but I'm just going to experiment a little bit. So you're using a unorm, yes. Oh yeah, so we've got a couple of things I need to remove, and this. I hope there's nothing else. Okay, cool. Right, that's what I wanted to see, my camera updating things. Okay, if you do an SRB conversion, then your swap chain image, then your swap chain image does it again. It will look grey. Is swap chain... Hang on then. I'm kind of curious then. So this is me converting it to linear space. If I take the material color, I'm not going to convert it to linear space, it's going to be HDR. So you're saying that if I've got a unorm swap chain image, oh, okay, there, I still need this kind of, but instead of this encoding, we're just going to do it like this. And we should be good. Okay, yeah, this is a very different. It looks, yeah, this looks weird. Here's a duck again. Yeah, it's like too colorful. Alright, so yeah, I do need to do that conversion based on my swap chain setup. Okay, so what I want to do just quick is take that Reinhardt code that we just saw and just see. Yeah, this is like the simplest, crappiest tone mapping. Because it might just help with the overexposure that I end up having. So material color equals material color divided by the... So I'm not going to do any smart stuff. This is still in HDR. Then we go to linear. And... No, it still looks great. No. Sag. Okay, maybe I'm doing the wrong... But you can see what I mean, like everything just kind of grays out. Which may be good, I guess, but... Okay, so I probably need to do the maths differently, because I think this Reinhard implementation is dependent on the fact that everything else is the same, and my code is very not the same. Which is a chill. Yeah, everything looks washed out, but I think maybe I'm doing this twice. Hang on. Hang on. I think what's happening here is I'm doing it twice, right? We need to do it once. I'm doing both. It's or, not and. So we don't want to convert to this. We want to do this, and let's have a look. How does that look? Okay, there we go. Look, like that's reasonable. Yeah. That's like better. So yeah, that kind of looks not. I mean, it blows out. It's a little bit grey, but I think that's the tone mapping algorithm. Yeah. Like when I did this, like Reinhard was the greyest out of all of them. But yeah, this looks fine. I just need to... I still prefer converting from HDR to SDR myself, because that kind of has like a different look. Can you look up what your swap chain image format? Yeah, sure. Swap chain image. Where would you be? You'd be in create swap chain. So let's find you like this. Yeah, you'll have to see if I'm in HDR or linear. This will all be going to my notes in a minute. Create. Where's create swap chain? Okay, so there we go. So that's the color space. But what is the... What are we looking for again? You're looking for... You're not looking for this, are you? Well, we're trying to look for the images themselves. Okay, so here are our images. Do these have a format? Yeah, I expect... Hang on, let's just have a look at this. What are we doing here? Okay, so this is a special... Okay, so that's what it is. It's this. Non-linear... Non-linear... Where? No, it's not. Where's the UNorm and all that kind of stuff? Create image format. Oh, this fella. Okay. What is this then? So, okay. So a long time ago, I wrote this code where we select the color space ourselves, I think. And in this, yeah, what? So you put supported formats. What do I select? Yeah, give me a minute. This is going to take a second to like remember what I was doing. So I am trying to find. Okay, so here we are. We have UNorm. So at the very least, BGR 8. Yeah, it's going to be one of these. At the very least. And I think they're all just the same with basically a different memory layout rather than a different color space format. So I'm putting... let's just assume this is the one we're doing. I don't exactly know. Actually, let's just put a breakpoint in here and see what it assigns to, and then we can figure out exactly which one we're doing. Yeah, so we have VK format BGR. Okay, so it's the BGRA, so it's this one, as far as I can tell, at least. Let's just check we don't overwrite that value. No, okay, we break out of everything. So yeah, it's this one. So we're trying to check if this one exists, then this one, then this one, then this one. Yes, it's definitely this one. Okay, so I don't know what this means. So let me just read a bit what you said earlier. So if the sRGB conversion, then your swap chain image does it again. Everything looks grey. Okay, so is this doing an sRGB conversion or not? I actually don't know. Let's look at the others. As far as I can tell, we're not doing this one. We're using unorm. Yeah. So I don't think it's doing the conversion, right? Does that make sense? Because that's linear. Unorm. I actually don't remember. What is this? Is this linear or non-linear? Is this linear space? Okay. It means you have to do the conversion yourself. The swap chain image is doing. Oh, fantastic. Okay, cool. Thank you for clarifying. It's something I've written and not thought about ever since. So, thank you. Because that's gonna go in my notes then. So let's write some notes. Tone map linear to sRGB. Yes, that's. Fortunately, we're not doing any tone mapping currently. I think the Reinhardt tone mapping looks terrible in my. I'm not saying it looks terrible in general. I think it looks terrible in my shaders. It's likely because I'm not doing the right color. But it did say in my notes, right, that you do. So we fix this by taking the LO and tone or expose the map, the high dynamic range value correctly to low dynamic range before gamma correction. It says or here, right? It seems like we do or a tone map or expose this thing and convert the values from high to low. Reinhardt isn't tone map operator. It looks better with some ambient lighting. Ah, okay. That's good to know. Thank you. Thanks again, Rashid. It's always appreciated. But I use custom fit of some aces. I assume that's some kind of like a nicer tone mapping than just this single Reinhardt operator. Anyway, so let's just talk about what we've just done. Okay, so that was fun. Where is... Okay, so I need to make this small again. Okay, fantastic. Okay. So I need to also do a swap chain image format. Swap chain color space format. When you are dealing with HDR / LODR images when writing your trying to think what I'd when you're doing some kind of lighting in a fragment shader like HDR. Sorry, like physically based rendering. You need to be careful that the swap chain image format isn't already converting your image to linear space, as you can do this twice by accident, making everything look grey. If you're at a very basic level, if you're going to convert the color space yourself, you need to set the swap chain image format, which was in to be a U norm version. If you're not of color space, if you're not doing the conversion yourself, you need to set this to sRGB, which I believe is linear, and in addition to this, you need to make sure that you tell the swap chain what type of space you're working in as well. So I'm just going to get the code in and just kind of simplify everything down. Okay, so we have main. No. Where were we? Okay, so that's the. So I'm just going to copy this in here for a minute. Actually, yes, throw it there. And I'm going to find my create swap chain. I think it's down here, maybe. Yes. Okay, so I'm going to grab all this and simplify it. Fun stuff, fun stuff. And I'll add that note about Reinhard needing some level of ambient lighting for the operator to work. Otherwise it kind of gets grossish. But yeah, it kind of works without me doing tone mapping on top of linear space, which... Okay, so what I'm going to do is basically get rid of everything other than what we care about, which is... Otherwise it's just not... It's just too much faff. So we don't need the alpha. Yes, we need the formats and we need the linear space, and we want everything else. We get rid of this. Okay. And get rid of the check. So it's just easier to read. And then I'll do this kind of thing. So grab this. Whoops. The whole thing. For non-linear space. And then the same again. sRGB. RGB for linear space conversion. And then we also want this, I think, as well. So if I go back to my code, I think we also need to... It would be good if we had a... Is there a linear version here? Alright, so I'm just going to leave that. Maybe not. It's probably a little bit too much here that's for me to say. So I'm going to delete some of my code. Get rid of this. And okay, so we have a fantastic node there. I'm going to get rid of that as well. Nice. Okay, with the context. I've linked it, but it's in DirectX HLSL. So you have to convert to Vulkan GLSL yourself. Okay. Hi. Say hi. What you from? I'm from the UK. Thank you for joining us. We're just doing a bit of studying. We're getting to the end of that though. To clarify, the color space for a swap chain is how the image will be interpreted by the... Right, okay, thank you. Let me write that in. The color image format is how the image will be interpreted. Yeah, no. Yeah, from the UK. I understood. I make those spelling mistakes / grammar mistakes all the time. By the presentation engine. Lovely stuff. Learned a lot. I feel like this has been like the most productive part of the stream so far, which is really nice. In a while. I know it's like, it's nice to see me code a bunch of stuff, but like, at the end of the day, this is going to make me a better coder. So, okay, the difference between unorm and S image is that the magic conversion is just the magic conversion that sRGB does while reading and writing. Oops. Conversion happens while reading / writing. Outside of that, the color spaces data is the same. Yeah, so yeah, that makes sense. I think I'm not going to add that in actually, because I think it's implied. The BGR8A and all that kind of stuff implies that the same amount of data is in both. It's just like how they're dealt with the. Okay, cool. We've written that down, and now we can go back to our thing. We've experimented. I'll remove my Reinhard because we don't have any ambient lighting, so this doesn't look very good. Yeah, I'll just restore this, and we should now have everything kind of looking normal. Yep, that's relatively normal looking. Fantastic. Oh. Okay, cool. Eventually, though, I'm gonna turn this all off because the stuff we're gonna be doing benefits from having no lighting because it looks so dark from the distance. So we'll turn off the lighting again. And we'll get back to studying. Well, actually, I'm going to hit the loo in a minute, but I'll read the chat before I go. The difference between unorm and... But in your case, the swap chain still exposes non-linear sRGB data when reading the magic conversion to linear. While writing, there is a magic conversion. When reading, there is a magic conversion to linear. And while writing, there is a magic conversion to linear. Fantastic. sRGB, right? Instead of linear. Thank you. Yes, I'm just going to hit the loo. Going to put a sign up. This will be BRB. Going to the loo. Yes. I should pause this, to be honest. Okay. Yeah, see you in a sec. Hello, back. Right. Fantastic. Right. So the goal is just for people. I've decided to stop studying when we hit lunchtime. What we're gonna do, I've actually made my lunch. Yeah, I can restart this now. I've actually made a pack lunch, so I don't have to go anywhere. Don't have to make lunch, which is gonna be fun. And I think what we're gonna do, while I scoff some food, I'll move my mic away from my mouth so you don't have to hear that. And what we'll do is we'll watch some videos about probably Vulkan, maybe a vulcanized talk. I don't know. Maybe some fun stuff that you guys want to watch. So yeah, if you want to at lunchtime, which is going to be in 45 minutes. If you have a cool video that you think would be cool to watch while I eat lunch, or you want me to watch, feel free to stick it on, because obviously I can't really do anything while I'm eating, typing wise. So I'll do it more near the time as well. So that's going to be in about 45 minutes, and then I think what we're going to do is move to programming. After all our studying. So we got 45 minutes-ish of studying left, and then we're going to eat lunch, watch some videos, and then we're going to go to do coding for the rest of the day. And then I'll finish roughly around 5 p.m. British summer time, which will be 5 hours from lunchtime. So we'll get a solid 5 hours of coding done, and 1 hour and a half of revision, and it looks like another about 2 hours of studying. So that'll all around be a really good day. So that's the plans anyway. But yeah, if there's some cool vid that you guys know of, let me know. Be kind of fun to pick, watch something that I wouldn't usually watch. If you want to check it out, just either type it in the chat, or if you're not in the Discord, throw it in the resources area, which is down here. Which is Ratchet has posted some stuff. But yeah, it might be good. It doesn't have to be Vulkan related, by the way. It can be anything. It can be, as long as it's computer sciencey. This might be good to watch or something. Something related to computers. Anyway, all right. Now I've said that. Where was I? Okay, so these things need to be done before the gamma correction. Okay. So it's not a good idea to do... Okay. the Reinhard operator works way better when you have some ambient lighting in your scene. This also means you want to do any tone mapping in HDR, not LDR. I don't know if I said this already. Otherwise, things look grey. Fantastico. Right. Next is to figure out where we're up to. Okay, so here we have a tone map, HDR color with Reinhard. We're using the Reinhard operator, preserving the high dynamic range of a possibly highly variant irradiance after the gamma correction. When's the gamma correction done? I'm kind of wondering. It's not something we have to do, is it? If you've done these things, done either just a conversion to LDR from HDR, LDR, or a tone map, or both, in order tone map to linear space HDR to LDR. If you've done both, then you can then the gamma correction can be done correctly, as meaning that your color output will be correct. In theory, because there's no way that I have got my color correct. Just by doing that. I tell you that. Okay, so taking both linear space and high dynamic range into account is incredibly important in physically based rendering. Without these, it's impossible to properly capture the high and low details of varying lights. And for high and low, for high and low light intensities, yes. Intensities. Fantastic. Okay, so now we can go back to what we were reading before, which was this. And where was... Okay, so in the previous chapter, now I can do a new... Now we have that information in our brain. We have HDR kind of mapped out a bit better. We've previously touched upon this in the previous chapter, taking the high dynamic range of your scene lighting into account into a physically based rendering pipeline is incredibly important. As a physically based rendering bases most of its inputs on real physical properties and measurements, it makes sense to closely match the incoming light values to their physical equivalent. Okay, so it is very important for PBR out. What is it? That you deal with high dynamic range properly, which we can link directly here. Both in, just gonna make dealing. Where should I put this? Oh dear, that was not good. It's very important you deal with high dynamic range properly. High dynamic range rendering for color space and your Vulkan swap chain. Is in the color space format you expect. And again, I'll just kind of throw this in here as a note to yet be created. So these haven't been created yet. That's why they're dark purple, which they will be. This is because the nope, okay. PBR takes in real physical properties which closely map what are we doing? Okay, so whether we make an educated guess on each light's radiance flux or use their direct physical equivalent, the difference between a simple light bulb and the sun is significant either way. Without working in HDR, your environment is impossible to correctly specify each light's relative intensity. Okay, so this is because without working in HDR, you can't work out the relative intensity of something like a small light bulb and the sun, for example. Cool. Okay. So physically based rendering and high dynamic range go hand in hand. both. How does this relate to image-based lighting? We've seen in the previous chapter that it's relatively easy to get physically based rendering in high dynamic range. However, seeing as for image-based lighting, we based the environment's indirect light intensity on color values of an environment cube map. We need some way to store the lights in the lighting's high dynamic range into the environment map. Okay. However, seeing as for an image-based light, lighting, we base the environment's indirect light intensity on the color values. Okay, so for image-based lighting, I'm just going to say image-based lighting. We need is based on the environment's indirect light intensity on the color values of an environment map, environment cube, let's say cube map, on a cube map. We need some way to store the lighting intensity, lighting's high dynamic range into the cube map. Cool. All right. Okay, so the environment map we've seen. I'm gonna have to get another drink. Ugh. My mouth's getting dry. Let's get another bottle of water. Drink again. Yeah, so we're getting everything's starting to come together, I think, in my mind, which is nice. Oh, yes. Already drank all my drunk. Yeah, hopefully you're all staying hydrated. Everyone, gotta stay hydrated. Your brain needs waters. All right. Cool. Ooh, got all my wires knotted up. 1 second. Okay. The environment map we've been using so far as a cube map uses a skybox, for instance, or in low dynamic range. We directly use the light color values from the individual face textures, ranging from 0.0 to 0.1, and process them as is. While this works fine for visual output, when we're taking them as a physical input parameter, it's not going to work. Okay, so as you remember that when we take in physical inputs for a PBR, we need them to be in HDR to accurately describe the relative intensity of lights. If you use a regular image for your cube map, you're only going to have the intensity, intensity, Jesus, intensity, there we go, of and 1.0. Meaning that for HDR, sorry, for physically based rendering, PBR, you need the inputs, you need the cube map to be in HDR, not LDR. Alright, cool. Okay. The problem with LDR, low dynamic range images for cube maps. Swag in HDR. Let's just say low dynamic range cube maps in physically based rendering. That's actually correct. I feel like the R is doing a lot of heavy lifting when it comes to this. Anyway, so let's make this bigger. We have this has been fun. I actually really enjoyed this. Get rid of that full stop. Okay. Oh, this is so annoying, this wire. There we go. Sorted. And we want to grab all the blah-de-blahs from here. Okay, so let me take all our notes that we just written. Okay, nice. And diffuse, irradiance, and what do we need to know for this? If you're using all inputs need to be linear. Why do I say that? Hang on. I thought it needs to be non-linear. Oh, okay, so this is the previous chapter. So far, we've assumed all our calculations are in linear space, according to this thing. Calculating lighting in linear space is incredibly important for physically based rendering, requiring all inputs to be linear. High dynamic range linear? Is that a thing? Yeah, you can have. Can you have linear non high? Can you have linear high dynamic range? Let's Google that. Linear HDR color space. Is that a thing? Ugh. It feels like there is a difference between the two. Linear is just 0 to infinity. Oh, okay, thank you. So you can have high... Right, okay, so LDR and HDR aren't linear. Sorry, they can be linear. Because HDR is just a type of linear space. No way, gameplay systems. Yes, we'll get to that in about 20 minutes. Actually, we're going to watch a video. And, well, we're going to eat lunch in 20 minutes. Watch some vids on YouTube that are going to be related to programming. And then, yes, we will dive in for about 4 hours and a half into programming. But for now, we're just studying, coming to the end there. But I didn't know... Okay, so... Right. Lightning. Okay, so if you're using physically based run, it needs to be linear. I need to kind of like... It always trips me up when I see color. Oh yeah, yeah. I will always write the color. It's a funny story. Because I'm dyslexic, I had to like go to like a special needs like room to like learn how to spell in school. And when I was like 11 years old, I like spent like probably about a month trying to learn how to spell color the correct way, like this with the U in. I kept forgetting the U. It's quite funny, like I got tortured unnecessarily if I was American. I would have just been fine with that word. I don't know why. It was like one of the first words that we tried to spell. Long story. Yeah, being dyslexic sucks. In school, at least. It's not too bad now. Anyway. Let's figure this out. Oh, I don't like that, actually. Let's get rid of that, full stop. Anyway, we also need to put that back. And... I came up with like an acronym, like color octopuses something something something. It was like the meta for learning how to spell back then. Right, so what am I trying to do? Low dynamic range. Okay, so I want to make a quick note that what linear space is, because that's actually important. Linear space. What is linear space? Because linear space is not necessarily low dynamic range, which is important to know. That's how I understood what you said there, Ratchet. So linear space just means that your color space goes from 0 to infinity. It doesn't mean that you're in LDR or HDR. So both LDR and HDR can be in linear space. So that's what I understood from what you said. Because I thought LDR was linear space exclusive. Yeah. Okay, so which Vulkan core version you support? 1.3 at the moment. Any assumptions you make that your game will only run on computers that support 1.3? Yes, that's probably what I'm going to do. Or will you have some conditional to enable and disable some very features? As far as I can tell, 1.3 is pretty well supported on desktop GPUs. I've got to be careful though with things like mesh shading and ray tracing. They're two things because you can support 1.3 goes back way further than ray tracing and mesh shading. So that's like the bigger concern. So yeah, it's gonna be running on Linux and Windows in Vulkan 1.3. So there's a bit of a rabbit hole regarding color space, especially with HDR displays and stuff. Yeah, as long as I've got that correct there, that linear space can be both 0 to infinity. It doesn't necessarily mean you're locked in with low DR. If you're in linear space, which is as far as I can understand, that's correct. Linear space means 0 to infinity. HDR can be linear, and LDR can be linear. And if I've done that right, so I can throw this in here. As a note, which is nice. And what I'm going to do is also do this. Linear. Kind of like that. Which is going to be nice to click on. If I'm like, what do I mean linear? Right, okay, so blah blah blah. Okay, that's cool. That's what I was confused about. I'm just gonna put general here. There's definitely gonna be more here. So, what is linear space? I need to read my book on color spaces. I've got a book on it. Well, a chapter on a book anyway. Actually, I do want to stick you two together. So we can kind of navigate this easier. And find a way back. Okay, so let's close these. Maybe not. I'll come back to it. Okay, so next is the problem with low dynamic range and cube maps, which is fine. Let's grab this guy. Yeah, if I was supporting mobile GPUs, I think I'd have to be a lot more selective of what Vulkan version I would have. But I'm going to assume that a lot of people who have like a GPU that doesn't support Vulkan 1.3 really don't have any. They don't have a gaming computer anyway, so they wouldn't be using it to game. So that audience that would potentially play my game is, I don't think exists. This is like its own thing, so I'm kind of like, I don't know what to link it to be honest. Oh yeah, linear. Duh, it's right there. Yeah, so oops. And this needs to be linked with graphics theory. And oops. Physically based rendering, and then image-based lighting. Okay, cool. And yeah, I'm gonna rob this. Put this down here. Now, what am I doing? Get rid of that. There we go. It's grey for a reason. Escape point. Because we haven't made that yet. So yeah, we also need to throw this in. Oh, no, we don't. And next is we need to create this. And so let's grab that actually. Change mind. Oh. Swap chain color space. So this is a Vulkan thing, but it's very important. It's like kind of graphics theory related. Okay. So Vulkan, graphics theory, and physically based rendering. So this needs to go in the swap chain section of Vulkan as well. So this needs to go. Where should I put this? Yeah, I think that is fine. And graphics theory. Where should I put this? It's going to be in both. I'm going to put it in general for now because I don't really know where to put it. It's going to be a misc place until I figure out what to do with these guys. Cool. And let's open this back up. Let's get the actual text in there. And we should have a lovely note to refer to for our vision. Very nice. Okay, so what refers to you? You need to be in there. What is linear space needs to be in here? What is linear space? Need to say yes to the music again. Oh, I love this song. And okay. And this needs to be in linear space, I think. So we can get out of there. What is linear space? Cool. Throw this in here as well. So we have some connections. Outgoing. This needs to be referred back to. Okay. Now, very nice. Very nice. So if I open up my graph, we should see that graphics theory has a bit more going on. And we haven't got the yeah. Oh no, we do. It's there. It's at the top. Okay, so let's go back. Let's get rid of these guys. All right. Let's go back to our thingy, and yes, we're getting very close to lunchtime. So yeah, feel free to suggest a video, guys, if you have a cool video that you think you might want to share. I would prefer it to very much be something to do with game development / graphics programming / Vulkan / whatever, you know, general vibes that we end up going for in the stream. But I have some ideas. I'm just probably going to pick a vulcanized thing, or maybe watch. I don't know. We'll get there. Okay, so I might just nab something from the resource section. Yeah, I think I'm actually quite tempted to watch something from there. Excuse me. Okay, so the Radiance file formats. Okay. Enter the Radiance file formats. Now, as far as I know, I think Ratchet in chat has done a bunch of work on this. Where in his engine he has a conversion algorithm thing. Or I could be wrong. That might be just to do with compression. All right. Enter the Radiance file format. The Radiance file format has an extension of HDR and stores a full cube map with 6 faces as floating point data. I believe you did some. This is a high dynamic range texture. I assume that you did all your compression around converting these to different spaces. Right, I'm just going to refresh this because I feel like we're getting the same few songs over and over again. Or maybe I need a bigger playlist with like thousands of things in. I could be wrong, to be honest. Right, let's go with next. Okay. Yo, this is good. Okay. Okay. The Radiance. Itchy nose. The Radiance file formats is a format that stores the value a cube map as 6 faces I convert these to F16 at runtime to save VRAM. Yeah, that's what I was thinking. In the case of cache hits, I just upload the cached version, which have already been converted. Hell yeah, bro. I love that. I did compress one of those into block control 6H. I don't know what the H is, but there we are. No, it was the first thing. No, it was both, actually. It was both. I know you've been working on this kind of stuff. So yeah, it's really impressive what he's able to have achieved, in my opinion, with this. As floating point data. This allows us to specify the color value outside of the range of 0 to 1, giving the lights, giving the correct color intensity. So this allows us to have the correct light in intensity of a given cube map. Because we are not bound by the limited LDR of 0.0 and 1.0. Alright, cool. Right, I'm going to leave this here, studying wise. And what I'm going to do is grab my lunch and go to the loo again. And yeah, I should be back. I'm going to pick a video. What I'm interested in watching is this data-oriented design thing. This might be things I already know. I'm not entirely sure, to be honest. But while I eat, I'll go and push to talk as well, so you don't have to hear me chew. Or we'll find some vulcanized stuff. So let's just figure out what's on the cards today, and I'll also mute the music as well. So vulcanized. Let's see if there's some interesting stuff for us to look at, like a classic or something interesting. Right. Pick up the new one. I didn't finish this one. This seemed quite interesting. GPU driven rendering in Quest 2 and 3. Streamlining. What does this say? Okay. Right, I've watched this twice, so we don't need to watch demystifying frames in flight. Yeah, actually, we'll watch two. I think we'll watch 2 videos. Or maybe 1. If one goes sideways and it's really boring, then we'll hop to something else. But yeah, it seems like a lot of people are just talking about their experience when it comes to using Vulkan. So what I'm interested in watching actually is what was it? This one seems interesting. Like just getting about the new features. Also we watched SPRV. Seems pretty good. Hard not to be, because I don't really know SPRV that well. It's been a while since I did anything to do SPRV, but it's kind of, I don't know. All synchronization problems with timeline semaphores. V-cube multi-grid in Vulkan. Oh, interesting. But anyway, we'll pick something. We'll pick a load of stuff. Yeah. So I'm gonna go to a data-driven approach to modularity in Vulkan rendering. So there's a couple of things in here that I'm interested in. I will go to the toilet, grab my lunchbox, and then come back. How's that sound? The Vulkan Now and Then. Do you recommend that one? Is by okay. Yes, he's very cool. All right. Well, you know what? Since you've brought that up and I know who that is, I don't know how to say his name though. I'm not gonna lie. That'll take me a minute. Alright, so, well, yeah, we'll check out this one. Yeah, we'll go from there. I will be right back. Let me just Yeah, I'll just say BRB. Can't be bothered typing a big paragraph about what I'm doing. Right, I'll be yeah, I'll be right back. All right. 4 hours. Let's go. Hello, hello. All right. So like I said, I'm going to move my mic away from my mouth and go to push to talk. Just so you don't have to hear me chew. But yes, this is going to be a... I don't know. I'm turning into a React streamer. This is my transition. He said what? Oh my goodness. Mukbang stream, yeah. Yes, it's the last thing we need. More of that. All right, let me just get set up and. All right. Okay, so Vulkan now and then we will watch this guy. He's a very just for people who don't know, he's written the How to Vulkan tutorial. He's very active. Well, I don't know how active actually. He's active in the Vulkan, as far as I know. I think he moderates the Vulkan Discord server. With the other guy, which I've forgotten his name, who's also done a talk. So yeah, we're gonna watch this. I'll talk less because obviously I'm eating, and when I do, I'll be you know, commenting on stuff. I'm not going to be taking any notes. Obviously, this is more of a be productive while eat type situation. So there's a limited amount of things I can do, and then yeah, we'll be on to programming. He wrote the Vulkan samples too. Oh, nice. I didn't know about that. Is that a tutorial? Vulkan samples? Anyway, so yes, let's start our timer. And I'm going to turn up the audio on your end. So let me know if the... Alright, I think I'll be able to tell immediately.
Hi there, and welcome to my talk, Vulkan Now and Then for Hobbyists, where we'll be taking a look at how Vulkan evolved, especially from the perspective of a hobby developer. My name is Sasha Willems. Yeah. Some of you might know me as an active contributor and community member, mostly focused on the graphics standards from Kronos, especially Vulkan. I started out as a hobbyist myself, which I consider myself still up to this day because I do most of this in my spare time. Even as a kid, I was always curious about how games work, how they put pixels on a screen. When I started a few decades ago on a Commodore 64, things were a lot easier though. And yeah, I actually did my first proper steps in real-time 3D back in the days with OpenGL 1.0. which made it very, very easy to get into graphics programming. And without OpenGL, I probably wouldn't be here. Yeah, so I always have a sweet spot for OpenGL, but to be honest, its days are over. And yeah, I was involved with Vulkan when it launched. I watched Vulkan evolve closely over the last decade. And yeah, that's what we'll be talking about today. Mostly focused on the point of view of a hobby programmer. So people that are doing this out of curiosity. And yeah, you might ask yourself, Vulkan as a hobby, why not? Sure, real-time graphics might be a niche, but it's a very interesting field, both in terms of technical and creative side of things, because it kind of combines both. And yeah, I mean, one of the most interesting things to come out of real-time graphics programming are games, and a lot of people play games. And some of them, yeah, they are inspired by games to get into graphics programming, and it often starts out as a hobby. Because yeah, just like me, people get curious. They want to know how those games work, how they put their pretty pixels on a screen. And yeah, with all the talk on how complex and complicated Vulkan is, people often wonder if it's a good API to use for your hobby development. And yeah, TLDR in 2026, I definitely say yes, it is.
Which is kind of interesting because a lot of people say that if you want to do like hobbyist stuff, stick with OpenGL. So there you go. It is interesting. All right.
And yeah, we always got to remember the hobbyist of today might be the professional of tomorrow, and learning a low-level graphics API might be the right gateway to actually someday land a job in a professional game programming company where you do real-time graphics. And I actually know a few people that were able to make the jump into commercial graphics programming and land jobs at larger companies by starting out with Vulkan. Because yeah, low-level APIs are where it's at, and if you know one, chances are high it's easy to get into another one. But still to this day, I see newcomers having troubles actually getting into Vulkan, and that often results in quick frustration. And yeah, we shouldn't neglect that audience. And spoiler, we don't. We have been actively listening to the community. We have constantly improved things, as you'll see on the following slides. And yeah, wanting to use Vulkan for your hobby in 2026 is fine. I mean, a pattern I often see online is like people want to get into graphics programming. They ask if Vulkan is a good choice, and then someone comes up and say, "Oh no, don't! It's too complicated. Use OpenGL or whatever." Yeah, while that does have its merit, I don't think that holds true in 2026. So, for example, yeah, sure, you can start learning OpenGL.
It's like that meme, isn't it, that goes around the oh, it takes 700 lines of code to draw a triangle. Vulkan's too hard. Yeah, I think Vulkan's easier to get into. I think it gets complicated once you try to do more complicated things rather than it just being inherently super, super difficult. And if you're dedicated, you can definitely go ahead and do it. Yes, he also wrote the how to Vulkan tutorial for sure. There we go. It may take 700 lines for one triangle, but you can have millions in 1,000 lines. 100%. That's a people overlook that fact, and the meme is kind of dead once you once you explain that. You know, OpenGL 1.1. Yeah, you could draw a triangle in 30 lines or something, or 50 lines or whatever it was. But it's much more hard. It then becomes much more difficult to do render a model or do some like basic effects that we take for granted. Anyway, let's see what else he has to say.
But depending on what you do in OpenGL, you would actually have to unlearn stuff. to actually move over to Vulkan or other low-level APIs. So let's take a look at the graphics API landscape in 2026. And if you take a look at it and see all those logos, it can be a daunting task. And this is your first step. You have to choose one of these APIs because as a hobbyist, you rarely have bandwidth to learn more than one. There was a point in time a few years ago where this slide would have had a lot less logos, but with the rise of low-level APIs, the API landscape fundamentally changed in different ways. So it kind of fragmented into three different API categories. So on the one hand, you got the old school APIs like WebGL, OpenGL, or OpenGIS, which no longer really map to how hardware works. Then you have those low-level APIs like Vulkan or DX12, which are kind of tough to get into. And because of that divide, in the middle, APIs like WebGPU or STL-GPU rose to kind of like fill in the gap between, for example, OpenGL and Vulkan, like giving you the benefits of low-level APIs without their complexity. And yeah, obviously consoles exist and they also have their own APIs. And even though as a hobbyist you rarely get into contact with them, people want to know if they're kind of close to what for example Vulkan does. And yeah, we don't we have to remember that there's a huge homebrew community. So people do open source and hobby programming on consoles to some extent. And yeah, then there's also the adjacent APIs like OpenCL, CUDA, OpenXR. So depending on what you do, for example, virtual reality, there might be additional APIs you have to learn. And if you're going to use OpenXR and you have an API like Vulkan that plays nicely with OpenXR, it simplifies API choice. I mean, to some regards, this.
Yeah, OpenGL 1x is weird. Yeah, I assumed it was high. High level. Mm-hmm. Yeah, no, that's unfortunately not me. Yeah, don't believe the rumors. Yeah, we're just putting on a video while I eat lunch. An educational video. So you don't hear me chew. I'm a bit quiet and I'm letting Sasha speak on his wisdom on how hobbyists can do Vulkan 2, which is very nice. Yeah, so I'm in push to talk mode as well, so you don't hear me chew at all. Yeah, so thanks for turning up, TT.
Feels like the heydays of 3D graphics programming around 1996, where each and every vendor had their own API. And yeah, that alone makes it hard to get into this field. Like, I mean, what API do I stick with? Do I have the bandwidth to learn more? Will the things that I learn in one API transfer over to others? Will the API still be relevant in 5 or 10 years? And from all of these, Vulkan has the widest and most robust platform support, which actually makes it a good choice to start your journey. I mean, if you get your Vulkan stuff up and running on Windows, getting it ported to Linux, Android, macOS, yeah, it isn't that hard. And yeah, it gives you a nice choice of where to actually go next. So let's rewind back a decade to 2016 when Vulkan 1.0 launched. It had to launch at some point. It was already a bit late compared to the other low-level APIs. And yeah, it might not have been the ideal API that everyone imagined or everyone wanted to have. For example, some people would have preferred a new OpenGL version, maybe something called GL Next, that was to build upon the base of GL 4.6 with direct state access. And yeah, in some regards, people saw Vulkan 1.0 as a step backwards to that modern OpenGL. API decisions were questioned, especially render passes. They were ultimately disliked, made things unnecessarily complicated. And when people realized that those mainly existed due to mobile GPUs, they started questioning why the decision was made to have one API that kind of like fits both desktop and mobile. Yeah, and as for documentation, let's be honest here, adoption of an API heavily depends on how good documentation is. And when Vulkan launched, yeah, we mostly had the spec, which was aimed at implementers and less so what people wanted to use Vulkan. There were very few samples, and that was about it. And combine that with the relatively new concept of low-level graphics APIs, and
It is interesting he says low-level APIs. I've been told by 2 people online, at least, that it's technically not a low-level API. It's an explicit API, which is different. Which is the reason it's an explicit API is because you have to use a lot of explicit language when you're coding Vulkan. No, but yeah. Anyway, he's saying low level. I just thought that was interesting.
how easy it was to get into OpenGL. That made it kind of hard for people to get into Vulkan, and especially for people doing this in their spare time. Yeah, they questioned if this was the right API for them, and you had other issues like lacking driver support.
I think you're right there. The real low-level API is direct commands. That's what I would imagine a low-level API is, like assembly almost. Like, you know, even C in like if we go to the GPU world, CPU world, we have you know, it's an abstraction on the actual language that gets used. I know people call C a low-level language, but I wouldn't call a Vulkan a C, like the C GPU version. Yeah, you could argue both ways. This is certainly bike shedding, 100%. Yeah, it is what it is. Either way, it's Vulkan is Vulkan. We love it, we hate it. Either way, Vulkan is Vulkan. Just gotta watch out for John Vulkan. He's the guy we actually hate. Anyway, yeah, true. Assembly is an abstraction layer. This is very yeah. I just thought it was interesting. Anyway, all right. Let's let the one of the masters speak rather than me.
Mobile, making people go back to old or existing APIs like ELS. I mean, I can relate. Just out of curiosity, I bought the cheapest mobile phone in 2016 that supported Vulkan, and yeah, you could do Vulkan on it, but you ran into arbitrary limits, into slow paths. It was no fun at all. So yeah, ultimately the result, it was a bit off-putting to people, and people moved back to other APIs, were frustrated, and never took a second look at it. In some regards, some people actually, while we're on the topic of gaming, compared it to like, yeah, Vulkan feels like the Dark Souls of graphics APIs. Git guard or die trying, not literally. But yeah, that was the past. Fast forward to 2026, so the present days, and things have changed a lot. I mean, a decade in a field that is moving as fast as real-time graphics programming, that's such a long time span. A lot of time for things to change. Hardware evolved, software evolved, the rise of AI. So a lot of things have changed, and yeah, so did Vulkan. And Vulkan 1.3 with dynamic rendering, buffer device address, sync2, descriptor indexing, timeline semaphores, maintenance stuff was considered by many to as the Vulkan as it should have initially been. In my opinion, it's pretty much the perfect baseline. A few things that were added in 1.4 further improved the experience, but yeah, Vulkan 1.3, that's that's what that defines what Vulkan should have been. And yeah, also fundamentally new functionality was added like hardware accelerated ray tracing, video encoding and decoding, and machine learning, which further improved the API surface. But earlier mistakes have been corrected. Dynamic rendering, for example, replaced render passes. We have lots of new dynamic state. So if you're more of the OpenGL guy, um, there are areas that are now less more dynamic and more closely resemble how OpenGL works. Yeah, so Vulkan is constantly improving. The whole mental model of doing something in it has become less.
I love that line. Vulkan 1.3, this is what Vulkan initially should have been. Oh yeah, without a doubt. The only thing I don't have is timeline semaphores, but yeah, literally everything else is so nice. Yeah, if anyone's here who's thinking about giving Vulkan a try, Vulkan 1.3 will be, it's a lot nicer. You don't have to deal with render passes. Ugh. Anyway.
Harder to understand. And something that's as important as improvements to the API, the ecosystem improved by a lot. We have new helper libraries that are universally used.
If you're not making your own CPU, you're not a real programmer. Yeah, I guess we all suck. Vulkan 1.0 is the great successor to GLES 3.1, which is what it was meant to be. Interesting. Okay.
Like VMA, there are new shading language options. Tooling around Vulkan has improved. We have wide library support. There are other Vulkan profiles. If you haven't heard of them or haven't used the toolset, go take a look at it. It will simplify the boilerplate setup, all the area of having to check for features, enable them. Yeah, they can significantly minimize application setup. We have active communities over at Discord and Reddit. Vulkan support on mobile is improving. Driver stability is getting better and better. Vulkan is now the main graphics API on Android. Version adoption is improving. And last but not least, there's a lot more learning material available, including tutorials, videos, and especially the new Vulkan doc site. So for those that have been put off back in the early days of Vulkan and went back to other APIs, now's the perfect time to give Vulkan a second look. And to give you some incentive, I've prepared what I would call the Vulkan Hobby Starter Pack. So drawing a color triangle might seem nice at first. It might be a nice challenge and it might be rewarding. But let's be honest here. The real fun starts when things get interactive. So being able to move stuff around, to play stuff, to interact with it, dynamically loading things, play audio, do networking. And once you reach that level of freedom, you quickly forget about the early hurdles of the complexity of Vulkan and you actually start enjoying the freedom of creativity. And with the added benefit.
Isn't baking... Yeah, you're not a real programmer. That was funny. If you're not doing lithographic fabs, yeah. Isn't baking a frame buffer render passes initially, using them inside a render loop faster? Even though I know about dynamic rendering, I don't use them. I thought it was slower. Is that not the case? I had that same idea when I was using older Vulkan. And I think it depends on the hardware. And I think on some mobile hardware, it is faster. Because you can use dynamic rendering on mobile. It's just you can't do a particular set of... you can't do deferred rendering. Some deferred rendering things on tiled hardware. I don't know off the top of my head, but I remember finding out that the slowdown was non-existent on desktop GPUs. It literally wasn't there. Because all that you were doing is you were effectively setting up an image pipeline barrier in like a super roundabout way. So if you had your dynamic rendering set up, a pipeline, an image pipeline barrier to deal with your frames, you effectively had what the render passes were giving you. That's as far as I know anyway. I can't say yes 100%. They are 100%. faster or slower or non-existent. But I believe, as far as I can tell, take my thing with a pinch of salt. I don't think on desktop GPUs there is any difference between the speed up. Yeah, so I think Ratchet's also on me at the same. So Ratchet's also saying the same things. Yeah. So so Omega Killer. So it depends what you're targeting. And for me, I had this idea that I was going to target like ancient desktop GPUs, which eventually went out the window anyway when I was like working with mesh shading. So yeah, I don't know what I was thinking, to be honest. So that was my decision from moving away from render passes. It just made everything really, really complicated. But yeah.
Of using an API that's very close to graphics hardware and how it evolves. So my advice: don't give up. Focus and pick the area that you enjoy the most. And to get your help started, this hobby starter pack is a list of like base things, libraries, tools to help you get something up and running as fast as possible that will result in an interactive environment. It might be a bit opinionated, so feel free to replace one or another library or tool with the one you prefer. One good idea is to use common formats for textures and 3D models. In this case, GLTF or OBJ for 3D models and KTX for textures. That way you can pick any model or texture you find on the large sites on the web like Sketchfab. And with a set of headers, libraries, and tools, you can do anything from a simple 2D game to complex physics-based 3D games, even including networking and multiplayer. I actually did make my own rapid game prototyping framework with a very light abstraction based on most of these libraries. And yeah, not only will that give you a framework where you can do prototyping both in terms of creative things, but also technical things like trying out new Vulkan features. It's also a good learning experience on how to integrate Vulkan in a real-world application. A tip from me: do shader hot reloading from the very beginning, because it makes things a lot easier if you don't have to recompile your application or restart every time you change a line on a shader. And yeah, don't over abstract. While object-oriented theory of things are nice on the CPU side, they might not fit very well with how graphics card works. So yeah, don't try to put each and every Vulkan object into its own class. Yeah, go for light abstractions.
That's one thing I never did, which I'm grateful I never did. The mistake I never made was try to abstract everything into like their own objects and use resource acquisition as initialization to handle all my objects, because it's harder than you think to get that right.
The screenshots on the right side, they are actually from prototypes that I was able to quickly create based on what you see on the left with my own framework. There's like a physics-based demo. I did a space exploration and fighting game in 3D with realistic physics. And I also did like a 2D auto battler with some retro style look using a CRT shader. And yeah, with such a framework, it's easy to do something like that, because you no longer have to kind of like create a new boilerplate application using Vulkan from scratch every time you want to test out something. So
yeah, I've seen your code. It's really cool, and yeah, I'm glad I didn't try to make RAII work.
So based on the advancements in the last decade and the hobby starter pack I just showed, I also decided to create a new tutorial for Vulkan from scratch in late 2025, 2026. I mean, back in the days when Vulkan launched, there was the original Vulkan tutorial, and it was fine. Actually, it was great because it helped a lot of people to get into Vulkan. But yeah, it was never really updated to reflect all the changes that Vulkan went through in this decade. And in my opinion, it's no longer fine in 2026 because it no longer does reflect the state of the API. And that might mislead people into what Vulkan is and how you can use Vulkan. And actually, almost on a daily basis, I see people that start with the Vulkan tutorial and then are told, oh yeah, you go ahead, you shouldn't have used render path, you should have used dynamic rendering, or please don't try to abstract something based on a Vulkan tutorial. Yeah, so it has done its job, but
There you go. That happened to me. That's why I started using render passes was because of that Vulkan dash tutorial. Yeah, anyone who's watching who's newer, check out that for sure.
it's time for something better, and we did something similar with doing our own fork of the Vulkan tutorial, but I somehow felt the need to do something from scratch on my own. Both for people that want to start with Vulkan and people that want to get back into it. Like, for example, people that did give Vulkan a try 10 years ago and went back to another API. Yeah, I wanted to give them a place where they can take a look at and see, okay, so Vulkan is very different. I can give it a second try. It does make use of Vulkan 1.3 as a baseline. It uses common libraries, and yeah, most importantly, it does more than just a single color triangle. It actually renders a scene with multiple 3D models using descriptor indexing, and also adds in some interactivity. The models are textured. So yeah, it also lets you experiment once you're done. Like, you can add additional 3D models, you can change the models in Blender, you can use different textures and stuff. I also wanted to kind of like only show the Vulkan side of things. So know how to read C++, especially because I also want people using other programming languages to learn from this tutorial. And the more C++ you use, the harder it gets for people that use different languages to adopt stuff. And while lines of code, in my opinion, is a very bad measure for code quality or API quality, still to this day, people think it's bad that you need 1K lines of code for just displaying a triangle in an API, and they say, oh, you can do with less in other APIs, so Vulkan must be a bad API, which totally isn't true, because that you only do that once. And yeah, it's no longer true. The code for this tutorial, it's less than 700 lines of code for rendering multiple texture 3D meshes. And yeah, finally, it was also a nice learning experience for myself.
Oh, sorry, I was talking to no one. Yeah, it's one of those things. Yeah, VMA and bindless is super nice to have. I think it's just having a nice community when you get like on the GP Discord. I haven't been on there long enough. But I think it's really helpful to have a community where you get basically told not to do something. And I think people in my community, even though it's very, very small in comparison, have bullied me into doing the thing, air quotes there, which is I'm always grateful for. What is the GP Discord? The graphics programming Discord, I think. I will throw you if you're interested. I think I can just invite you. Not that I own it or anything. I can just give you an invite if you're interested in joining that particular Discord. I think you're already in my Discord as well, so it's not. This isn't my Discord, by the way. There you go. But I'll provide a link. There you
go. Sometimes, if you're closely involved with something, like in my case, Vulkan, it's important to change your point of view and look at how things are from the point of view of someone else. And writing such a tutorial exactly helped me do that. So a few closing words. Um, from the slides before, you might have realized that doing Vulkan as a hobby developer has become a lot easier. Vulkan has evolved a lot. It will evolve further. Things will even get easier. For example, see the talks on descriptor heaps, which kind of like throws out the complex descriptor setup in Vulkan, which a lot of people had trouble with. So using descriptor heaps and dynamic rendering, yeah, that's pretty much the perfect API because you can do away with a lot of the old API craft. Yeah, but doing Vulkan can still feel like a full-time job. And yeah, very few people.
Yeah, even though Vulkan has changed and it's got better, it's still difficult. But definitely worth doing. Anyway.
Want a hobby that feels like a job. So yeah, it's you gotta focus on something. But I think doing Vulkan as a hobby in 2026 is fine. One of the challenges is keeping up with the changes. If you've been out of the loop for too long, and the too long might even just be a few months, it might be hard to get back in because things are moving fast. We are at around 400 device extensions, including 15 maintenance extensions. Some call this the OpenGL effect, which is something that we actually did not want to repeat with Vulkan, but yeah, with the API getting so much adoption, with the rise of AI features and machine learning and hardware accelerated ray tracing, yeah, you have to do extensions for those. Another area that's hard for Vulkan hobby developers is making sure your stuff works everywhere. Unlike OpenGL, where the driver did a lot of hand-holding, in Vulkan, this has been moved to the application side. So yeah, you gotta make sure you use the API in a proper way, or stuff might break on other devices. And hobby developers rarely have time, money, or resources to test on all vendors and platforms. So a tip: use the validation layers. They are not a 100% guarantee, but if validation is clean, chances are high things are working properly on other devices. Driver stability is still an issue, but it has improved a lot. Some of the commercial Vulkan games run stable, just like their DirectX counterparts. A tip from me: if you want to test how Vulkan works on something different than your GPU, you don't need a different PC. Use Swift Shader from Google, which you get free from with every Chromium-based browser. That's a software-based implementation, which has wide feature support and lets you test your stuff on a different implementation than your main GPU. And yeah, one thing that...
What did he say?
A tip from me: if you want to test how Vulkan works on something different than your GPU, you don't need a different PC. Use Swift Shader from Google, which
Swift Shader.
you get free from with every Chromium-based browser. That's a software-based implementation, which has wide feature support and lets you test your stuff on a different implementation than your main GPU. And yeah, one thing that simply wasn't there in 2016 was the easy availability of AI models. And that has changed how people actually learn and use Vulkan, because nowadays they ask AIs for guidance. And while some of them do an okay job with Vulkan, due to the complexity of Vulkan, even the better models have problems understanding things. And yes, everyone knows LLMs hallucinate. So they will always give you an answer, but in terms of Vulkan, that answer is often misleading. So yeah, it's a good idea to ask humans for help over at our communities. But yeah, closing.
Yeah, it's a big one, that one. Definitely. I mean, I've harped on this a bit, but yeah, reaching out to people. I do it when I get stuck as well. So it's not just like I'll hop into the Discord, ask questions, people answer. People in like Ratchet and a couple of people have helped me out a lot when it comes to Vulkan. So yeah, it's always good to rather than spam the AI bots that always just give you an answer. Try to reach out to people. And yes, the graphics programming Discord is a great place. Yeah, just describe your problem in detail, and you'll have a good time. Unless John Vulkan finds you, then uh-oh. But we don't talk about that.
Using Vulkan as a hobbyist can be daunting and challenging, but it also can be very rewarding. And there's a list of pointers. Here are a few links to get you started. For example, our documentation site, it's a great starting point. It combines several important Vulkan documentation resources into a single site, like the spec, ref pages, proposals, etc. We also recently added a new simple game engine tutorial to the Chronos tutorial, also available at the doc site, which might be very interesting for hobbyists as it shows how to structure an engine like it would be done in a commercial game engine. There's the Vulkan guide, not the Chronos one, which is a nice tutorial that does GPU-driven rendering. The learn page at vulkan.org has additional resources. And yeah, hop onto our active communities, especially Discord and Reddit. You can find me there. I might help you with your issues, but it's always a good idea if you learn something to kind of like hop onto a community where you have like-minded people and where you get instant feedback. So that's it for my presentation. I hope you enjoyed it. Thanks for your attention. And yeah, let's make Vulkan a joy to use.
Well, you got a rousing applause for your presentation. Yeah. That was fantastic.
Thanks, everyone. Sorry, but German internet is a running gig over here. It always fails the moment you need it. So.
Well, I'm going to break my own rule and cut into the break for about 5 minutes. So if we can get a few questions, that would be great. So did I see any hands?
Hello. Thanks for that video. That was wonderful. Question for you or for the room. Is there any thought to really focusing on universities and students? Last year, I had a conversation with a student at GDC, and he was learning OpenGL in his course in 2025, and he hadn't heard of Vulkan. And I thought that was interesting and got me thinking that universities are, really would be a fruitful focus. I don't know how, but just kind of a general.
Something I do not understand about universities is like, why are they that far behind that they're teaching OpenGL? As you just heard, 2025, someone was learning it and they didn't even know what Vulkan was. And I don't think that's uncommon.
Topic to put out there.
Yeah, that's actually a great question, and that's something we're actively looking into. We do have an internal Discord channel, an educators forum, where we are inviting people from universities. With the intention of doing exactly that, getting kind of like universities to move over from older APIs to like Vulkan.
Yeah, and I'll just say this: if you've got contacts at universities that would be interested, let me know, because I'd like to invite them to the Discord channel. We are working on some curriculum that we hope is kind of a guideline for what the universities could adopt into their own programs. And we're posting that on this Discord channel for those that are interested. We haven't seen a lot of traction on that yet, but we're definitely interested in ideas to improve that. So yeah, that'd be great.
Thank you for the talk. So I use a combination of descriptor indexing and buffer device address. I'd just like to ask, what combination of Vulkan extensions do you think are the best for using the Vulkan API in general and make it your productivity better?
Yeah, so I think one issue that Vulkan has to tackle is fragmentation. I think Vulkan 1.3 is pretty much the perfect baseline if you want to support as many devices as possible. So yeah, it's descriptor indexing, which makes things a lot easier. And once it gains more traction, descriptor heaps. Buffer device address is another one of my favorites. And then you got stuff like timeline semaphores in combination with synchronization 2 to kind of like simplify the synchronization setup. yeah, that would be my sweet spot. There are a few honorable mentions like VKX host image, I think it's called. That simplifies the image upload stuff. When using that, you can mostly do away with descriptors. Yeah, that's probably my my perfect Vulkan setup. Although ext host image copy isn't widely supported yet.
Okay, looks like we're done with questions in the room. So thank you very much, Sasha. I'm sorry that didn't work live, but that actually worked out pretty well.
No problem. Thank you very much. Have a nice conference. Bye-bye.
There we go. Thank you for oh no, we won't keep going. Maybe I do need to know that one, but yeah, thanks for bearing with me while I ate some food. I am fully satiated. So yeah, we are okay. So the next step of things that I want to do are obviously programming, right? Let's just pause this for a minute. Crazy to see dev, sh, graphics programming in the same list at NVIDIA. There we go. Yeah, so I am going to work on this entity issue thing, and I may look at videos and different resources. But yeah, that's the plan of attack now. It's we've done a lot of studying. Programming on stream is kind of crazy. So programming on a programming stream. Yeah, I mean, who would have thought? Oh, is dev sh. You just see her or something? Or oh, is he? Oh, he's. I don't know who dev sh is. Right. Yes, we're gonna have to do the all to restart our music. Let me get my keyboard in the right place so I can actually do something. Yes. So programming time, which is fun stuff. Hopefully you've enjoyed the stream so far. I know I have. It's been a bit of a challenge, but that's why I kind of did it. I decided to do a really long one. Let's just, before we start though, how long have we been going for? What does it say? No idea. Well, oh, it's right there. Nearly 5 hours, so let's keep going, bros. Yes, right. Okay, so let's just boost up stuff. Right, thank you. The end of the talk I just watched. Yeah, I didn't quite know who you were referring to. So let's just make sure we got the lighting and right. So I'm not sure if people are familiar where I'm up to. So I was able to get deleting working without delete swap. So if I go back to my main code, and what I'm going to do here is remove this. I'm going to scroll up. And we should, if I just get to my, yeah, okay, so delete this and change that to erase. Yeah, I don't think anyone's seen this yet, so just so people understanding who maybe don't know what I'm up to at least. So I've got everything in a line, and I've colored. I'm using the debug spheres as like an indicator of what is what. So the more blue we are, the further we are in the buffer along, so that we have this buffer that's accessed through a buffer device address, which is off, and we access this by the instance index. And the more blue the sphere, it tells us how far we are to the end of that buffer device address. Now we only, that buffer that is accessed with the buffer device address. The buffer that we have has 40 elements, 0 to 39. And all it has is, it has two things. It has color, which is why I was able to change the colors, and position. And we index via a, let's just go into our core vertex shader. We index into that particular buffer with the GL instance index. Okay. And with that we have instance rendering based on that buffer. And if I didn't mean to close that, let's open that up again. And how I've managed to do this, I've interleaved ducks and rocks, so I could try and figure out how to delete things. So like this is the beginning, this is 2, this would be 1, this 0. The reason that we've got like purple down here, and you know, is how I decided to change things up recently is instead of having one big instead of having like individual buffer device addresses for each model type, I decided to simplify things on the stream, and that resulted in having one buffer device address. So I did it again. One buffer that is accessed with a buffer device address, so one positional buffer. Yeah, I'm trying to correct my speech, so I might make a couple of mistakes there, here and there. Anyway, that being said, so this positional buffer, we have now one for every model in the scene, and that is why that we index things like this. So one instance render will just render the ducks, and the only difference is instead of having 0, 30, 60, 90, etc., it's now 0, 60, 90, 120. And I was able to achieve the same result with one buffer instead of 2. And I think that's generally going to be the simpler approach, especially for my particular type of project. And I was able, because of that simplification, to be able to delete things like this. So I'm trying to delete the docks, and the reason I have the rocks here is so I can see if anything goes wrong. The other thing is you can see the mesh isn't overlapping anything. That's another reason why it's good to have a wire mesh for this particular case anyway. So yeah, we can do this, and if I throw this into RenderDoc, which I won't do, but you'll just have to trust me, the buffer has shrank. Now the implementation I've gone with is probably the worst for now. So what I do is I take that buffer that has the positional data in, and I actually instantly destroy it based on the current frame. So if we're on current frame that's being recorded and I've deleted something, then I actually recreate the buffer from scratch after finding out that you can't resize a buffer once it's been uploaded to the GPU. And because there's two buffers, because we don't want to have a race condition, we have a boolean here, and that then deletes the second buffer with the positional data in at the next frame. So it's possible, for example, we're on frame 1 here. We want to delete and recreate that buffer. And here we then we'll be on frame 0 here, because I have 2 frames in flight, so it hops between 0 and 1. And once frame 1 has been submitted, then we can delete the frame 0 and recreate that. I've done it with a simple flag. There's a lot of issues here. Recreating a buffer at runtime, although this happens with a mouse press, is slow. Like you got to be careful with this, because it can get really intense. Right now it's fine, and this is just for debugging right now. So you got to be careful that you don't like recreate this buffer like every single frame. So there are better ways to do this, where you have like a large positional buffer that has a bunch of data in, that's like 2 megabytes or something. And that just sits on the GPU, and what ends up happening is you just update the positions within that buffer. You don't actually recreate the buffer, you just kind of move things around. What I need to do right now is, because this works fine, I can officially say without, although it's not the best, without any issue, that the buffer creation stuff, the actual positional buffer that we use for instance rendering, like here, like getting the model position, that itself is dealt with. Like I will need to come back and fix this, but for now it's dealt with. What isn't dealt with is what we do with the positional data itself. So the positional data gets updated here. So this is the actual, like, if I add physics, for example, this is how I update the physics. I check if it's the player, if I have to do the player, I have to do something slightly different. As far as I can, yeah, so I have to get the character. A character is different from a body, a rigid body, so we have to do something a bit different here. But apart from that, it's very much the same. We upload the positional data based on the current transform of that particular piece of data. Sorry, that entity or whatever. The problem is this guy right here. So when I delete something from the array, if I do a delete swap anyway, it completely breaks. So I'm not entirely sure, like, how much memory how much of a time save this is, but as you can see right now, this is the deletion key. When I press 0, I delete something. This actual piece of code I don't like at all. The only reason I have this in, by the way, is just to delete the rocks as well. We don't have any stable ID, so when I actually like access this element or go into here and access this through this entity index or whatever, it's not very stable. There's no way to refer to the same model once the deletion has happened, and that's kind of awkward. You know, even if I was to have like a 2 megabyte buffer where I move stuff around in the thing, or remove an element or whatever, have like a sparse array, like a sparse set of positional data or whatever, you know, all those things, we still need a way to refer to this. Now, people have said, why not use end? Why not use this and that? And I've tried to use multiple with no success. I have been working on this. So this has been a way of doing this stable ID thing, where you can remove an entity without and still referring to it later on. And it looks promising, but it's a little bit too feature full, if that makes sense. There is too much in here that I don't want. So yeah, that's the idea. I need to be able to safely delete something and still be able to refer to the same elements. And deleting something right now is very slow because of this erase function. I don't even know it's correct the way I've written this erase delete. But ideally, I would want to have a delete swap on all these guys. But I'll show you what happens with a delete swap, and you'll be able to see like what I'm talking about. So yes, we should see this guy, and then this guy, and then this guy, etc. But if I delete one, then everything kind of goes a bit weird. You can see stuff down there happening. So it is like, then they get deleted. Which, does delete everything in the scene, but it's not correct. Now, I do have a way to store the actual index of that entity that's been deleted, but when I do a delete swap, it doesn't really matter anymore. It kind of gets all messed up. So what I'm thinking is instead of trying to modify this individual, like try and figure out like a slightly better way of doing this and moving around this data and all that kind of stuff, we're effectively going to try and create kind of like a bit more of an abstraction based on this implementation by Pazzaworks, but without all the features. Like I've already removed like most of like a big class here that wasn't needed. But instead of using a standard vector, we're going to use our vectors. Sorry, my code. Because it feels like I'm close with this idea, but I just need to like remove everything because I don't really care if something's valid. I don't really know what that means. So that's the first thing I'm going to try and get rid of. I'm going to try and simplify this down as much as I can. So yeah, yeah, because we have a reverse. We got to deal with the reverse ID. It's very confusing. It's yeah. So yeah, let's dig into it. So yeah, feel free to ask me questions about this. This is found on Pazzaworks' GitHub, but I'm gonna get rid of a lot of the stuff that I don't care about. Like I don't need a capacity function. We do need some kind of management system, and again, I won't have this at all. Guess I'll just make data public. What we need is we won't have a remove if, really. I don't care about this. So my idea now is to make this as simple as possible. So I just get this stable ID idea. Because I tried to write this thing with just like a random like index thing that has the reverse iterator in it, but it just didn't play ball. So I don't need to remove if, really. This free slot thing is the thing I really don't understand, so we're going to dig into that. We have pushback, which is what I kind of care about. We don't have in place back, so I can get rid of that. But I'll come back to that because we actually use that function. I need to like, that's what I want to get rid of. Can I get rid of this? Yep. Yeah, I guess I could have those, but I don't really. Yeah, we wouldn't have these either. The reason is because I'm going to do this. We're just going to have everything public. And the other thing I don't quite understand is why don't you delete swap this? This is the thing I don't get, but we'll get there in a minute. Get rid of this. Is valid. Is valid ID. Is that used anyway? I think I like this function. Yeah, this is the thing I do not understand at all. So if meta... oh, hang on, sorry. I've been blasting your ears out, haven't I? Sorry, I apologize. The music is probably really loud. Let me turn that down. Hopefully that's better. Sorry about that. Let me know if that's better. Sorry, I forgot I turned up the mic because of the Vulkan talk we were doing. Yeah, I'm just gonna have I'm just skimming through this. Oh, I didn't start the timer. Okay. Let's get into it. So the first thing to figure out is... Okay, so in place back, I don't really want a forward iterator. We'll have to implement one. I'm just going to kind of go, alright. Kind of like this idea. So I'm going to get rid of that in place back. Yeah, so I'm just going to make this as simple as possible for our particular needs. And let's get rid of that. This thing. And yeah, here's the thing. Like, why would I ever want this? What's it? Do I even use this? Alright, so we're going to dig through this a bit more. I think we could just have an ID in here. Get rid of this. And now what we want to do is that. So anytime we have a reverse ID, we do this, this, and this. I think that's going to work. Alright, let's just have a look. Yep. So, simplify it again. Okay, so let's get rid of this commented out code. So the rest of the utility functions, we don't need this. Reserve. Nope. Oh, I don't want to do it. Will I ever use that? I don't think so. Yeah, get rid of this. Alright, let's do this again. Okay, so here's something I don't understand at all. When you do a... Why didn't you just pop back? The metadata thing. Is this what I've been doing, right? I'm kind of confused. So this is me trying to break it. Like, how does that... Okay. So I never could understand this. Alright, I don't really care about anything else. So, if I delete enemy, then I want... let's try this. Alright, cool. I'm just going to head to Lulu again. This is what happens when I drink too much water. It's pretty annoying. Be right back. Be right back. How big can this go? Okay, that's the biggest. Alright, see ya. I know, yeah. I've still got it because I'm on Windows 10. It has no AI in it. It's so nice. It's lovely. There's no ask ChatGPT or whatever it's called. What is it? Copilot? Yeah. Anyway, so let's keep beating this up. I think while I went for the toilet, then I realized the benefit of having this idea is that you don't have to. I don't really get it though. Like, I think the point of this is, let's go to this now. So you don't have to push back this array, but like, you have to push back this though. Alright, I'm gonna just simplify it for now. And oh yeah, get next ID. Hang on, what did I delete? If size is, if this is greater than that, I'm back. I was fixing a vertex. Your vertex buffer, fantastic. I hope your vertex buffer is all fixed. If not, I hope you made progress. I need to plug you guys in. My laptop's dying. It's actually done quite well. It's been what? How long since it's been up? I think we looked earlier. 5 hours and 17 minutes, and it's just now gone into power saving mode. All right. Sorry, I just need to check this other thing. All right. We are data. Okay, so here's the key, right? The indices. So get data index. You know what's going to be helpful, I think? Oh yeah, sorry. Let me work this out. So if size is greater than, which it'll never be, get metadata instead. Metadata stores the reverse ID. Actually, I'll just put this underneath. Oops. It's fixed. All this Vulkan talk gave me ideas. Hell yeah, dude. I love it. Right, let's continue simplifying this. So yeah, I think it's useful to have those. And this is the... Okay, so I'm actually kind of interested. When I... What stores the... It's the meta struct, isn't it? What's the indices? Right, I'm going to turn up the music. Let me know if it's too loud, guys, just for my own sake. If it's too loud, then I can always turn it down again. Yes, I've just started. We've just so you're aware, we finished the studying. We did the revision, which I think you were here for, and now we are on. Yeah, I'm glad you could appreciate my music taste there. And now we are trying to simplify this code, which does exactly what I want for the most part. But we need like so little features in comparison to what was in it. And then I'm going to write my own code version. I don't think I care about this at all. I don't know what it means. What's next ID even do? Yeah. Like, I'm never going to use that. Let's just get rid of it. Is ID valid might be useful. Because what I need to be able to do at some point is... loop through all the entities. Let's see if I can do that, unless I've wiped out too much code. Not yet, no. This works, but it doesn't do what I want, so I'm trying to simplify it and do it the way I want to do it. So to get the actual thing I care about, I just need to pass in the IDs. So I'm going to try and loop through these guys, because this is the important part. This is effectively my draw routine. And what I want to do is... so, yeah. And then I don't want to loop through... I need to pass the entities in that... So what I'm going to do is... So that creates... So we need a list of entities. So I'll just go standard vector. uint 64t. So these are the IDs. I don't really care about the reserving size or anything like that. So as far as I can tell, I can probably just do a simple pushback into an array like this, and yeah, so I don't really care about the numbers. We're only interested in the text, to be honest. So we should have stable IDs in this list. And then we go and say that's player. Oh no. And then we delete this thing. Okay, so now what I want to do is for all the entities in that list. IDs still work, which is fine. I want to say entities. Is ID valid? IDs I. And I say if it's a valid guy, give it a go. So I hope that this works. Because I'm going to modify this thing further as well. So subscript out of range. Where's that gone wrong? 1. Oh, right, okay. Let's... do that then. Nope. Okay, so I've broken this too much. Let me guess, 1, index 3. Wait, what? Why is this saying it's valid? I haven't deleted anything out of is valid. Let's get rid of this maybe, because that's what it originally was. Do you think you need... Do you think... don't you think you need a vector of entities? Don't you think you need a vector of entities? It's nice to have something that's contiguous in memory so I can loop over it very quickly. That's the idea anyway. But for some reason we are looking up. Why is this true at 1? Let's delete 0. And then we can debug why is valid is returning. Yes. It's good for the buff for cache locality. That's why you would want that. 0. Why? Isn't that an invalid ID? No, I think this is wrong. Let me try and think about how to check if something's valid. Okay, so this isn't. Okay, so we need to expand this a bit. Okay, so if m underscore data dot size is equal to the reverse IDs, which is the meta struct size, then oh yes, needs to do this. Then we can return true, I think, instantly, because nothing's been deleted, so all the IDs are valid. Next is okay, so when I look this up, I do this. I need to figure out if this is the last slot in this array thing. Yes, for fetching data, it's faster if you have a contiguous piece of memory. Memory lookups are expensive relative to computation on the CPU. I think you've actually... if I go to resources, I think you may already be familiar with this. It's this idea, right? I believe this is data-oriented design with all this cache locality stuff. I don't get your naming. Oh, right. Okay, so this is someone else's code that I'm just slowly destroying / changing. This will be something else. This will be entity manager or something. Yeah, so yeah, forgive me for that. This is Paz's Works GitHub repository, which I'm modifying for my own needs. Okay, but right now I've kind of broken this in a way that I'm going to just have to press Control Z, which is annoying. Let me do that, copy and paste again. There we go. The naming is alright, but I don't... The naming is alright. Naming. let me... Oh, poop. I didn't mean to do that. Oh, that sucks. Press the wrong key. Okay, what was I deleting here? I think we're pretty much back to where we were. Let me work this out for a minute. And I will get back to you momentarily. Is valid. Oh. Validity. Alright, let's do this again. What I want to do is... Okay, so... Is valid? What's the validity ID? Checks if the object is valid considering its last known validity ID. I don't know what that means. Let's go with that. No, it's the same issue. Okay. The naming is alright. I don't really understand that question, or if that's referring to... Yeah, I don't get what... Yeah, I just don't get what is what. Oh, okay. Neither do I, to be honest. That's why I'm trying to figure out what's going on a bit more. Okay, but I do understand a little bit what's happening. So this is not my engine. Just straight up, just let's start from there, right? This is my little scratch pad of code where I just kind of edit things. So this is nothing to do with my code at the moment. So hopefully that clears up that. I'm just confused about the naming, is fine. Oh, yeah, I just wouldn't call it vector, personally. So, for Mado's sake, yes, I see what you're saying there, Ratchet. This is just someone else's code, which has stable IDs, but it doesn't work in the way I expect. And so I'm trying to modify it so I can use it in the way I want. It's a bit too restrictive. And that is what we're trying to do here. So this has 3 different vectors that kind of can be translated to any type of data structure. And it has a reverse ID system where you have this meta, it's called metadata, but it's like a second struct that takes an ID, does a reverse lookup bit with this reverse ID, and then gets the actual data that you're interested in based on that index value lookup. Now this is fine, but what I want to be able to do is loop through all the things, not just the data, right? The data I need to refer to because it's going to be a positional buffer and all that kind of stuff. That's like fine. Or no, this wouldn't be. Actually, I wouldn't have this data in here, but it would basically. This is like a stand-in for like arbitrary data that we would end up using in the Vulkan as a buffer or something like that. And we have a 3 vector. Yes. So the idea here is that we move an element to the end. So here's the magic, right? The idea is we do a pop and swap on data only, and we just do a regular swap on these guys based on the data ID that we got from indices. Then we do the swap of the indices around, and effectively we can reuse this these indices that have been moved around as like spare index slots, which is fine. It does what it describes nicely, but I don't really understand how to loop through all the things based on their index. That is eluding me, because that's the whole point of what I'm trying to do here. So if I've indexed 1 and I've deleted 1 and I've deleted index 2, but I have index 3 as well, I want it to go 1 skip 3, right? Or 1 don't do 2 3 kind of thing. Jeez. Oh, I'm just gonna get another small drink. I drank too much recently, but my throat is getting a bit tired from all my yapping. So yeah, just another BRB. Just while I get a drink. Alright. I don't know how regular streamers do it, dude. Alright. So let's figure out how to use this thing before I break it apart, hey? I think that's the biggest... Oh, okay, yeah. Because that's what I've been doing wrong, I think. I've been breaking this up. Because it's completely useless if I have to refer to each... If I can't do this, I need to be able to do this. It's possible then that I need to get metadata or something? All right, so what does the index operator do? So index ID, let me get this. That's the data ID, excuse me. And that's the last ID, I guess. So let's look at dot in. Maybe I could do this differently if I loop through. Okay, yeah, we're gonna make that public. Yeah, I'm just trying to figure out how it would work. In our case, okay, so that's gonna be accessible soon. So I think I can then do this idea. Oh, did I? Oh, hang on. Yeah, I need to make it public. I think it's private twice because C++ programmers do that all the time. They like add private multiple times. Entities. Right, so we're just going to loop through all these guys and see if I can do that without an error. Nope. And it's out of order. Right, that's not good. This is completely breaking apart in the way I don't want. This honestly feels like my code. The way it's breaking, it feels it's breaking exactly the same way. Hello, MC Fire, MC Crossfire even. Yeah, we'll figure this out. We'll get there. I mean, we've got a long time to try and do it anyway. Data index. Okay. Get data index. Is that what we care about? All right, I'll try it that way around then. What does it need to be? Because I know it seems silly, right? The way this worked originally, before I did this pushback thing here, was it just went, oops. It went ID, so and then it was like, oh yeah, you can delete this guy. And then you can access this guy very easily. Now, I could already do this in my code. This works fine. And you could also, let's just delete one instead, I guess. Let's do 0. What programming languages do I know? I know C++ very well. Well, kind of. C and C++ are the languages I know. I know a bit of Python. I know GLSL, which is a shader language, which isn't that hard to learn. I know a bit of Python. I did that back at my job. And that's about it, to be honest. I feel like once you know a language really well, it's very easy to learn other languages that are very similar. Oh, CMake. I know CMake. I know CMake enough to get myself in trouble. Right, okay, so let's get rid of this for a minute. So I could already do this. I could already just store like what the index was and then just get it out again. What I need to be able to do is loop through the indices, the indexes, once they've been deleted. Because otherwise, you know. So when I do this, let's just see the error. So ID 1 has been deleted. Let's try and... What's the error? That's the actual error. Because maybe I could build a out of bounds check or something. So let's write some code. You don't know any CMake to get yourself in trouble. Fair enough. Yeah, if you've seen my CMake, it's very basic. I don't want to learn CMake, so I do this very basic CMake stuff. So if I say that this value is greater than... Oh, oops. Or equal to... m.size, I think. Then... Oh, what do I want to do? This is just a reference. I want to skip this, and I don't know how, because it's returning some arbitrary type. Yeah, pretty much. Yeah, I'm rolling my own entity system. What are we doing? So if I return, what do I want to return here? Obviously it's like false, but that's not going to make any sense. Because this is just a type. I mean, I could do this myself outside the loop, but it's a bit scruffy. Like, I could do this type of check in... No, let me think. Because what I can't do is this. Because it's like, what does that mean? You know, I think it would compile. Let's just actually check. No. Okay, good. What would be a not I don't want to do a standard exception. What on earth would be appropriate here? Okay, let's just try this insane idea. Where I reverse the logic. Oh, wrong way around. And I throw this in here. I'd assert here. I want to be able to just skip it and just be like, alright, yeah, chill. But maybe you're right. Because that's does not work very well, because what happens here? You know? Huh? Because I want to just write a for loop where we go through all the IDs and it just goes, oh yeah, that ID doesn't exist, so we don't do anything with it. Did you use AI in this project? No. I've never used AI. I learned to code long before that existed. So I just continue on as things as usual. Alright, let's see. I don't think it's possible, is it, to deal with this subscript operator and have like a return type when the type T is so generic? There's no like yeah, there's nothing here. It's like assert false is the only thing I can do. I just don't see any other way of trying to fix this. But then that kind of leads us back to where we were, where it's like, if I have an invalid ID because something's been deleted, like, how do I say, is this valid or not? A lot of the is valid checks requires this validity ID, and I'm just like, what? And this valid ID just doesn't. What I could do is, I got an idea. Okay, so for this, I think I know how to work this right. Personally, I'd set up iterators for this container. Range-based for loop. Yeah, I'm probably, what I'm going to do is at very least set this is valid ID. We know for a fact that this gets smaller, so M data gets smaller, right? If this is smaller, then we're basically going to do this check. At the very least, we can do this check, and at the very least be able to check. Although it won't protect us completely. Please provide information about CRUD in Python. That, I believe, is networking, and I don't know networking. Networking programming, unfortunately. My expertise, if you can call it that, is Vulkan and graphics, and yeah, it's a bit of a that's a bit of an ask. So if this is less than the size, then we know at the very least this is valid. So if I'm looping through all the entities that exist, and I get the IDs, which are stored in, yeah, indices. At the very least, I can do this. And it's not ideal, but this is what would be happening anyway. Yeah, this. How do I get at this? Yeah, I need the is valid. Is a valid ID. Then I get the ID in here. If that is true, then ooh, got an extra subscript here and here, which I don't need. So if this is a valid ID, then we can do this. All right, so let's get rid of that because it's no, this one. It's not going to work. So let's actually get rid of these altogether. Yeah, maybe standard optional is going to be the option, but I want to be, yeah. I don't know what a standard optional does if you loop through it. And trying to do something on a standard optional, it doesn't exist. So it might lead us back to the same situation. Alright, let's have a look. Okay, so we've got player 1. Okay, so that worked. My change. The downside is it's basically the same as before. So annoying. So we've ended up back at the same situation. Okay, let me show you why. So I'm deleting this. So what I really want to see is the output of this, right? So all I'm doing is printing these strings. So, you know, index 0 should be player. Index 1 should be enemy 1. And this should be 2, right? Output. So you can see that in the list, right? The problem is we have a player, enemy 2, then enemy 1. These are back to front, and if I were to delete player, we should see it even more out of order. So it should be matching this order, right? It should just be enemy nothing 1, 2. Okay, enemy 2's there, and yeah, you know what I mean? It's like I'm kind of back to square one with this idea. So maybe and the whole point of having this ID anyway is to make sure that we don't access data directly unless we absolutely need to. Right, let me think about this a bit more. Let's chew this up. Okay, I'm just going to print something else as well. I'm just going to make sure that this works. I thought this was a independent, sorry, a Alright, so that's not worked, but I think what I can do is maybe have a standard vector like we did earlier and loop through that instead. So if I do dot pushback like this, I think this might be it. And then if this works, then I can beat it up. So we have a standard. Yeah, so we want to access this. We say 0. Just an extra layer of indirection that stores the actual arrays, which I might just store inside the actual in the actual data structure. And then we should be good. Right, so I'm just gonna get the last guy. Oops. -1. Okay. Right, that should be in order as far as I can tell. Yep. Yep, the deleted player. Okay, so let's go to this. So if we have a way to loop through each ID, so what I'm doing here is just making sure that one array is bigger than another, which is kind of a bit random. Okay, yep, music's still going. Yay, we won. Woohoo! Okay, so the problem is for me, I don't really understand. Like, this seems super simple. This could be like vastly simplified based on what I've just done. All we do is we set default indices into the data index. Yeah, okay, now we're dead. What I'm thinking is, okay, so we have a positional buffer. What was the point of this? I'm starting to think that everything I was doing kind of here is just fine. Like, what is this even achieving? Because I could literally just do what I did in my other code base and just be like, alright, it's fine. Hi, how you doing, dude? I hope you're having a great day. We're just trying to get some game stuff going. What have we got? Right. Okay, so I think okay. I'm convinced after a bit of thinking just then that when I delete something out of a buffer for a position, I just cannot use delete swap at all. It just does not ever work. Because what I'm doing is effectively saying that at position 0, you belong to the player. That's the position of the player. At position 1, that's an enemy. At position 2 is another enemy. At position 3 is a third enemy. When I do a delete swap with one of the enemies, then all I do is I move the, let's say, delete enemy position 0 because the player killed it, and I do a delete swap that swaps the last enemy's position with the current enemy's position and the one I just killed. It just breaks everything. I just can't see a way of ever getting that to work. And if the index that I get out of this is like corresponds is in this data structure here, then there's literally no way I can use a delete swap ever, because these indexes index into the thing I've just deleted. If that falls out, meaning that I mess around with the index in here, this refers to these two, that refers to these two, then everything breaks again, because it's just an indirect version of delete swapping these guys. So I'm convinced that if I do this again, are you making use of Mesh Optimizer? I am actually, yes. Mesh Optimizer is one of my favorite libraries that have been found. I'm not using it very extensively, but I did use it when I was working with mesh shaders very extensively. That's when I used it a lot. So look, I literally have already solved this problem. I don't see a way of doing this in any other way. I've been thinking about using it and noticed it was in your repo. Is it easy to use? Yeah, totally. The comments in Mesh Optimizer are pretty extensive, so if you were to use a function, so the only function I'm using right now, admittedly, isn't the mesh used for Mesh Optimizer, but I'll show you what I mean, at least with the functions. I think it's down here. Where do we set up the positions? Okay, so if you go in Mesh Optimizer, okay, that was a really bad example. But yeah, that's what I was looking for. Like these comments, right? Like it explains the function very well. Sorry, that was a terrible example I showed you initially. So yeah, if you wanted to like reorder your vertices, for example, to have better mesh something or whatever, I don't know what you're doing. But yes, it's very nice to use. And it's they're free floating functions as well, so because of that you can very much, you don't have to, you can put it in any namespace, there's no stuff that's going to go wrong. But yeah, I'm just pretty much using it for one function right now, which is the turn a float into a half. Anyway. Which is a pretty bad usage of this library, but I have used it for other things. No, it's fine. Yeah, you can ask me questions. If I am getting distracted, that's my fault, right? Not your fault at all. No, so feel free to ask any questions about anything. So Mado has said you need exactly 2 vectors of the same size and one more vector. One more vector to hold the data. One vector to hold the data, one vector equal to the points owner. One vector to hold the data, one vector of equal size to hold the points to for that owner data, and another vector to point to the first vector. yes, that is what I gathered from your code and this code, right? But do I ever want to do this? Like, this is the only thing it's useful for. It's not really useful for what I want. Right now, at least. What it's useful for, right, is... This code is useful for this. Oh, I've labeled enemy... which one did I delete? Yeah, okay, all the enemies, so... yeah, I want enemy 2. Give me enemy 2. Do something with that. It's not useful for this at all. In fact, it actually gives you access to these, to the actual underlying data. So what I was hoping to find effectively was a way to allow delete swap to happen, while also preserving the order of the positional buffer in a way that just allowed things to work. But it just does not work at all that way. And it's potentially useful for future applications. Yeah, making a little mini ECS, but I've convinced myself that what I wanted was just impossible. You have to do it like this because you delete swap, it gets messy. Yeah, 100%. Yeah, once you delete, you lose the position. So you use F to 16 intrinsics. There is an intrinsic for that. Let's have a look. What compiler is it for? Is it for every compiler? I'm just gonna look up this because it would be nice to have like if I can reduce the amount of function calls. Let's see. Right. Yeah. So. Yeah, looks like it's a standard intrinsic. Just like anything else. Right. I won't dig into this immediately, but because I don't exactly know the assembly. Sorry, the Intel blah de blah for it. Okay. Let's have a look. Let's just post it in chat. So let's So TT said you can do it. You can do it. You just never index directly into that. The problem, okay, so here's the problem for me. It's not the CPU so I'm just going to read TTs for a minute. So it's not like that buffer itself is going to be ever indexed in on the CPU. It's going to be uploaded to the GPU. And for some reason I thought maybe I could figure out a way to here, right? Here I was like, okay, this is the CPU access, right? This will be the CPU access of that buffer, this is the buffer, right? This is the buffer data. And this is something that it would guard me against, for sure. But what it doesn't guard me against is this, where I have what is it called? An instance index that indexes into the buffer, right? Because this is a direct index, right? Literally what you described. You can never index into this buffer directly, which is what this is doing. Hello. So we are kind of stuck with our implementation with this, as far as I can tell at least, because this is accessing a buffer directly. And based on that instance data, it needs to be in order, otherwise everything falls apart. And that is, as far as I can tell, the only That breaks everything that we've been trying to do completely. Yeah, you would have to do something else on the GPU then. Yeah, exactly. We'd need to kind of figure like an offset or kind of like have a separate index. I mean, I haven't got into a situation yet where I just need to have... Oh, I thought it stopped. I haven't got into a situation yet where I need to kind of pick at anything that's useful when it comes to deleting... sorry, when it comes to accessing like the actual, you know, I don't know, like I want to change the color of enemy 70 because it's got it's leveled up or something, right? That's what this is for. What Mado has in his code, what this code is for, it's like you can access entity 70 and do something with it, right? Even if you've deleted other things in the scene. But for me, I'm like, I want to have the positional data all in an array because I need to upload it to the GPU anyway. And I just can't do a delete swap on it. Because on the CPU and the GPU, they're relying on the order being the same. Which is fine, right? It's a good thing to kind of figure out at this point, because it's like, okay, we don't actually need to do that anymore. So yeah, let's have a bit of fun, and it's both the magic happens when you delete an entity. Yeah, the delete swap and all that. Yeah, it's pretty cool, but it just does not work for me because it is positional data into a buffer. It's like if I deleted something out of a vertex buffer, right? I think people are more familiar with vertices in vertex buffers, and if I deleted like I don't know, element 7 out of a vertex buffer, then I like made sure that it was all contiguous again after deleted vertex 7, packed it all together. But it's like if I did a delete swap on the vertex data. Now I've taken vertex data that's at the end of the buffer, swapped it around, and yes, it's all contiguous again, but the data's all screwed up because the index, when you do an index draw call, it goes from 0 to n, and n being the end of the index. So it kind of breaks it all apart. And I have the same kind of situation here with the positional buffer, where it's like we go from 0 to n on per instance rather than per index. And it might work. There might be a way around this, but I just don't see a way around it right now. You don't leave gaps in dense arrays. Yes, exactly. That's why you need other vectors. Sure. Yeah, like you would have other buffers. Sure. You update the buffers again. Yeah. Yes. So let's dive into it because I'm kind of interested. The AVX2, which I think most computers support nowadays. Well, there probably is 256 CV TPS and it is PH. Okay, so let's have a look. This is like a really cool website that Intel has, by the way. It's like one of the coolest so how this is converts a packed 32 float element to a packed half precision 16 float. Stores it in the destination. And let me look at my notes for for SIMD. That would be in the performance section. When you're doing SIMD, you would need to. So that'd be pair 8 for AVX if you're 100% AVXing. Here's the thing: the compiler might even flip and do it for us. You know what I'm saying? Yes, thank you. I'm not that. This is just for fun, more than anything useful. Okay, let's start the music again. Have we finished all the music? Why is it stopped? All right, sorry. Let me reboot this. Okay, so pair 8. No, actually, I gave up on this idea already as well. Sorry, I'm giving up on stuff. Okay, let's the reason that I would need to store the data in SIMD, and I would just thought, hang on a minute. If nothing else is installed in SIMD, this is gonna be really annoying. Okay. We'll come back to that a different day. We just know it's possible. Okay. Right. What do we need to do? We need to make this deletion code make a bit more sense. So. Yeah, because that's my what I'm doing is loading everything into a. It's not a vertex buffer in the strictest sense, so I would have to like figure out how to make sure that gets uploaded to the GPU with SIMD intrinsics in the. Sorry, GPU. Sorry, I'm just trying to think at the moment. Let's come up with an idea. So what I'm thinking is actually this might be useful. I know I've just flipped again. Apologies. The reason I'm saying that is because let me load up the game, like actual. Let's see the game, right? So yeah, just bear with me a minute while I get rid of all the demo code for a minute. Where is everything? Oh, come on, there needs to be a good banger. Although expander's kind of cool. No, I'm just scrolling down. That's why I clicked on this. I'm in the mood for. Yeah, let's do this. Okay, cool. Then I'll put on shuffle again. Anyway, so yeah, I'm just gonna add all the player. Okay, it's the player camera. I want the player camera updated. Let's see, where is the player? Okay, cool. Everything's good. Okay, so we can reset the player. Very good. Okay. And we need the scene now. Where is the scene thing I care about? Yep. Alright, so let's reload this and throw in... So, people who have... it might be like, oh my goodness, we're seeing the game again. And we aren't updating the player. That's okay, that's what's happening. Give me a moment. That is supposed to happen. That was to stop the player kind of moving around on its own once I removed the player camera. It's around... Here it is, okay. Yeah, because you don't update the player. In fact, why is this here? This should be... I'm going to move this. This is a stupid place to put that. This should be in the physics area. Alright, cool. Yeah, 6 hours live. I'm going to go for longer. Okay, so I'm going to fly around. I crash into this rock. Oh no, boom, right. We should be able to access that rock by ID to do something with it. And this by ID, right? That's what I'm thinking, right? It's not useful for what I wanted. What it's useful for is finding... All this does... this code, anyway. All this does is allows me to easily look up something by a number. Regardless of what's happened to everything else. So, that is what I think we should be doing. I notice you're using Jolt. I've been working on a 3D physics from scratch for 3 years. But probably just 100 hours in. But probably just 100 hours in at that time. It's really hard, haha. Or maybe honestly, I wrote a physics engine. It took me... I was much worse at programming. And I was doing my degree at the time. So it took me my whole university time to program a physics engine. And it was literally from a book, so it wasn't even that complicated, you know. I totally understand like how hard it is to write a physics engine. That's why I don't want to write one. So, you know, if you're feeling Noah, if you're feeling that it's kind of like it's kind of a rough situation to be in, I totally get it. Writing physics engines are very difficult. One that's accurate and it has the right constraints and it does all the things that you want. You know, in theory, you could write a physics engine that kind of just simulates a rotating cube. But even that's not that hard. That's harder than you think. But obviously, you mean like collision detection, constraints, ragdoll physics, all that kind of stuff. And yeah, that is tough because that is hard. It's hard to do to get that precision right, where everything doesn't blow up on you. My goodness. Yeah, actually, let's investigate what that collision detection actually does. Writing everything is hard as fuck. Yeah, pretty much. Yes, the hardest part I had with my physics engine was numerical precision, getting everything to start spazzing out, and understanding the separating axis theorem, and then implementing separating velocity on collision detection. Oh, flipping heck, that was a pain in the neck. I mean, it was really cool when you got high restitution. So you could like mine was an impulse-based physics engine, and I had like a cube that with the separating axis theorem that would bounce off stings because it had super high restitution. So it was kind of like Portal 2 when you get everything covered in blue. The blue goo, if you've ever played that game. But outside, it was just so... It just took ages, and I struggled. I couldn't even get anything working when it came to like, I couldn't do indoors. It was really strange. I couldn't do anything that was like if you were inside geometry, I couldn't get that to work. Now I would understand how to do it, but back then I was completely lost. Yeah, writing everything is hard. Yeah, it's all hard. As I've said to people, you don't programming never gets easier. You just work on harder problems. Like, it just never gets easy. You know, maybe you found it, like, originally I found it really difficult to use arrays in Java. I couldn't understand it. And now, like, obviously that's easy peasy for me. But just because I understand how to use arrays now just means I'm on harder problems. Anyway. What am I doing? Oh yeah, that's what I want to do. In physics, what does it tell us about what's collided with? I don't wish using Java. Yeah, neither do I. Like, I have a funny story about figuring out how to get keyboard import in like early versions of Java, and printing out my user, like when you type in your name, it printed it out. I showed my dad, and he said the program was terrible after I worked on it for ages. Oh my goodness, trying to get the input from the scanner. Oh my goodness, what a pain in the neck that was. Yeah. That was a funny day. Right, so what is what when it comes to this? So we need to figure out what ends up happening when we collide with a rock. Excuse me. Yeah, maybe you shouldn't say anything for you, C++. Yeah, we're not the cool kids at all. We ain't using Zig or Rust or whatever. I've been using Java for a decade. That's how I learned to program. I made Minecraft mods. Ah, hell yeah, dude. Okay, so if I crash into a rock... Once it gets there... Okay, so we have persisted... Okay, so it looks like... Okay, if we get rid of persisted, and if you crash into a rock, we get validated. Is that the first thing that happens? Let's crash. Boom. Okay, so that's the if. Looks like that's the if, right? I don't know what the rest... Oh, I know why. These are unfortunate. When the rocks touch each other, they kind of bounce out. So how does that tell us anything about what's being collided? Oh, hang on. We have remove here. We should go to the next one by itself. But it's not. Okay, so... We get... Oh, okay. Validated. And then I move away. Removed. Okay. So that tells us we're not colliding anymore. Okay, that's good to know. No, Zig's nothing wrong with Zig. It's either way. Like C++, everyone beats on C++. No one beats on Zig. Zig's cool. I've been using, yeah. I don't miss the overhead. The real cool kids actually ship Instead of bike shedding alone like me. Yeah, pretty much. I mean, I'm doing the same here. We are bike shedders. Not good. Okay, so we need to figure out what the actual... Oh, okay, so we have the bodies here. Which is nice. I believe... What can I do with this to make it... So we basically need to pull out what our ideas. Collision shape result. What's this? Oh, excuse me. So we need to go. Okay, bro. We need the physics object, and we need to do something with it. I'm not sure which one's which either. So let's do a breakpoint and figure out what's what. Oh, did he? I thought it was a cool language. Yeah, C's nice. My C++ is closer to C. It's not C though. I can't call it C. It's not. It doesn't have all the crazy template stuff. Yeah, I love the simplicity too. Fortran was the last good programming language. Don't you mean Cobalt? Dude, come on. Fortran's too new. Alright, so what I want to do is... That just happens all the time. Okay, let's just check. Okay, let's let this game engine run for a second, and then we'll put a breakpoint in. Yeah, I think that's appropriate. No, I've embraced templates. It's never been a fun time. Right. Okay. So let's crash into this. All right. So what do we get with this? Yeah, we have gameplay. Look at that. Okay, so we have 1, and what's body 2 then? Oh, what am I talking about? Okay. I don't know which one's which. It's the ID. Index is 4148. Huh. Object layer 0. I think my object layer is... Yeah, okay, so that's going to be different based on... Okay, so body... We can get the body ID, but I'm trying to figure out exactly how we can make this work for us. Oh, there's... Oh. Didn't see that. So this is the player. This is 100% the player. For some reason the player is 4,444, which is interesting to say the least. Why is it that way around? Interesting. All right. Zig is essentially Noah. I left C++ because of the template. Oh, that sucks. Yes, go write URA without templates. I was tempted. Honestly, I was tempted. I was tempted to literally just write everything multiple times over just to avoid templates. That's the best way to program. Use C and add a few C++ features you like. Yeah, that's basically what I do. I mean, I'm beating on templates just because of my last job. Oh my goodness, the abuse of templates, you've never seen it before. Just imagine that you had a something called an item list, right? This has 2 vectors in a vector. One of the vectors is a unique pointer, contains unique pointers, and it has a custom deleter. And the other one has some kind of templated ID system, which is separate from the other templates that you use throughout the code base. And this custom deleter would call function callbacks to delete things and shift things around. So you could not, for the life of you, figure out what the hell was going on. So that was like... I've seen template abuse. My God. It was miserable. Right, so I'm just going to go to the loo again. So be right back. Let me just type out. I can talk Slander because I don't work there anymore. Right, so I'll be back in a minute. Back again. Okay, so they were the musics I want to listen to. So I'll put Lost Paintings on again, my favorite track, and we'll put it on shuffle so I don't have to faff around with the thing anymore. Okay, get rid of this. Minimize that. All right. Okay, so why are you index 4444? You should be index 0 really. Because that would be nice if everything corresponds with what my entity indexes are. We could store the index, actually. I don't know. Okay, so... it's like backwards. I see. This is a first in, first out container thing. Yeah, okay, so I shove everything into an array. So because of that, it's first in, first out, meaning that what index 1 is is 0 is the opposite when it comes to our body index. Okay. My first major C++ project didn't even use standard template. Nice. Or anything standard template for that matter. Escape point is that a C++ issue or a template? Oh, it was yeah, it wasn't C++, it was the architecture of that code base was miserable. Yes, you're referring to my work. Yes, it was I don't know. I do not understand why it was written that way. Okay, so when we do something with this physics object, so we have to use this kind of so we have effectively a slot here that gets run. Yeah, be aware, guys. If you go working in a C++ code base, it's possible, not always, that you're walking into the worst code you've ever seen in your life, and they're professional C++ programmers. It's mad. Like truly some people who are unemployed, who've never worked a job are better programmers. Right, so we have a body ID here. Can I set the ID? That'd be interesting. Okay, so there's the body ID from a setting shape. Oh no, we have the IDs. Interesting. Okay. I'm trying to figure out how to connect these things together. When we actually do a collision detection, we need to do something. But we can't just do it for any collision detection. We need to do it for a particular type of collision detection. And at the moment, we just have this, like, internal class that gets triggered every now and again for every type of collision, for every single body type. So, yeah, it's one of them. Yeah, that's kind of the issue with C++ for me. I'm glad I never learned C++. Well, no offense to anyone. Nah, that's no problem. I'm not offended at all. I completely understand. Yeah, you can write terrible code in any language. That's facts. Yes, this is the burden of a high degree of freedom language, 100%, which I appreciate with C++, to be honest. I'm glad I can do something stupid. But when I have to do with other people's stupidity, that's when I hate it. Anyway, let's dig into this a bit more. Alright, so accept all contacts from this body pair. Accepts this and further contacts. Accepts this contacts only and continues calling this callback for every contact manifold for the same body pair. Rejects this contact only but proceeds any other contact manifold for the same body pair. Okay. Rejects this and any further contact. Okay. So, what do I want to do here? Okay, so I've got to think of a condition. That makes sense. Sound like a village person from Minecraft. What I think I'm gonna try is I'm gonna try include some audio. I just see. Yeah. Okay. So let's do something really basic. Yeah, because we have our audio engine set up, so we'd be able to check. I don't know which body we're going to have to check here, so because there's two of them. Get ID, I guess. And what does that return? That returns a body ID, which is a what is this type? Get sequence number, get index and sequence number. What? Returns the index and sequence number. What's MID? Just a number. Alright. So yeah, I'm just gonna do some like really lazy use of this. This is not how you use this library, I don't think. Alright, so... Or... So... I'm going to do some hacky stuff at the moment. And now we want to do... How do we get anything in here? This is the next question. Because this is a virtual function, we can't add any more arguments. Let's just see if there's something else I should be doing. Maybe there's a way of checking if a particular body is colliding. Because if I can check out... Alright, what I'm going to do is close this. Open up Jolt for a minute. Because we must be able to do something beyond just it collides with internal stuff. Because I need to be able to check. Oh, if it's player, then we need to do something, right? That makes sense? So let's open up that project. Yeah, I've never used static analyzer or a linter for that matter. I think that I can't remember if they're the same. I've just said the same thing twice. Alright, so no, we want to go to vendor and then Joel physics. So I want to be able to do more than just what I've just done, basically. And the Jolt Physics library has an excellent sample section, so I want to be able to see, like, when we do some character stuff. I assume there's more going on than just so when a collision happens, is there a way to do something when that happens? That's the question. Rather than just have a function callback that just, you know, calls itself. Which is great. I mean, that's something. But I want to be able to use that for a particular situation. So initialize, we have a bunch of stuff. So this is building up the scene. Perlin noise. Excuse me. Yeah, that's what I'm trying to think. Yeah, I want to be able to have some user data. Let me just let me check that the last argument isn't just user data. No, okay. Yeah, because I've got to have something in here that I can do. So yes, that's the idea. I just was paranoid then. I was like about to go down Odyssey, and then there's like a void pointer that I can just do stuff with. So yeah, when in doubt, check the source code. That's and the documentation. Yeah. If you download Jolt, you can build its repository. Well, it has a bunch of sample code. So I'm just gonna that you can have you have to use CMake to get it to work. But generally it's quite good. Generally, it's actually really good. It's a well-behaved library where it kind of just works out the box when it comes to building its source code. You know, you'd be surprised, for those who aren't programmers, how often you get a library which is just someone else's code, and it just breaks immediately. Like you spend forever debugging. Let's see here. Okay, so there's linear. This is all just more of the same code. Yep, I'm just being very careful here. I just don't want to add miss something obvious where we add like user data or something, you know. But these are all just the, as far as I can tell, for the Jolt physics engine, these are all just the structs that you just build up to build up. If it's moving, it's non-moving. If it has restitution, what's its rotation, what's the mass, blah blah blah. All right. So yeah. I assume Visual Studios has some equivalent. Yeah, there's going to be something. Oh, thank you for that, Ratchet. I'm just going to make sure that that's what you're supposed to do. Because it's not this library in general, but this library is very, very good. It's just I've used it wrong in the past and it's caused some silliness. And everything got really slow. It was part of that speed up I did where it got like 16 frames per second to 5k frames per second. Because I was just using this library completely wrong. You write your own libraries. Nice. Hey, that's what we're here for, you know. Like we all do the same. I mean, you know, everyone here is kind of like writing their own game engine, doing their own renderer kind of stuff. So yeah, you know, you're in good company, to be honest. You know, I was very much inspired by people who did their own stuff back in the day. Right, so there's nothing interesting here at all, as far as I can tell. Nope, nope, nope. Let's see. Okay, so yeah, send me the link. But like I said, I'm just gonna be I gotta be a bit slower on this one because I just want to absolutely make sure. Okay, yeah. So this is just I'm gonna scroll a bit quicker. All right. Okay. So process inputs. It's fine. Okay, yep. That's, I assume, nothing to do with the physics engine, so pre-physics update. Okay, so we... Okay, camera. Okay, so we have a couple of things. We have rotation. What else do we have here? Yeah, so let's just move kinematic. Okay, so I don't need to get too close up with that. Okay, so animate the characters. Sure. Draw, yes. Initial camera. Draw a padded character. Okay, so there was nothing really there that told me that we do something. It's possible that pre-physics, what was the other thing? Menuing, initial camera, pivot, save state. Draw character, state, no, okay, what else we got? No, I don't think there's anything here. Hang on. What class are we even in? So this is the base. Hang on. Let's move to character. Okay, so that was kind of useful because that can tell me the setup of the scene. But this is the inherited class, and so I will open up what you sent, Ratchet. I assume it's here. Yes, Jolt. Thank you. Which is in body. I need like a is colliding kind of situation. To do something with that particular body in it on that particular session. Something like that. Anyway. Maybe it's through the body manager, but yeah, let's just keep reading this source code. I'm off to bed. But I left a sub. Thank you. Good luck with your engine and platformer. Thank you. Honestly, I appreciate that, dude. And thank you for all the reactions as well. Whoever's doing that, I can't tell. Access to user data can be used for anything by the application. Yes, I just want to make sure that's correct. I do believe that is going to be useful. But it's very easy to, with this particular library anyway, it's very easy to slow things down by accident. I'm just getting cooked by the sun here. I have to close the curtains. Yeah, thanks for anyone who's tuning in as well. Just to say thanks to you. It's a very long stream. I expected like people to be interested for the first hour, but it's very cool that people are still tuning in. So yes, very much appreciated, everyone. Goated community. All right, so remove from physics system. We have initialize. Yes, all that's fine. Pre-physics, which is already done. Draw character state. Post-physics update. Yeah, what is this? So this is in the character code. Okay. S character. So what I'm looking for, by the way, Ratchet, if you're interested, because I know you send stuff, is effectively a way to communicate with the... Where are we? This is really strange. Can you do this in C++? Just throw in a class in the middle of a function? Okay. But the goal of this is to say at body ID n, whatever that n is it colliding, and we need to be able to do something with that. That's what I'm trying to achieve, but I want to do it again in the way that makes sense. That's really strange. Literally, I mean, a nested class in a function. That's crazy. Okay, so find the hit that is aligned with the vector. What is this for? Okay. Oh, check collision. Okay. So we have a check collision twice. And we have a... I've literally never seen this before. That's so strange. I mean, it makes... I literally didn't know you could do that. What a mad thing. Well, you learn something new every day, as my dad always says. Get broad phase layer filter. Get default layer filter. So, oh, this is for the character. Hang on. Is this? Right, okay, so actually what we need to be doing is accessing the character code. And then using that, I think. So, we have a character or whatever. Okay, so this is good. Let's actually read these instructions. Well, the arguments at least, because I don't really know what they do. Get all context for the character at a particular location. In position... position to test. Get all context of the character at a particular location. Excuse me, I keep yawning. Rotation at a particular... Okay. Rotation at which to test the shape. Okay. A hit in which direction the character is moving will be calculated. Will be used to calculate a proper normal. Okay. Max separate distance. How much distance around the character you want to... Okay, so it looks like... I don't really know. There's so many arguments here. Needs to be called after every physics update. Oh, really? Max distance between the floor. I don't know if I call that then. Let's just check. Yeah, so this is wrong. Excuse me. Ugh. The reason is because I need to be using the character, not a generic body. I've gone too down in the physics engine. So we have one character and the rest are objects, and that's a very different thing. Jolt has callbacks to collision, right? I think so. I just want to make sure that when I do that, I want to do it on the character itself. Because actually, the physics engine is a bit overkill for what I need. But I'm going to end up using it anyway, so I'm going to have to, you know, for more complicated simulations and stuff. Okay. Yeah, so what do we need to look for is colliding, I guess. And with what is it colliding with? So let's see. Get grounded normal. Why do we need this? Grounded normal. Cancel the player's movement in the opposite direction when touching something we can't walk up. Do we need that at all? Give me a second. I'm just going to get rid of this and just see what the difference is. We could end up moving it at the speed of light, so be prepared for the fastest moving duck you've ever seen. Let's get rid of that. Oh, okay. Needs to be back 3. What would this be then? Where is this stored? Player movements. Oh, okay. So I'm not going to modify the player movement then. I thought that was just a... Yeah, it makes sense. I mean, how would you know which way, what the velocity is with just a number? Yeah, so there's probably a function callback for the velocity and stuff. Let's unplug the... Not overcharge the laptop. Okay, so what am I interested in here? Yeah, so I want to collide with something and just see what ends up happening based on that. Yeah, I had a feeling that I didn't need to do that because we're never ever in that situation. We're in a grounded state. We are never grounded. Yeah, okay, so that's something we can get rid of. And I'm not entirely sure this is a good number, by the way. That's just kind of like... It feels way, way, way too fast. And I think it might just be because my frame rate is so extreme. But we'll see. Okay, so the next thing I want to figure out is... Based on the character, can we figure out what we've collided into? So clearly we have... Oh, excuse me. Oh. Alright, so get position. Transform shape. So this is the best as far as I can tell, but check collision. Huh. Rotation, movement position, float, max separation distance, shape, in base, offset, collider collector, shape. What the heck's this? No, I want to see. What I want to see is like what the collector means then. So. Is this the... Right, okay, so... Yeah, because we need to be able to do something different. Let me stretch. Flip it back. This was a mad stream. I'm not giving up or anything. I just realised. It's a bit. I literally don't know how streamers do it. My voice is getting a little hoarse. I guess I was reading out loud for a while. I'll have to get some like lemon tea or something. I'll be fine, by the way. Just what's this? Is shape collider only for character? No, it's like for every type of shape. Yeah. Okay. So collider collector. What is this? Alright, so the character... So we need to figure out how the character knows what it's colliding with. Alright. I just need the body ID or something, you know? Like, collided with what? Obviously not the ground, because that would be... But for us, it really doesn't matter. We can get all... Let's see. Let's type in character and see what we get. So, is there a character? Let's see, character. Yeah, this is the same deal. There's check collision, but it's like check collision with a particular object. You know, I don't know. It feels like the collision, check collision is like hang on. It's maybe here's what I'm thinking then. Could we just pass in itself for its character? Like rotation, position, movement in direction. That's gotta be something like. Yeah, let me just check something real quick. Okay, that's sorted. Let me okay. Yeah. Hopefully you guys can still hear me. Yes, okay. Just need to fix something real quick with my wires. Apologies for the lack of professionalness. Okay. Alright, so we need to keep figuring this out no matter what. Okay, so we have collision detection. Is there a way to figure this out? Narrow phase, which is what we're interested in. A narrow phase query will first query the broad phase. Yes. Okay. Let me just Google this. Maybe this is fine. Like how to check jolts. Jolt physics engine. How does the character know what it's colliding with? What is this deep wiki? I keep seeing this. Yeah, we haven't looked at this class. It's a good point actually. So okay, so initialize, maybe this is what we need. So this is inheriting a contact listener. But I think we also have a, as far as I can tell, if I get off this, go to our character. Yeah, what is this? Okay, so what is this class? Inherits diagram, non-copyable, character base. Right, okay, so that's virtual. Is there a thing in here that I care about? Let's have a quick look down the functions. Oh, has collided with. Okay, that's really good. Has collided with. Let's have a look. Has collided with body ID. Okay, this is what I needed. Check if the character is currently in collision with another body in the last operation. Has collided with virtual character, character ID. Okay, so this is nice, but it's like I don't have to check every single collision object against the character. That would... Okay, let's just see if we even have access to this with our character. If we go to main... character, yes. Has collided with. Looks like gets virtual, maybe? No. Character base. Okay. Maybe we need, instead of character, we need maybe virtual character. Let's have a look at the inheritance tree again. Hello, Kalia. Wow, 7 hours. Thanks you. Yeah. Now we're still going to keep going. Okay, so looks like character and virtual character are different, but they're the same hierarchy. Let's have a look. Alright, so, okay, so let's try virtual character versus non-virtual character. In 2 weeks, Vulkan journey starts. Hell yeah, bro. You have to update us how you do. I know Mabdo has done. He's called Forsaken in the Discord. Yeah, come into the live stream and let us know, or in the Discord or whatever you fancy. It's always motivating. So, if we take our character and make it a virtual character, what's the difference? Probably need a virtual character include, right? Oops. Let's have a look. It might be the same include. No. Okay, so virtual Right, okay, so let's just see what that doesn't do. Okay, so yes, we can't add it to the physics engine. Add to physics system. Okay. What else are you missing? Okay, so we just... What is the virtual character though? Okay, so we have contact list. So we have a virtual character. What is the virtual character? I don't even know. Okay, so it's going to be the same setup, I imagine, as everything else. Okay, so we have... Right, so how do you add it to the physics system? So we add... Where's the... Anything to do with adding it to the physics system? So extended update, we have update. I don't see it. No, okay. Why is there two of these? I'm so confused. So we have like basically two classes here. One's called character, one's called virtual character. I don't know what the difference is between the two, but this has what I need for checking a collision at the very least with itself. So let's just have a look. So runtime character object. This object usually represents the player. Okay, good. Contrary to the character class, it doesn't use a rigid body, but moves doing collision detects only. Moves doing collision detects only. Moves doing collision detects only. Hence the name virtual. The advantage of this is that you can determine when the character moves in a frame. Usually this has to do at a very particular point in the frame. But the downside is that objects don't see this virtual character. To make the virtual character visible in simulation, you can optionally create an inner rigid body, though character... Okay, minimum rigid body. A virtual character is not tracked by the physics system. Oh. So you need to update it yourself. This means that you call system save state will not save its state. You can call... Huh. The problem is if that's going to happen every frame, is that slow? Okay, what does this do? Save state for replay. I don't think this is right. Okay, so let's actually investigate what these do based on this. Runtime character object. This object usually represents a player or humanoid or AI. It uses a single rigid body, usually a capsule shape, to simulate movement and collision for the character. The character is a keyframe object. The application it by setting the velocity. All right, so what I'm gonna do then is, let's see how long we've been going here. Okay, so what I'm gonna do is figure out. Yeah, okay, let's put this back to. It looks like virtual character is something slightly different, some kind of like not real character. All right. So we do have the collision detection system, which takes our rigid body and feeds it into the listener. Now we could add our user data to this object and have some function callback that kind of escapes that function. If that's what I want to do. Okay, so what do I want to do? What do I need to do? I feel like, honestly, there's something I'm missing. Like just some information that I just need to know. Yeah, so this is not going to be useful. This is not part of the physics simulation. That's why it's virtual. Which is not good. What do I need to do then? I need to figure out. Sorry, I'm being a bit scatterbrained at the moment, but I'm trying to figure out. Let me show you what I mean, right? So if you run this, again, just for people, this is not my engine. It's going to be booting up. This is a physics engine, but it has a bunch of samples, so we'll be able to see what's going on. Right, just give it I don't know why it's recompiling, but here we are. Oh, I think because I updated Visual Studios. Different Windows SDK and all that kind of stuff. Okay, so this let's bring up the menu. Oh no, it's not it. Okay, I don't know why that crashed, but what's the? Okay, so that's the. Okay, escape is the menu. What did I press? I feel like I pressed the wrong key. Oh no, okay, that is interesting. What? Why is that happening? It's possible that this did work in the past. Let me regenerate the project. So let me close this. Delete that. Okay, so CMake VS 26 cl.bet. So I think, yeah, we need to regenerate the project. Something has gone wrong with it. Very cool. I'm so glad that worked. That's so clean. I love the fact that that's that easy to do. All right, so let's build. I don't think it matters if it's debug. So what we're going to do is try and compile the Jolt physics engine, try to get the physics simulator working. Okay, so let's have a look. And escape. We need to select test, character. Right, interesting. So, and we press P. I don't actually know how to rotate this camera. Let me think. What do I want to do here? So this is running the sampler code, right? So let's start debugging it. So character. There we go. Character test, right? Okay, so we have indirection. No, what do we look for here? Hang on, this might be it. On persistent contact. This might be what we're looking for. Character test. Okay, I think this is it. All right, so where's character test? Where's character test? This might be, hang on. Okay, so it looks like we can actually extract out what we want here. So, character test, base test. What are all these tests? Test. Okay, so let's go back. Boop, 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 boop. And let's Google. Let's search the documentation. Character test, maybe? No, okay. So that's something that's written itself. And that's a good sign because that maybe tells us, if I go to character then. Are we in character? Yes. Okay, so okay, so what are we doing here? We're doing a okay, so on contact persist, on contact added, on contacted. Where did these come from? Does it come from the base? Because then if I do contact, I don't want persist, I want the other one. I want, oops. I want, what is it called? So on contact persist is almost what we need. Go to our contact listener. Where's our physics code? Yeah, on contact valid date. So maybe we can access this function based on the pattern I've seen here. So if I go back, on contact persisted, right? And this is a overridden function. Yeah, okay, so it's virtual. So we're going to try and hopefully get some inheritance going here. But in our character code, okay, so So let's have a look. Character base. What's in here? On character. On ground. Is there anything else? Non-copiable. Okay, so this, it's got to be somewhere. It's got to be like somewhere in like some kind of inherited type deal. Okay, so what's this character test? I'm confused now. Yeah, where's this come from? Contact listener. No. So what I'm trying to do here, by the way, is just to figure out exactly how to get a contact valid on the player to tell me, like, on the player object itself, rather than just generally happening across all collision detections. Because we need to see, oh, we're only interested in the player, rather than trying to filter out what the player ID is, which will be expensive. If you know what I'm saying. Okay, so contact added. Okay, let's just try and do it. I'm gonna throw this in, just see if there is a virtual function, right? It's gonna be like super obvious, but I don't think it's gonna work. So I'm just gonna throw this right here. Okay, so comment this out. So this is a virtual override. Okay, that's what I wanted to see. So that's unfortunate. There is no base class. I thought that was the case, but there is something here it's just doing something that I want to do. What is character test? I really don't understand this. Why is there a character test and character? Okay, so there's a character here. .h. And test. Is this in the documentation? No. Oh, the music stopped. Yes. Okay, 1 second. Sort out my wires again. Yeah, sorry about the music being stopped. I didn't notice. So what I'm looking for here is the character itself, because clearly there's something. Character versus simple. What on earth is this? Oh my goodness. Okay, so character versus character simple collision. A list of active characters on scene. Okay. Okay, so there's a character here. Nothing that interesting. Okay. base class for character tests. Initializes the test scene. So if I go into the initialization then, what is it doing? So this is just the code we saw earlier. All right. Okay. Okay, so documentation. Let's go back. Is there a way to find this out? Just make sure the stream's still going. Yep. Okay. Realize without music I'd be more productive. Yeah, I love music, so I can't live without it. I think the limit for me is when I hear talking in music. I can't really... I mean, some talking, it's fine, but... it's very rare that I get silence when I'm coding. So, initialize... So what I don't understand is, where is this collision detection stuff coming from? Okay, so if it's written... Okay, so this is for the test code, right? And if it's overridden, we can write the same code and get it to trigger, right? Okay, so this is something that we can deal with. So character test, we need to look for this everywhere we can find it. So contact listener. Okay, so right there. So if we... Okay, so... It looks like to me, if I want to make a character that has a contact listener on it, I have to use multiple inheritance, where I have to have a character listener plus the character. And only then can I end up... It's kind of lame. So let's try that out. Okay, so contact listener, and then we can do something with the valid. Okay. Okay, that's lame, but multiple inheritance is part of this library, so I wouldn't be that surprised. Oh. Yeah, let's get rid of that. So what I want to do then is... Do I want to do inheritance here? Alright, so we have a player class. Yeah, let's it has maybe this can just has a contact listener instead of is a contact listener. Let's have a look. So this is just like an example of how to deal with contact listeners. How do I... Okay, this is like C++ OPP stuff. You coded music too, I love it. New GPUs are coming by NVIDIA. Nice. Time to upgrade. If only I waited like a month and bought the 5070 graphics card instead of the 4070 graphics card. Yeah, I literally bought it a week like a month before they released the new range. I should have really looked up when they were releasing them. Okay, so really trying to figure out how to do this without making everything like 10 times multiple inheritance. You always ignore a contact before it's created using layers. Not to make that. Okay. What I want to do then is, so in the player class it needs to have a contact listener, I think. And all that happens though with these guys is they get ran. Okay, so what I'm going to do is cut this code out. So this is a pointer, obviously, that we can do something with if I wanted to do that pair. Alright, so we don't need just like a random collision detection. The player needs to be listening for contacts. So I'm going to move this in here for a minute. I know it's not going to work because we need... I know it is, okay. And what I'm trying to do here is make it so the character is the only thing we care about. How do I do that? All this, yeah. Oh, it'll be all the Super Series. Got you. Can't wait to pay. Yep. Yeah, it's gonna be tough. Yeah, I don't even have a 4070 Super. OPP. Object Programming Paradigm? I don't know. Yes, I'm OPP. This is object-oriented programming, but this is the Jolt physics engine. It's very object-oriented. It's like so object-oriented you can't really get around it. So this is function that gets ran every time there's a collision detection, but I want to limit it for just one type of collision detection, so like one type of body. And I don't exactly know how to make it just work for one character. The only way I see this working for something I care about is like making another level of inheritance for our character right here. And then like, even then I feel like it's going to be triggered every single time anyway. So I'm trying to think. Yes, I could select the body that we care about based on an if statement or something. And just say if it's index 44444. But that's not that useful really. So it's a bit of a tricky one. Hi Julius. Did you start with C++, or is it something that you learned on the way and stuck with it and stuck to it? Did I start with C++? I started with Java because I wanted to be a hacker. This is many years ago now. Turns out that not many hackers care about Java, so I kind of moved to an application where you can actually run the executable, because I didn't know how to do that at the time. You needed the Java runtime environment. I don't know how it is nowadays installed. So I moved to a compiled language where it actually makes an executable binary rather than some bytecode. Long story short, if you don't know what I'm talking about, I just wanted an application that you could click on without installing anything extra, which you need for Java. And so that's why I went with C++. I literally, it was by accident that I picked C++. I didn't really know anything about anything. I never got formally trained in C++. And then, yeah, I just kind of stuck with it. So yeah, I just the second one, I guess. I just learned it and just kind of stuck with it. Okay, so Is there some kind of weird C++ thing where I can make an inheritance only for a character or something, and then just be like, that's the only thing I care about? Because I feel like what's going to happen if I make my character a contact listener, it's just going to do the same thing anyway. And like for literally everything. So I think I can test that at the very least. Right, let's just compile this for a minute. Alright, so doesn't know what a contact listener is. Okay. Why is this here? A contact listener gets notified when bodies are about to collide. Oh, okay. And when they separate again. Note that this is called from a job. So whatever you do here is thread safe. Registering one is entirely optional. Okay. A body activation. Okay, so that just tells me if something's gone live or dead. Okay, so contact listener. What do we end up doing here with this object? Why do we need to instantiate it? It almost feels like it's completely superfluous. I started... Ooh, there's more. Okay. Let me just see these errors. Okay, so we need one. Okay, I'm glad I'm breaking things because it's actually making things make sense a bit. Right, okay, so we need a job system that will execute physics jobs on multiple threads. Typically, you want to implement a job interface yourself and let job physics run on top of your own scheduler. Job system threads is an example of an implementation. Okay, so I started with C++ due to variety and reliability. Honestly, pretty interesting how you got into programming with Java. It's one of the languages I don't really get the grasp of sometimes. Yeah, I've completely dropped it nowadays. Did you set up the JPH list? Yes, I did. I believe I did, Mika. The layers are... So what I'm trying to do, if you know Jolt, is... Right, so I'm going to move this back. Is have only the character worry about collision detections. I don't want to have to simulate like everything when it comes to... like, I don't want to have to filter out a bunch of arbitrary collision detections. Oh, maybe that's the only way, though. Because this is just a function that just kind of runs. I want to be able to go, okay, the character has collided, but with something. I heard people who come from Java very often. Interesting, yeah. It was popular at the time. Thanks for subbing, dude. I heard Java was created by taking the worst parts, not from C++. Sorry, I heard Java was created by taking the worst parts, not C++, and making them into a language. Yeah, Java was nuts. Well, the one I worked with anyway. Their actual early adverts, like advertising Java to C++ programmers, being like, "Oh, so you won't have to ever program C++ again. You can use Java." It's a bit nuts, thinking back. I like the joke that Java has. All right, so yeah, it's what is it? The official slogan is write once, run everywhere or something like that. But it's like the joke version is write once, debug everywhere. All right. Because that's in theory what ended up happening. I don't know. I'm not a Java programmer. I'm not a professional Java programmer. All right, let's just try and figure this out. Just like do the simplest way. Do the simplest way. All right. So I'm gonna say I'm kind of interested in this, right? I'm gonna try something in body 1. Get ID. And then get sequence number. No. Get, what is it called? Get sequence, this one. Is equal to, I know this is really crappy, but I'm kind of interested to see if I get what collision detections do I get this in? So 2. Oops, not 12. Do I get it here or here? Or both? I don't know. Yeah, new Java isn't so bad, I guess. Yeah, it's one of those things, right? I haven't used it in ages. I didn't mind Java. The fact that I couldn't click on something. Oh, hang on. I'm not an expert in Java, but I think what you want to do is layers. So if I set up a separate layer for like the player or something. Okay. That didn't even work. No, it's good because I'm kind of learning on the fly. Yeah, Kotlin's what I would use if I was doing Android. I remember I was a grasshopper learning one language and then jumping to another. Yeah, I don't recommend that at all. But yeah, it's you know, if you're gonna learn Java, like I said, the only reason I wanted to learn Java is because I couldn't click on an application. Like, if I took I made an application, for example, and it was a Java application, and I wanted to run it on my friend's computer. I got the USB, and I brought over my Java application, and it didn't work. And he could do that, and he was an artist. He didn't even want to learn to program. And I was super jealous. I was like, oh my goodness. Why can't I do that? I want to be a programmer. And I'm learning this language that I can't do that in. So then I immediately dropped Java. And I also wanted to be... It turns out that, yeah, like I said, hackers don't use Java. Really. Even back then. Yes, I don't want to be a hacker anymore. That was many, many, many years ago. That was like when I was 16. Just a wee lad at 16. Oh, back when the TVs were black and white. Okay, interesting that this never happened. Okay, so let's see how to do layers. Let's look at layers then. Maybe there's a layer. Like, we can turn off everything. Yeah, if we put... Hang on. Yeah, so maybe we can make more layers. Maybe there's like a secondary, like a character layer maybe? There should be an enum. I copied a lot of this from the sample code, by the way. That's why it's a bit random. About 2 to 3 years ago, yeah, being a hacker was popular. The new C++ documentary, yeah, pretty much, yeah. The new C++ documentary about The history of Java in C++. Yes, I'll write it myself. Is there actual a real C++ documentary, or are you just referring to me talking about the past? Object layer filter implementation. Oh, I see. Right. Okay. So non-moving. Yeah, non-moving only collides with moving. Moving collides with everything. Ah, okay. So non-moving. Right. Okay. So okay. So if I do case. Right. So I'm gonna say false. Right. For now, I'm gonna be super lazy with this. We're gonna make a new layer. And it's gonna be just character or something. Alright, character. Okay. Let's try that again. Character. Yep. This is going to be 2. This is going to be 3. That's a 4. Okay, so layer. Oops. Return true. And so if I go into my character setup, which is in the player, layer. Okay, so you're a character. So I can set up a different layer for you. And I think there's some more I need to do. I haven't quite finished. Let's go back to physics. Yeah, okay, so this I don't exactly know. Okay, so each broad phase layer results in a separate bounding volume hierarchy tree. It's just narrow. Okay. In the broad phase, you can at least have a layer for non-moving and moving objects to avoid having to update a tree full of static objects every single frame. Okay. You can have a one-to-one mapping with the object layers and the broad phase layers. Case like this, if you have many object layers, you'll be creating many broad phase trees, which is not efficient. If you want a fine-tuned broad, okay. So we'll try to avoid this for now. Okay, so we'll see what happens with what we've done. I'm gonna try to not do the broad phase and just see if the narrow phase picks up what we wanted. And then maybe we can just like figure out exactly what's getting collided with what based on our layers. We shall see. We shall see. We shall see. Is it gonna crash and die? Yeah, I thought so. Okay, so yeah, he didn't like what we did, so we're gonna have to make another one, which is kind of character. Oh, I can't spell today at all. It's going capital letters that I can't. So I keep, yeah, okay, so that's the mistake. And then C. Okay, cool. Okay, that actually spells character. And this is 2, this is 3. I don't know how many I should have here, so... Right, so... do... Number of phases... Sure. Okay. Okay, so do... Okay, so this is going to determine if they're in the broad phase. So... False. I should comment that out because I actually need that in the... because this is just a demo code at the moment. So I'm just going to go return false, like that. False. Case layer. Character. Okay. Return true. Okay. Yes. Layers. Hey, you're back. Nice. Yeah, it's a pretty yeah, it features Bjorn. So it's pretty cool. It came out yesterday, I think. Oh, nice. You know what? I'll look it up. C++ documentary. Let's have a look. Documentary. Yep, there it is. Cool. Interesting. I will, yeah, I'll look into that. I don't know if I'll watch it, but I'll definitely see what it's about. Okay, so is there anything else I need to do for our collision listener? Okay, we'll just find out if it just doesn't work. Okay, so yeah, we didn't get any persistent stuff. And oh, I need that. That's just going to tell us if something's collided, right? Again, I've turned off the lighting, so this won't look like this in the game. Okay, cool. And let's just rerun this again, because it is possible that some of the rocks didn't collide with each other. And what I want to find is this. Yes, I'm going to crash into this. I have a feeling we're going to go through it. Although we are a player, so maybe... Okay, no. That's actually cool. Okay, so we turned off collision detection for everything other than the player. Okay. Right, the next step then is to do something about it. So we absolutely know for sure now, based on our layers, that our character is colliding with something. Now, I don't exactly know how many layers is good or bad, but I'll look into that. So at the very least, we can do something now. And the problem is this is just a random... This is just a function that runs. It's printing to the screen, which is nice. We have, like, the ability to call other functions, obviously. But if we have an object that does something... how do we get the object in here? Because I don't think we can... Okay, so a listener class receives collision contact events. It can be registered through the set contact listener. Only a single contact listener can be registered. A common pattern is to create a contact listener that casts get user data to a game object and then forwards that call to a handler specifies specific for a game object. Ah, okay, right. Don't tell Ratchet, but if he's not here, I don't know. Yeah, we should have just done what he said initially. That if we set up if we set up something inside the character's rigid body user data, because that's just a void pointer, then we can do whatever we want with a specific collision detection. Ah, dear. No! He's seen me. Don't beat me up, Ratchet, I swear. But yeah, we should have just done what you said earlier. Based on a rigid body, we can use that user data to do something with. So, let's do the simplest thing first, and Unity and Unreal have about 10 layers. I would assume 10 is safe. Thank you, Mika. That's really valuable information. So yeah, absolutely no more than 10. I cannot have more layers than that. Okay, so for those who don't know what I'm talking about, Ratchet is someone who's in chat, and he suggested earlier that we just need to set the rigid body up with user data, and then we can actually do something with that. So what do we want to do? Let's look at, I'm pretty bad at function pointers, so just bear with me for a moment while I look at the, because I just don't do it very much. Okay, so we just actually, I remember the syntax. It's just, how do I cast it back out? Or maybe I can, instead of a function pointer, maybe I can just make it an object and have that function do something once we cast it back out again. So let's try that. That's actually simpler. Instead of doing function pointers, let's could I set up, no, in the initialization code, when we're setting this up, what is it? It's character setting data. Can we set up the user data here? No. How do we access the actual body? So we get back a character. Get body, maybe? This body ID. And we can, I think we need the physics object to return the body, because it's not thread safe to access the body's raw, as far as I remember anyway. So let's get the physics system up. Again, I'm kind of learning this on the fly, so we'll grind this out. So the physics simulation. Actually, this is going to be easier if I look at scene. Scene does stuff with this. So yeah, we need the physics object, body interface, body ID. So is there a set user data maybe in the body interface? Because I don't want to get body. Like I said, you don't want to handle the body directly ever. User data. So yes, okay. So set user data, and then we just hand in a pointer. Fantastic. Yeah, he got me, dude. User data in my Jolt UN64. Yeah. What is Jolt? What is Jolt physics? It's just a physics. It's a very object-oriented, useful. It's not bad or anything when I say object-oriented, but it's a very object-oriented physics engine that everyone seems to be using. It's very good. It's open source. It's the. Believe right now it's the best option we have, and I think I'm very grateful that we have it. So yeah, that's what it is. So when I initialize player, we need physics. Physics. I think that's what I've done in scene. I'm just going to copy scene basically. Yep. Okay, physics. And player. And we need to include physics. I know it's fine for some reason. Right, so this is in physics, believe it or not, / physics.hpp. Now, okay, yep, that's correct. I had a feeling that would not work for some reason. Right, okay, so in the initialization code, then we want to get the body. Body interface. Interface. Let's go. Okay. What am I doing? Get set user data. All right. So I'm going to make a bit of a wild guess here and try to dereference to this pointer. I want to pass in itself. Is that possible? I mean, there's the uint. This is terrible, by the way. Don't do what I'm doing. So that this pointer is just a pointer. Now, is that even a good idea before I've even set everything up? Because I want to be able to run this code within. Let me just read that again for. And that's undefined behavior, I think. That would work, but I don't think it's very good. Where did I find that code? I want to see that thing I was reading earlier. But just bear with me. Yes, go back. It's not. Hopefully it's... Okay, we're coming up on it. Ah, poop. What were we looking at? Do a reinterpret cast. Yes, yeah, I was doing one there. It's I was using the C one. So we need to think about this. We need to be careful. We don't need to be careful. We just need to think. So the contact listener. No. Yes, contact listener. That was it. Okay. If I just use my brain for 5 seconds, then we don't have to click 1,000 times. Who would have thought? Okay, so let's try this again. Okay, so the contact listener that casts get user data to game data and then forwards the call to a handler specified for that game object. Okay, so we're not going to do that. We're just going to assume, for now anyway, that we have one game object that's going to only do this based on a layer thing, right? Typically, this is done on both objects involving in the collision detection events. Oh, that's true. But for now, we'll just... So what we're going to do is reset the position. That's all I want to do, right? I want to reset the player position. Note that the contact listener callbacks are from multiple threads at the same time. When bodies are locked, this means that you cannot use the get body interface and get multiple threads. That means you cannot lock. Okay. That means you cannot use the physics / get body interface, get lock interface. Okay, so you must use the body interface no lock, I think. Okay. Instead, if you're using lock interface, the simulation will deadlock. Okay, so that's fine. Okay, so I just basically got to be careful here that I don't go into a routine that takes 1,000 years. And if I try to use the locking interface within this... Yeah, so what it's telling me here is because this function is ran by multiple threads, if I then use body lock interface in that function, it's going to wait for itself to finish. Or it's going to wait for a thread or itself or whatever to finish. But because we've set this up that the thread is waiting for that function to return, it will never return because we're waiting for the function return, right? So a thread is running that function. It's waiting for it to return to unlock everything. But we've currently locked it with this current lock interface and we got a deadlock. So that makes sense. So okay, so let's just give this a shot, eh? I don't know which body is going to be returning the data there. Because if I reinterpret cast body 1 and it's in body 2, I think it's going to be pretty safe to say that get user data is going to either return something or maybe null. So if you have something in, or so that's the first thing I need to check, right? And if so, we're just going to run this function in here. We're not going to do anything fancy. So we're also going to need oops, I like to put my includes this way around. Include game / player HPP. So if that's the case, we have a pointer. So we'll see if this even works, right? This might be just absolutely poo itself. Actually need this out of here. The reason is because I need to assign it to something. So this is just a uint. Oh my god, this is so miserable. Okay, so uint 64. It's just a pointer. That's all I had to remember. So a null pointer should be 0, as far as I can tell. 0.01. So if I go in here and say it's equal to 0, not equal to 0, we have something. And then hopefully we can reinterpret cast this out. This feels very abusive of the language. This is just a pointer. I don't know why it's not used pointers, like a void star. Okay. So when we collide, what I'm going to do actually is just kind of do this. Get rid of these. For now, anyway, right? That means we've got something that's come through. Body 1 has data. Right, 2. Right, let's see. Let's see how this runs, if it even works. Boss mode, indeed. We'll get there. Oh, yeah, that makes sense. We've got to, what? Oh, we've got a circular conclude. I think we have. Or I've just been dumb, right? So when we set up player, wherever that is, we need to send in physics, which should be somewhere. Where's physics gone? Oh, physics instance, fantastic. In fact, I don't need to. All right, let's build. Yeah, okay, so this is a circular include issue. As far as I can tell, anyway. But we don't need this really, because it's a singleton, which helps us out a lot because we can actually. Ah, okay, so we have it here already. Yeah, okay, so this is actually going to help us out a ton. Because now we can go, alright. Yeah, I already thought ahead. Instance. Cool. Alright. Now I need to get back to main and get rid of this. And we shouldn't have now circular includes because it's inside the translation unit, aka the CPP file. Yeah, looks good. Alright. What do I want to do here? We want to go into int ID holds user data with an entity component system. Fantastic. Yes, let's hope yeah, that music's sick. I love it as well. Thank you Mika as well for helping us with this Jolt physics engine situation. Alright, so let's just see if we actually have anything to dereference. So I don't want to try and dereference a null pointer unless we have data to dereference. So let's see. Okay, so hopefully this doesn't go bleh. Okay, so body 1 has data, but body 2 does not, which is good because I didn't set it up to have. Body 1 has data, and body 1 has data. Okay, so clearly we have data, right? So if I then take body 1 pointer, bring separate cast to a player, this is nuts. Pointer 1, pointer. And then I do reset position. Now, obviously, yeah, the ducks are back indeed. Obviously, this is not how you do things, but you would call it out and do some other thing. But I'm kind of curious how well this works. Actually, I have no guarantee that's going to be the same setup every single time, so I need to put it in both. Yeah, because this time it could be body 2 for all I know. So we'll see. We'll see. I don't know how to tell which one's which either. We'll see. There's probably some kind of jolt physics thing here, but anyway, I just want to see if it's going to work. Alright, so we should reset the position, but this could just absolutely crash and cause all sorts of issues. No. We are stuck, and yes. Okay, so let's get rid of this. And let's do that again. And just see if it was trying to interpret like a null pointer or something. Why remove the prints? Because I don't really need to see them. What I'm trying to do is interpret a pointer. Yeah, so what? Oh, okay, I think we ended up with a deadlock or something. Yeah, okay, so what I'm going to do then is just play some music or something. I don't know. Let's try something benign. Which would be, I don't know, play a sound effect. Audio. Crash noise, I guess. Yeah, I don't really know. So, well, we want to see at least something happening, right? So I'm just going to pass in the audio as a const ref. So we'll need a... I don't think it masses, but... Alright, so const audio, audio, audio. And what did I call this? I called it... Oh, it's in its own thing, isn't it? Oh, no, it's not. Audio system. Right, did I make this a singleton just to make... No, okay. Might be worth doing that. Okay. Paste this in here. Audio... Play sound effects, and it's been such a long time I completely forgot how to do this. So what do the sound effects I even have? I don't have many. Oops. Audio. Alright, so we have this, which is good enough. Nope, that's the physics engine. So this should be completely separate to the physics engine, so there's no like deadlocks or anything like that. That potentially might happen. It's his player. And I'm gonna go in here. So SFX. Oh, I don't have it. Boo. Alright, let's add this in quick. It doesn't really matter. This is a... Does it modify the system? Okay. Fair enough. Alright, let's make it non-const then. I don't really care that much, to be honest. Constness doesn't exist. It's only a compilation compile time thing. And then it gets stripped out. The fact that you can do a const cast means const isn't real. And is that playing now? Is that going to play? Audio system, yes. And yes, we're going to go to another dimension. Yes, it should play a laser sound effect when we crash, but we'll see. The problem is it's got to have an argument. Very annoying. Okay, so I'm going to change this a bit. This is... Let me think how to do this. Because now I'm going to have two things in this object. In this user data, sorry. Oh, this is lame. I'm just going to have to do a simpler function. I didn't want to do this, but... We're just going to print to the console. Boo. Because we're going to have more than one object passed to the... crash noise. Right. Because I literally just want to see if if I'm even on the right track at all. And it looks like updating on the contact, updating the position is not a good idea. Where is this? Right, crash noise. Type safety is a suggestion anyway. Yeah, pretty much. This is why I like C++ and C and stuff like that. You can just like abuse the language. Like I can reinterpret caster this pointer to an int and then reinterpret back again. So okay, so at least works, right? It made a noise in theory. Crash noise. Alright, so we're on the right track. Now we need to figure out how to fill it more up with data. In a way that's like makes sense. So obviously this is not how you do it. No. There is no noise. I unfortunately, because it had to have an argument for something, it wasn't going to play ball with what we wanted to do. But it printed the console, which is what I wanted it to do. At the very least, crash E noise. Okay, so that is good. What we need to figure out next is to pull this out into, like Mika said earlier, hold user data to with an entity component system into an ID. So we need to be able to pull out this and kind of run based on some ID in the contact listener, some kind of stuff, which Yeah, that sounds super complicated. Because my entity component system is poopy. Anyway, so, right, what do we want to do then? Plan of attack. So, for those who don't know what I'm talking about, I don't want to have a raw... I don't want to have to run... I don't have to do this, for example. Let me explain it a bit better. So, where is it? Okay, so we got the user data out. We reinterpret casted the pointer out or whatever. And then we did a crash noise. Now, the problem with that is this function is going to get massive. And it's going to be difficult to figure out what pointer does what. What we need to do is pull out some kind of ID that then can be looked up at runtime. At collision time? I don't know. That then runs the code based on XYZ, right? So if we have like object X that has an ID of 7, and then that, okay, so that goes, oh yeah, okay, I'm ID 7, object X will then do this or that. So we need a way to communicate back out of here, outside of this function call, which is fine. Because we got user data, we can literally pass in anything, which includes all sorts of things. So what I might end up passing in here instead of this pointer is some kind of meta structure that contains all the entities, right? And then we can... I love this song so much. We can then like access the entities and do whatever we want with them. The player is not a strict entity at the moment, but I think we can probably make it that way if we wanted to make it super generic, to make it like homogeneous. Homogeneity, sorry. Is what we're after. So it's... is it heterogeneous? Whatever, anyway, so... even if it isn't, we need a way to interact with entities and do something with them. Right now we've only been deleting them, which is fine for our buffer data or whatever. But now we need to be able to use that struct to access the actual underlying data and do something with them. There is no concept right now, so I'm talking so much, but there's a lot of thinking. There's no concept right now of like a rock. A rock is... yes, okay, so the only thing that really exists in the game is the player, really. So we have these rocks, right? They kind of just exist as a object, as a collision geometry, a debug geometry, the actual model itself, and all the physics that goes along with that. Now, there is no way to refer to this particular guy and do something with it, because it's literally just basically a physics object. And yeah, if we crash into this, the only thing that's actually reacting to anything in the scene is the player, making this print noise here, which is a stand-in for do something. So that being said, I think we should leave the rocks alone and just get this to work with our player. Oh yes. Yeah, so that's what I'm thinking anyway. So we need to have like this generic system pull out with user data, and kind of do it the way it was described in the contact listener, which is a listener class that receives collision contact events. It will Okay, blah, 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 blah. Only a single... Yeah, okay. A common pattern is to create a contact listener that casts user data to a game object and then forwards... Here we go. Then forwards the call to a handler specific for that game object. That's the next step, right? We've done this bit. Now we need to forward this thing out to do something. Based on the ID or whatever. Typically this is done on both objects involving the collision event. Hey, how do you have 2 windows? 2 windows? Are you referring to me streaming, or are you referring to... Oh, I think... Right, I think it's just a bit of... So this is just... that's just the debug window. This is the console window. It's actually hard to get rid of, believe it or not. It's more difficult to get rid of than the actual game. Like, to ship a game, you have to like do a load of faff to get rid of this thing. But it is useful because it has standard out. Oh, you actually don't know how to do that. Okay, so if you want to do that, make sure that in Visual Studios at least, I don't know how to do this in like VS Code or whatever. But in your main executable directory, you want to make sure that your I always forget where it is, so bear with me. The subsystem is console, at the very least. If your subsystem is Windows, then it won't work, but it still will, in theory. The other thing that triggers it, the console window to pop up, is int main, right? So if I scroll up to main, right, this is giving arguments to another main window. So to actually get rid of that console window in Windows at least, you have to write your own main win function. With just int main, you end up with like this is not the base main function. I think maybe we can see that if I... Okay, so there's external code here, but yeah, the external, I think this automatically launches the window, the console window. Ooh, yeah, let me just no, I can keep going. Why is the music stopped? Again. Alright, so I'll put this on shuffle. Heaven forbid we have to listen to this track again. No, it's one of my favorite tracks, so so it should lead to something in 2 minutes. No, nothing distracts me, honestly. I've got a pretty lateral mind. It's not necessarily a creative mind. Meaning that I can hold like lots of ideas in my head at the same time. It's the opposite of, say, you'll find someone who's like super linear, where you talk over them in like a meeting, and they'll have to like restart their thoughts from scratch, because you've interrupted them. That's like a super linear mind. Not necessarily. It doesn't mean cleverer, by the way. It just means like they often have depth rather than breadth when it comes to their thoughts. So I have a generally more linear mind, which is more breadth rather than depth. So it's fine if you guys want to talk. That's why I'm totally chill. If I need to concentrate, I just will not read chat for a bit. I don't think anyone with a super linear mind could code and stream at the same time. I think that would be very difficult for them. Or they would just not ignore chat completely. It's just quite funny to think about. Alright, so we need some kind of system to get out of. How do I even do this? This is like a whole architectural issue here. Your streams are very helpful. I appreciate that, dude. Yeah, it's really nice having you guys around. Honestly, it's motivating. It's fun. You guys make it worthwhile. So thank you to you too. That's all. Okay, so we need to be able to forward this out, and I think the way of doing this. I'll just have nobody in chat like my streams. Oh, you stream, cool. I'll have to check it out. Hell yeah, I love that dude. I love that Mado. I'm glad everyone's learning stuff and it is valuable. Okay, so what do we want to do here? We want to. Okay, so there's an architectural issue here that I need to think about. So forwarding things out. So I'm going to write some stuff in here, right? So this is stuff we read earlier. So I need to be able to forward forward out objects to run when they are collided with. So they can do something. You cannot. Oops. Go on. You cannot access the body interface here until I think maybe in contact listener. So the contact listener I think is a handler for objects to be forwarded, meaning that our contact listener is going to have some inheritance to it that actually also not just listens for contacts but also forwards them out. So I think that's how we're going to do it. So we're going to have some inheritance here because that's how the Jolt physics library works. We need, okay, so we need some type of ID system. Yeah, basically some kind of like signals that kind of tell us that we've done something. Some kind of ID system, some kind of ID that tells us what entity does. Tell us that we need to do X thing with our entity once we've converted it to an object. So there's some kind of sorting that needs to happen. This, or some kind of selection, I guess, not sorting. This will be some kind of selection algorithm or something. Yeah, something like that anyway. Okay, I'm going to share you. I'm going to type in chat. exclamation mark Discord. Anyone who is watching can join. If the bot replies, or maybe the bot's dead. Okay, there we go. That should be my link to my Discord. It should be still joinable. I don't think I've changed anything. So it's 5 o'clock. That is my deadline. I decided to stream until 5, and I need to give my throat a rest. I've had so much fun, honestly. I very much appreciate everyone who's joined in and commented and kept me company while coding. I honestly expected this stream in particular, because it's going to be a longer one, to have like no one in chat for hours and hours and hours. But no, it was a pleasant surprise that people joined in. So honestly, thank you guys. It's been wonderful. I very much appreciate you all. So yeah, I'm going to end the stream here, and hopefully you guys have a fantastic day, and yeah, crush it and whatever you're doing. Yeah, thanks for anyone who likes and subscribed, and who has already subscribed as well. I should mention that. Yeah, so there we go. Yeah, good luck with your projects, and I'll see you all guys